Over the next 3 hours, I'll teach you everything you need to know about HTML and CSS to build beautiful and responsive websites like the ones you're seeing right now. Today, we'll learn what HTML is and how to set it up as fast as possible. HTML stands for Hypertext Markup Language. It's the standard language that basically builds the structure of every website in the internet. You use HTML to define headings, paragraphs, links, images, and so on. So basically everything you see on a website. To write HTML, all you need is a text editor and a browser. You could basically write HTML code in a regular text editor, but since that is not very efficient, I recommend a code editor which highlights, formats, and indicates errors in the code for you. I recommend installing Visual Studio Code, and in order to do so, we are just going to type Visual Studio Code in Google, and then we click on the first link. And right here, you can basically just click Download for Windows, which will get you to the download windows. Then you're going to wait until you install the entire setup, and once the installation is ready, you're basically going to click on the installer. Then you basically just accept the agreement, you click next, next, install, and then you'll wait until the installation is basically done. And once we're done, we're just going to press finish. Now we can open Visual Studio Code by typing Visual Studio Code into our search bar, for example, or you can obviously just click the shortcut on your desktop. And this will open Visual Studio Code. We can maximize it here. And now we can basically go to the desired destination by pressing File, Open Folder. Now we can, for example, navigate to the desktop, and here we can create a new folder, for example, which can have the name HTML, or the name is basically up to you. And we're going to select that folder. And as you can see, we are now inside of our folder. To create an HTML file, we can now press on the new file icon and give our file a name, like index.html. The .html ending tells the browser that this file is an HTML file. And this is really important if you want to create your websites. It's a convention that you basically always name your root file, so the entry of your website, index.html. We're now going to install two extensions that are really important if you want to work with HTML. The first one is basically called Prettier, which is a code formatter. To install extensions, you are first going to navigate to the extensions tab over here. And right here in the search bar, you can type the name of the extension, which is Prettier in our case. Then we're going to press on Prettier code formatter right here. And we're going to press install. The second extension we're going to get is the live server. Again, we're going to navigate to the live server extension and we're going to press install. Now there's one additional thing we need to do to set up Prettier, so basically our code formatter. We're going to press on File, Preferences, and right here we're going to navigate to Settings. And right here we're going to type in the search bar, we're going to type Format. And right here we can select a default formatter, and it's really important that you select Prettier from the drop-down menu. So we are going to select Prettier code formatter. And the second thing we are going to do is enable format on save. And by enabling this, the code editor will make sure that the file is formatted properly every time we basically save. And you'll see what is going on here in a second. To generate a basic template in our index.html file, we are now going to use an exclamation mark and basically press enter. And this is what the basic HTML template looks like. And now if we press Ctrl S, which basically saves our file, you can see that Prettier formatted our document. To run our website, we are now going to right-click our index.html file and press Open with Live Server. This may take a second, but now you can see we basically opened our file on a website. You could also open your website without the live server by navigating into the folder where you saved your file and double-clicking your index file, for example. We'll open it up in the browser, and you can see we also have our index.html file right here. But the difference between opening the index file manually and opening it with the live server is that the live server will make sure that every time you save your file, all of the changes will be displayed live on the website, which obviously makes development a lot easier since you don't have to reopen your website every time you make a single change. So now you know what HTML is, what it is used for, and how to set up your first project. Today we'll learn the structure of an HTML file. Every HTML file follows the same basic skeleton, and here it is. Doctype HTML tells the browser this is an HTML file. HTML wraps the entire page. Inside head, you put metadata like title, styles, and scripts. Metadata is basically the information about the page that isn't shown directly, like the title, the description, or the character set, for example. Inside the body, you put the visible content of the page. Text, images, links, so basically everything the viewer sees in the end. Think of it like this. The head includes all of the information, while the body is what you actually see. So that's the basic structure of every HTML file. Today, we learn what the head in HTML is. The head is a place where you put information about your page that isn't directly shown to the user. This includes the title, the character set, and instructions for the browser. Here are the most important tags that you use in almost every website. The title tag sets the text in the browser tab. Meta name viewport makes the page responsive for mobile. So this is basically important to make the website look good on pretty much all devices. Meta charset UTF-8 tells the browser to use UTF-8 character encoding, which supports most languages and symbols. Computers only work with numbers, specifically with zeros and ones. A character set is needed to translate those numbers into letters and those letters into numbers, symbols, or emojis. UTF-8 is the standard today because it supports almost every language and almost every character. Those were the tags you basically need on every single website. So let's take a look at some important ones you will use pretty often. The link tag is used to connect your CSS files to your HTML file. Meta name description is important to create a description for your website and is basically the description that shows up in the Google search results. Meta name author defines the author of the page. The script tag is used to load your JavaScript files after HTML is parsed. So let's take a look at the head inside of Visual Studio Code. First of all, we can create a basic template again by using the exclamation mark and pressing enter. We're going to open the website with the live server again. And at the moment, if you take a look at the top right here, you can see that we have the text document over here. By changing the title, for example, to test title and pressing save, we can change the title on our website. And as you can see, right on the top here, we have test title now. We also have the meta tag that basically defines the char set, and we have the meta tag that defines the viewport and makes our website responsive, so that it basically looks good on mobile and pretty much every device you use. If we type meta followed by a colon, we can see the different meta tags we can use. And for example, you have UTF-8 right here. So if we just press enter, we are basically gonna generate a basic UTF-8 meta tag. We can also use meta colon description, which is basically a tag used to create a description for your website. So we can just create a basic description here by, for example, typing this is a basic description for our website, like this. We could, for example, link a style sheet by using the link tag followed by a colon and CSS, basically selecting that one from the drop-down menu, and now we collected a style sheet with the name style.css. Since we don't have the style sheet at the moment, this is not going to work. But if you want to link a CSS file to your HTML page, this would be the way to do it. And you don't have to understand what CSS is at the moment, but this is really an important concept when you really work with HTML and CSS. If you want to add an author, we can basically use the meta tag again, give it the name equals author, and then we can add the content attribute and say that the author equals Pascal, for example. Then we close the tag, and by doing so, we basically added an author to our website. You can also use the script tag to link a JavaScript file to your HTML page. You don't really need to know what JavaScript is at the moment, but just keep in mind that this is really an important concept, and you usually use a lot of JavaScript with HTML when creating a web page. To link a JavaScript file, you can basically type script :source, and by pressing enter, you'll basically have the basic template. Now you can basically define a source that could, for example, be an app.js file. We don't have this file at the moment, but we could create one by typing app.js here, for example. And now we link this app.js file to our index.html file. If we define the script tag in the head, it's important to add the defer attribute. Those were the most important things you need to know about the head in HTML. What is the body in HTML? The body is the part of an HTML page that actually shows up in the browser. Every visible element, text, images, links, buttons, forms, and so on goes inside of the body. Let's take a look at the basic structure of a body inside of HTML. If I type something inside of the body, it will show up on the web page. If we type in hello guys, for example, and save the web page, you can see it. It's displaying right here on the page. Obviously, you can display all types of elements on our website. Headings work, for example. Paragraphs work as well. Of course, you can also add links that navigate you to a different website or an image. Obviously, you don't need to know all of these tags yet, but this is basically how the body works inside of HTML. Today, we learn what HTML tags are. HTML is made of tags. A tag tells the browser what kind of element something is, like text, a heading, an image, or a link. Most tags come in pairs, an opening tag and a closing tag. The opening tag looks like this, while the closing tag looks like this. Everything in between is the content. Some tags are self-closing, which means that you close the tag within itself. This is indicated by a backslash at the end of the opening tag. If an element needs content like text inside, it's usually not self-closing. If the element just stands alone, like defining the char set for example, it's usually self-closing. Hope you understand tags now. Today, we learn what attributes are in HTML. Attributes give extra information about an element. They always go inside the opening tag. Let's take a look at an example. Right here, source tells the browser where the image file is, for example. Alt gives an alternative text if the image can't be loaded. Rule of thumb, tags define what an element is. Attributes define details about it. And this is what attributes in HTML are. Today, we'll learn headings and text in HTML. Headings go from H1 to H6, and they define titles or subtitles on a page. Let's take a look at it in VS Code. By using an opening tag for the H1 tag and a closing tag for the H1 tag, and writing something in between, we generate a title. And the title could, for example, be all you need to know about cameras. And once we save, we see we have an H1 title on the top of our page. Usually every website should only have one single H1 title, which basically represents the title of the entire page. You could also add an H2, which is basically a subtitle on your page. Let's add an H2 with the text my favorite cameras. And once we save it, you can see the H2 popping up right below our H1. As you can see, the H2 is slightly smaller than the H1, and you can have as many H2 tags as you want. We could add a second H2 right here, for example, saying the most expensive cameras. If we further want to divide the H2, we can use the H3 to create several subtitles for the H2 subtitle. We could, for example, say that the first subtitle is the Sony A7300. Then we save it and you see we have a third subtitle, which basically is right below my favorite cameras. Now we might have several cameras, so we can duplicate the subtitle by pressing Shift, Alt and the down arrow. And by doing so, we can, for example, duplicate it twice. Now we could maybe add the Fujifilm X-T3 and probably the Sony camcorder. And now we have three subtitles showing three different cameras. We could obviously further divide our page into H4. This is an H4. And we could further divide our H4s into H5s, of course. And finally, we could add an H6 to further divide our H5s into H6. This is an H6. You don't really use H1 to H6 for styling purposes, but to really tell the Google search engine how your website is basically structured. So your H1 should always be the title of your website and the most important, most descriptive thing to describe your website. Your H2 is then usually used to subdivide your website into subsections. H3 is used to subdivide your H2s into further subsections, the way I did it right here. And then H4, H5 and H6 obviously further to subdivide the previous title. Paragraphs, on the other hand, are written within the P tag and they're used to display blocks of text on the page. So headings basically give structure, paragraphs give content. So if we take a look at our page inside of Visual Studio Code, we would, for example, write a short paragraph about every single camera. So basically about the Sony A7300, the Fujifilm X-T3 and the Sony camcorder. So we can basically generate a paragraph by using a P tag, an opening and a closing P tag. And inside of these P tags, we basically have the text we want to display. So this could be a basic text like this, or we could also obviously use a longer text. We can create a placeholder text, for example, right here, just for demonstration. by writing lorem and then the amount of words we want to use as a placeholder text. In our case, we want to use 30 words, for example. So we'd write lorem 30, we'll press enter, and it will generate 30 words, as you can see. And now we have our paragraph below the Sony heading. Obviously, we can use multiple paragraphs on our website. So we could, for example, add a paragraph below the Fujifilm X-T3. We could add a paragraph below the Sony camcorder and so on. And by doing so, we have headings and paragraphs right now to give our website structure and content. Today, we learn all about lists in HTML. There are two main types of lists, ordered lists and unordered lists. An unordered list uses the UL tag. Each item inside of an unordered list goes inside of an LI tag. An ordered list uses the OL tag and numbers the items automatically. Here, items also go inside of an LI tag. If you need a specific order, like step 1, step 2, use an ordered list. If the order doesn't matter, like a list of ingredients, use an unordered list. So let's take a look at that inside of Visual Studio Code. First of all, we are going to start by creating an unordered list. We can do so by using the UL tag, by basically using an opening and a closing tag for the unordered list. Now we will use the LI tag to create different list items. So we can basically do so by using the LI tag, and inside of the LI tag we are basically going to use some text like this is the first item. Now we can duplicate this item 2 times, for example, and create a second item and a third item. Once we save, we can basically see those bullet points, and we have our first item, we have our second item, and we have our third item. And as you can see, you could basically add as many items as you want to. Now let's take a look at the ordered list by using an OL tag for ordered list, and again using LI to create different list items again. This could, for example, be the first ordered list item, and now we'll save our website, and as you can see, we have a 1 right here, and now it basically says this is the first ordered list item. Now we can duplicate this item again, and as you see, it now basically enumerates every single item. So you have a first item, you have a second bullet point, and a third bullet point. And we could, for example, rename this to second and third, but it doesn't really matter too much. I'm sure you basically understand the difference between ordered and unordered lists now. Every time the order of the list matters, you basically use an OL tag, and otherwise you use an UL tag. This is basically all you need to know about ordered lists and unordered lists. Today we learn what links in HTML are. Links are created within the A tag, which stands for anchor. So let's take a look at it inside of Visual Studio Code. We can create a link by using the A tag and pressing enter. As you can see, it automatically creates this href tag, which basically defines the location we are going to get once we click the link. So we could, for example, go to google.com, for example. We can copy this link and paste this link into this href tag. As you can see, it takes the full link. If we go back to our website, you basically can't see anything. So we basically need something to press on our link. So we'll add a text right here, which could basically say go to Google. Now we save our website, and now we have this link here which says go to Google. If you click this link right now, we will be redirected to Google, as you can see, but we basically want to go back. And now imagine you want to open this link in a new tab once clicking on it. And you can do so by using the target attribute, as you can see, which is equal to underline blank. And by adding target equals underline blank, you will redirect the user inside of another tab basically. So once we click on to go to Google right now, it will open a new tab, as you can see right here, and then it will redirect the user inside of the new tab to Google. And as you can see, our website is still open right now. And if we click 3 times on this link, for example, it will open 3 different tabs. If you want to navigate the user to another HTML tag, you could create a second HTML page here, for example, which could, for example, be our contact page. So we are going to name it contact.html. Now we're going to generate a basic template on this page as well. And we're just going to say contact right here, for example. And now we could, for example, generate a second anchor tag. And inside of this anchor tag, we are going to say go to contact page, we're going to save, but as you can see, if we click this link now, it basically doesn't do anything because we didn't use an href here. To navigate to another HTML page inside of the same folder, we can use the hashtag, and then we are basically just going to type the name of the page, which is contact.html. And if we want to navigate to the contact.html, we basically just have to type the name of the page, which is inside of the same folder right here, and press enter. And now by clicking on go to contact page, we will open the contact page, as you can see. And now we landed on the contact page. Obviously, we could also add the target equals underline blank attribute as well here. And if we click go to contact page, we will open a new tab now, and we will open the contact page inside of a new tab. So this is all you need to know about the anchor tag in HTML. Today, we learn about images in HTML. Images are added within the image tag. It's a self-closing tag, which means it doesn't need a closing partner. So let's take a look at it inside of VS Code. First of all, we can create an image by using the image tag. The image tag looks like this, and it has two attributes, the source attribute and the alt attribute. The source attribute is basically used to define the location of the image, while the alt attribute is used to create a fallback text in case the image can't be loaded. And it is also used for search engines to understand your content, and in case you have visually impaired users, the screen reader will basically read out the alt text. So the alt text is pretty important as well. Now let's get an image to use on our website. We can, for example, use Unsplash or download it pretty much anywhere online. We could, for example, display this image. Then we are going to press download for free. We are going to take the image once it has been downloaded, and we're going to drag it right into our folder in VS Code. So we're basically going to go here, we're going to drag it into our folder. The name is kind of weird right now, so we're going to rename the image to my image, for example. The name doesn't really matter though. And now we can basically use the source attribute to define the path to our image. And right now, the image is basically in the same folder, so we're just going to enter or just going to write the name inside of the source attribute by defining my-image.jpg. And now if we save our website, it should basically already display our image. Obviously the image is way too big, but we could change it, for example, by using the width attribute and, for example, putting this to, for example, 100 pixels or 500 pixels or whatever. But usually it's obviously not recommended to use HTML attributes for styling, and you usually use CSS for this. I just wanted to show you that this is basically the image and that you can also use the width attribute to basically rescale the image, but this is not the recommended way. And as I already mentioned, it's also important to use an alt text, so we could basically say that we have some glasses on a chair. And now, in case the image can't be loaded, we will basically have this fallback text, or if a screen reader would read out our website, it would basically read out this alt text. So this is basically all you need to know about images in HTML. Today we learn about divs and spans in HTML. Not every element in HTML has a meaning. Some are just containers. For example, div is a block level container and span is an inline container. They basically don't describe what's inside, they just group elements. Think of a classroom. The pupils inside are the elements, they're the actual content. The classroom itself is just a container grouping all those pupils together and separating one class from another. That's what a container like a div does in HTML. It doesn't have meaning by itself, but it groups elements so it can organize or style them as one unit. You can create a div by typing div, then closing a bracket, and you have an opening and a closing tag for a div. And everything inside of this div basically belongs to this div container. We can now, for example, write something inside of the div, like here is some text, and you'll see the text on the website. But this text is inside of a div right now. And we can take a look at this div inside of the inspector, which we can basically open by right-clicking the page and inspect. And those are basically developer tools. So if you basically hover over the body, it highlights basically everything that belongs to the body element. Now you can expand the body and see what is basically inside of the body. And as you can see, we have our div inside of the body right here. And now if we make our website a little bit bigger and we hover over the body, we see that basically the div is our body, so this is the entire body. Now if we hover over the div, it basically highlights the entire div, and as you can see, our div goes from left to right, so it basically takes up the entire available space. So everything from left to right. Now I want to show you a second container element, which is basically the span. And we're going to create it pretty similar to the div. The only difference is basically that the name is span. Now we can also like write something inside of the span, like here is some span text. And now we save our website and this basically reloads our website. So now if we hover over the body, it basically marks everything. So it marks our div and our span. And the reason for this is that our div and our span are basically child elements of our body. So our div and our span are inside of our body. Now we can expand our body. And if we hover over our div, it basically marks our div. And if we hover over our span, it marks our span. As you can see, our div takes up all the available space from left to right. If you see it right here, everything that is blue is basically our div. If we hover over our span, you can basically see that our span takes up the minimal available space. So it just takes up the space that is necessary to display the text. So we could, for example, create a second div element right here and say, here is a second div, and we'll save our website. And as you can see, it will display our second div below our first div. And the reason for this is that our first div takes up all the available space. We create a second div, and the second div takes up all the available space. So it obviously needs to display the second div inside of a new row because there's no space available in the first row. But if we create a second span, for example, by using the span tag again and saying here is a second span, it can display the second span right next to the first span because the first span just takes up the minimal space necessary to display the text. So there's a lot of space available right next to the first span. And basically a div is called a block level element because it is basically displayed as a block that takes up all the available space. And span is basically called an inline element because you can basically display multiple spans in line, in one single line, because they take up the minimal necessary space to display the content inside. Both of them are basically containers, just with a different purpose. And that is all you need to know about divs and spans. Today we'll learn about HTML hierarchies. HTML is structured like a family tree. Elements can contain other elements. An element that wraps another one is the parent, and the one inside is the child. This parent-child relationship is what creates the structure of every web page. So let's take a look at it inside of VS Code. First of all, we have our HTML tag that basically wraps the entire web page. So this is basically the parent element of every element inside. Now we have the head and the body, which are both direct childs to our HTML tag. If we create a new element inside of our body, we create a child to the body element. So we can, for example, create a div inside of our body, and now this div is a child of this body tag, and this body tag is a child of this HTML tag again. If we, for example, create a paragraph inside of our div, which contains some text, for example, and we save our web page, then this paragraph is a child of this div. So this div is basically the parent of this paragraph, and this paragraph is the child of this div. This div again is the child of this body, and this body again is the child of this HTML tag. Now we can create a second paragraph, and now we have one child of this div, and we have another child of this div. And now we can take a look at this inside of the inspector by right-clicking and pressing inspect. And as you can see the structure, the tree structure of this HTML document. If we hover over the HTML tag, you can see that it marks basically everything that contains to this HTML tag. So basically everything. But if we hover over the body tag, it basically highlights almost everything again, because the body includes basically all of the information, because the body is basically a parent element to pretty much all of the content. If we hover over the div tag, again, it highlights both p tags, because both of these p tags are direct children of this div. And now if we hover over the paragraph, it basically highlights the first paragraph. If we hover over the second paragraph, it basically highlights the second paragraph. Under developer tools in the element section, you can really good visualize the tree structure of every HTML document. By pressing this arrow and opening the body, you basically see all of the children of the body element. By opening the div, you basically see all of the children of the div element, and so on. And understanding this structure is really important when working with HTML. Today, we learn all you need to know about semantic HTML. Usually, The basic template of a web page consists of a header, a main section, and a footer. The header usually contains the head content of your website, so basically navigation bar like the nav bar. And for example, if you take a look at a company website, you oftentimes have a video or an image on the top that basically shows what the company is doing, for example. And that usually belongs in the header as well. The main section usually contains the main content, so the main information that you want to share with the user. So that could be, if you think about a blog post, that could be the blog post, for example. And then finally you have a footer on pretty much every website that includes basic information like the contact us information, a phone number, a street, a city, and so on. So all of that basically goes into the footer. Now you can further subdivide these sections with certain elements, and I'm going to introduce you to those elements. The first element that is pretty important is the nav element, which, as the name already implies, basically is the nav bar or wraps the nav bar. Inside of this nav element, we could, for example, create a nav bar now by using an unordered list, then a list item, and now inside of this list item we can create a link that, for example, points to our home page, which could be our index.html. So basically this page. Let's say that is our home page, and now we can copy this link tags and create two more nav elements, and let's say the second one goes to an about us page and the third link goes to a contact page. Obviously we didn't create those pages yet. We have a contact page, so we can create that one, but we don't have an about us page. But usually you could obviously add an about us page as well, and then this link would redirect to the about us page, and this link would redirect to the contact page. So this is basically a nav bar, and usually the nav bar goes inside of the header. Now when it comes to the main content, if you think about like a website that basically introduces the user to cameras, for example, you could use a section, and a section is used to group related content inside of the main area. So let's imagine we have a section right here, and inside of the section we have an h2, for example, that says my favorite cameras. So this section basically groups all of my favorite cameras. So we could actually also create a second section, and this second section could, for example, include the worst cameras. So now I have one group for my favorite cameras, and now I have another group for the worst cameras, in my opinion. And in this group I could, for example, list all of my favorite cameras. So every camera should basically go inside of an article, because an article is a self-contained piece of content, like a blog post or a post about a camera, for example. A post about one single camera or information about one single camera goes inside of an article, because it is basically a short article about one single camera, and those articles all together make up one section, because all of those articles, all of those single cameras are part of my favorite cameras. Hope that was a good explanation. So I could go here and create an article tag to group one article, and right here I could use an h3 tag, for example, and say my first favorite cameras, maybe the Fujifilm X-T3, for example. Then I could like create a short paragraph including maybe 30 words, and now I have an article that includes my first favorite camera, which is the Fujifilm X-T3, and I have a little bit of text about it. So I could go here and take this article and create a second article inside of my section, because I obviously have more than one favorite camera. So I could also have the Sony camcorder as another camera that I really like. So now I have two cameras inside of my favorite camera section, and both of these cameras go inside of an article. Now I could obviously go here and take this article and paste this article into my section, second section as well. I could change maybe the names, so this could be the XT4, for example, and yeah, this could be whatever. It doesn't really matter. I hope you get the idea. And now you might also want to give the user the possibility to buy this camera on Amazon, for example. Maybe you're an affiliate and you want to make some money by redirecting the user to Amazon, whatsoever, it doesn't really matter. But the link does not really contain to the content, if you want to say, because the link is like not really any information that the user needs, and the information also does not really belong to the content. So it's more or less something that is aside from the content. So here you can use the aside tag because this is like side information, like sidebar or related links, as you can see. So we can use the aside tag right here, and inside of this aside tag we can, for example, create a link, and this link redirects wherever, and in our case we say get the Fujifilm X-T3, for example. And now we have a link right here where we could click basically on, maybe get redirected to Amazon or wherever, and buy the Fujifilm X-T3. So this is basically the purpose of the aside tag. Now let's get to the footer, which is usually on the bottom of your web page and usually contains links to, for example, a contact form, or includes copyright information or a phone number whatsoever. So we could, for example, create a paragraph here, say add copyright 2K25, then we could add a phone number, say phone : +49176, doesn't really matter, and so on. So we can like create content that basically usually goes in the footer, that does not really belong to the main content and does also not belong into the header. So basically just some side information that some people might need, but content that does not really belong to the main content and is not really necessary for the purpose of the page, to be honest. And this is the basic structure of every web page if you work with HTML. Let's learn about inputs in HTML. The first input I want to show you is the text input. You can create an input by using the input element, and then you can use the type attribute to define a certain type. And as you can see, we have a lot of different types right here. And to create a text input field, we basically select the text input type. And once we save, we basically have our input field right here where we can type basic text. If you want to indicate what the input is used for, you can use a placeholder to show the user a certain text, like username, for example. And now once we save the website, we see that the user basically sees username right here. So this indicates to the user that this field is probably used to create a username. So I could, for example, create my username right here now. For a lot of inputs, you also want to use an ID field like username and a name field like username. Those two attributes are especially important when you work with JavaScript and CSS. Creating a password works pretty similar by creating an input field and using a type of password. As you can see, if we type something inside of the password field, it is now hidden. Again, we can use the placeholder field as well here, and those attributes work pretty much for most input fields. A tip if you work inside of Visual Studio Code is that you can basically type the name of the tag, which is input, followed by a colon, and then the type of the input field you want to use. Let's say we want to use an email input field. By using :email and pressing enter, you basically auto-generate a basic template for an email field. Now you could enter a name, which could be email, and an ID, which could be email, for example. Once we save, we have an input field for our email, which could be heyo@gmail.com. To create an input field for a number, we can create an input field again with the type of number. And for the number input field, we can also define a min value, which could be 0, and a max value, which could be 100, for example. And as you can see, if we type like 90 inside of this input field and we are like going upwards, we can just go up to 100. And the same obviously goes in the opposite direction. To create a checkbox, we can again create an input field of type checkbox. And we can, for example, give the checkbox a name of is broke and an ID of is broke. And once we save, we basically have our checkbox right here, which we can check and uncheck. The checkbox also has a checked attribute, and once we save, you can see our checkbox is checked. And if we uncheck it and save our file, our checkbox is basically checked again. So this checked attribute basically makes sure that the website, once it loads, has a checkbox that is already checked. Radio buttons are pretty similar to a checkbox, but it's probably easier to understand if I just show it to you. Like this, we have a radio button, and we can, for example, create 3 different radio buttons right here, and we can check every single radio button. But if we use the same name for each radio button, like has pants, and now we just copy this name and paste it into all of the 3 radio buttons, we can check one radio button, we can try to check the second one, but as you can see, Once we check the first radio button, it unchecks the second radio button. So this name attribute basically allows you to connect different radio buttons and makes sure that you are just able to select one single radio button. And this is really good if you want to make sure that the user has to choose between different options, for example, and is just able to choose one single option. To create an input field that allows the user to select the date, we can use the date type. And once we save, we basically have this date picker where the user can open a date form, if you want to say it like that, and select a desired date, for example. You can also give the user the option to upload a file by using the file input field. And once you save the code and update your HTML file, you have the option to choose a file from here. And this gives you the option to upload an image, for example, or whatever. Usually when working with input fields, you use them inside of a form most of the time, and every form needs to have the option to submit the form to a server, for example. So if you think about Facebook, you type in your username, you type in your password, and then you press a button. And this button allows you to register, to log in, whatsoever. And this button is basically the submit button. So this button tells the browser to submit the form to a server. And to create this button, you can use an input field as well, because in the end, a button press is just an input that the user gives. And you can create that input field by using input:submit. And this will create an input field of type submit. And you can create a value, which could be register, for example. The value is just the text of the button. And if you click register, you would submit the form to a server if all of this was inside of a form, which it isn't right now, but usually you use this input field inside of a form to submit a form. And something that you use oftentimes in combination with the input fields is the label. And the label allows you to create a text that is connected to a certain input field. So imagine we have an input of type text that allows you to type in a gamer tag, for example. So you have this input field that allows you to type in a gamer tag, and now you want to create a label, and this label should be connected to this gamer tag. So we can, for example, write a text inside of this label, which could also be write your gamer tag, for example, or write your username, whatsoever. And once we click this text, nothing is going to happen because this label is not yet connected to our gamer tag input field. And to connect your label to your input field, you need to create an ID. And that ID can, for example, be gamer tag or whatsoever. The ID is something you can choose as you want. The only important thing is that this for tag matches the ID of the input field you want to connect your label to. So in our case, it has to be gamer tag as well. And once we save, we can now click our label basically, and it will highlight or select our input field, and we can just write inside of our input field without having to select the input field separately. And this is all you need to know about inputs in HTML. Today, we learn all you need to know about HTML forms. You can create an HTML form by using the form tag. You have an opening and a closing tag, and the form usually an important attributes when working with forms is the action attribute and the method attribute. The action is really important when working with a server or PHP, for example. So the action attribute basically tells where to send this form. So if you basically have a PHP script, you tell that this form will basically be sent to this PHP script, and then this PHP script, for example, would define how to work with the form data. So this is not that important for us right now, but it's important to know once you start working with a server. The method basically defines how you send the data you send via this form. And there are basically two ways to send your data. You can use the get method or you can use the post method. If you use the get method right here, your data will basically be appended to your URL and everyone can see it. And if you imagine you have a form with, for example, a username and a password, and you append this username and the password to your URL, it's probably not the best idea because this would definitely not be secure. And if anyone would read out your URL or stuff like that, he would be able to get access to your username and your password, which obviously isn't something you want to do. So if you want to use a secure way to send your data, you always use the post method. And by using the post method, your data which you send to the server is basically encrypted. So if you have important data like a credit card number, a password, whatsoever, always make sure to use the post method. When do you even use the get method? method. So the get method is really good if you have like websites where you have parameters like the colors of shoes and so on. So imagine you're browsing on an online store website and there are different colors. You could basically take the color the user selected, save that color in the URL, for example. The user can copy the link, for example, and if he uses the same link to get to the same website later on, he has already pre-selected the certain color. So the get method is really useful if you want to bookmark a page, for example, and pre-select certain filters, for example. Inside of this form, you can use as many input fields as you want. We can, for example, use a text input field that could have the name username and the ID of username. Let's take a placeholder of username and say that this input field basically receives the username. Now let's add a second input field that, for example, takes a password as well. We add a name of password and an ID of password again, and a placeholder of password, for example. So now we accept a username and a password. Imagine this is a register form. You will obviously also need a button to submit this register form, so the username and the password, to a server, for example. And we can create this submit button by using an input field of type submit. And now we can create a value, which could, for example, be register. And once we save, we have this register button right here. And this value is basically the text that you see over here. And every time you use a form where you want to submit data to a server, for example, you need an input field of type submit, or a button that basically submits your data to the server. And once you have this submit button, and once I click on this register button, but since we didn't really define a location to submit this file to, we are basically getting this error page. And as I already mentioned, you'll usually have a PHP file, for example, where you redirect to. So we could, for example, say, okay, we get to the index.php file, for example, once we submit this form. And now we can like reload this, but obviously we don't have this index.php file, so we get an error. But this is basically the way forms work in HTML. As you can see, if we use the get method right here, and we type in a username like hello and a password of monkey, and then we press register, you can see that we basically have this URL now, which has a username, which equals hello, and a password, which equals monkey. And imagine you have a friend and you want to share a link with him, and you basically just copy this, and you have your password and your username basically saved in here. You send it to your friend would see your password and your username, which would obviously be like really risky, not a secure site, and nothing you ever want to do. So in this case, you could, as I mentioned, use the post method. And now if we use the post method right here and we type in a username and a password and press register, there's nothing saved inside of our URL. Inside of a form, you can use the field set tag to group certain elements to a logical group, basically. So we can, for example, copy this, use the field set tag, and inside of this field set tag, we'll save our username and our password. Now let's go to the bottom and we'll reload our page. And as you can see, we basically have this group of username and password right now. We could, for example, create a second field set, and we could say that we'll add an input of type text right here, and we'll accept a gamer tag right here with an ID of gamer tag again, and a placeholder of gamer tag, for example. And now we have this second field, so this second group basically, that could, for example, group game related information. And by doing so, you can basically create different subgroups inside of a form. Inside of this field set, you can use a legend if you want to do so. And inside of this legend, you could create a description for this group. So this could, for example, be gamer information, if you want to say so. And now you have this gamer information inserted into this group, and you could create a second legend for your general user information, for example, and name this user information. So now you would basically have two groups, one group that contains all of the user information and one group that contains all of the gamer information inside of one form. Now I want to go over certain attributes that are really important when working with forms, and one of them is basically the placeholder. We've already seen the placeholder just gives you a hint text basically that shows you what this input field is used for. You can also add the required field. If you add the required field to your form and press register now, it will give you a warning saying that you have to fill out this field. By using the value attribute for a field, you can create a predefined value that will show up to the user once he loads the page. So you could, for example, say I am a user. And once I load the page, you can see that our username field is basically pre-populated with the value. If we create a check mark, for example, so a checkbox by using input checkbox, we have the checked attribute, which says that the field should basically be checked once the page is loaded. So once the user gets on the page, the checkbox is already checked when using the checked attribute. And this is all you need to know to understand forms in HTML. Today we'll understand the text area in HTML. To create a text area, you can use the text area tag. Feel free to create a name attribute and an ID attribute. In our case, we'll use message for the name and for the ID. You can also have a placeholder text for every text area, which could say message, for example, as well. In addition to that, you can define the number of columns for every row. So we could, for example, say that we want 50 columns for every single row. And as you can see, our message field gets a little bit wider now. Now we can also define the number of rows by using the rows attribute, and we could, for example, say that we want to use 10 rows in total for our text area. In addition, we can define a max length to define the maximum number of characters the user can enter into this input field, basically. So if we say 10 characters is our max length, for example, we can, for example, type numbers from 1 to 9, and the 11th number will not work anymore, as you can see. If we create a longer text input field by using a max length of 100, for example, we can now save that file and we can type in a lot more characters if we want to. And this is all you need to know about the text area in HTML. Today we learn how to do a drop-down menu in HTML. To create a drop-down menu, we use the select tag, and now we can fill out the name and the ID attribute for the select element. Imagine we want to have a list of fruits, for example. Then we can use fruits for the name attribute, for example, and fruits for the ID attribute, for example. And now to create different subgroups inside of the select element, we could create an opt group by using the opt group tag, and inside of this opt group tag we can create different selectable elements by using the option tag. And inside of this option tag we can choose a value like banana, for example, and then we can decide what text the user should basically see once he opens the drop-down menu. And in our case we want to display banana to the user, and once we save our website we can already see that we have this drop-down menu which only has one single item, which is a banana basically right now. So imagine we want to have maybe a second item inside of this option group. Then we can create a second option tag, and maybe we can use the name apple for this one, and we want to create an apple option. And once we save, we now have the banana option and the apple option. Now we might have a second option group which maybe includes different elements, like let's say we want to have melons inside of the second option group. So we can say we have a honey melon, which is the value basically, and we use honey melon for the text. And now we have two option groups, as you can see here, one for the banana and the apple, and the second one for the honey melon. And as you can see, they are separated within the drop-down menu. Now we could, for example, create a second melon type like the watermelon by doing so. And now we replace the honey with the watermelon. And once we save our web page, we now have the watermelon as well. And this is all you need to know about the select statement in HTML. Let's learn all you need to know about buttons in HTML. You can create a button by using the button tag. Inside of the button tag, you can define the text that you want to display on the button. So it could be, for example, a register button. Now you can click this button, but nothing is happening right now. To define a certain type for a button, you use the type attribute, and now you can, for example, create a button of type button, a button of type reset, or a button of type submit. So let's create a button of type submit in this case. To really use the submit button, you have to use this button inside of the form. So let's do that. We're going to create a form by using the form tag, and we will use the get method in this case, but this doesn't really matter in our case. So let's take the button and put it inside of our form. And once we click on the submit button inside of the form, we will submit our form. And now you will see the difference. Once we click the button, you can see that it reloads the document right on the top. And if we define an action attribute that basically tells our form where to send the data, and now pressing the button, it basically redirects us to our index.php, which does not exist on our page, but as you can see, the form is basically working. We could also create a button of type reset, for example. And if we click this button right now and rename it to reset, you can see that basically nothing is happening because we don't have any input elements in our form yet. But we could change it by creating a text element, for example, and say that this is the text element for a username. So we give it a placeholder text of type or of username as well. And now we can basically enter some text right here. And if we press the reset button, it will reset the entire values inside of our form. You can also execute a JavaScript function by using the onClick attribute inside of HTML. But this will be further discussed inside of my JavaScript course. So this is all you need to know about buttons in HTML. To create a video in HTML, we can use the video tag. The video tag has a source attribute that allows you to define the location of your video. So first of all, we obviously need to get a video. So to get a video, we go to Pexels, and on the website, we can basically select videos. With 13 videos here, we are just going to download the first one. Doesn't really matter which one though, since we are just going to test this. We press the download button, and once the video is downloaded, we can take the video and drag it into our folder. We can now rename it to make it easier to get the path, basically. We can, for example, say this is a street.mp4. Now we close this video. We could also preview the video right here if we wanted to. And inside of our HTML file, we have to define the path to our video. So we could either go and copy the path, or we could just type in street.mp4 since we are in the same folder right now. And once we do so, we should already be able to see the video on our web page. So you basically see it's as easy as that to embed a video, but like this, it obviously doesn't make too much sense because the video is too big. The user can't really play the video because you see it right now, it's just an image, and so on. So the first thing we can add is basically the controls attribute, which would add some controls to the video. So now the user could press the play and the pause button. Since we might not like the width of the video, we could also add the width attribute and say that we want to use 500 pixels, for example. So as you can see, the video is a lot smaller right now. We could also define a height, but this doesn't make too much sense in my opinion, because the height usually automatically adapts to the width, and by changing the height, you would basically destroy the aspect ratio. If you would, for example, say that the height is, for example, 700, you can see that this looks pretty weird. But yeah, I just want to make sure that you know that this would work as well. Now, if we load the website, the video is basically not playing at all. So the user first has to click on the play button, and then he can click on the pause button, which might be the way you want it to be. But sometimes you might want to use the autoplay option to immediately start to play the video once the user lands on the page. And as you can see, now the video immediately starts. And this oftentimes happens if you think about the website when you have like a header on the top without the controls attribute. And now once the user lands on the page, he basically has a video that is basically the header and, for example, shows what a company is doing and so on. So yeah, that might be a use case where autoplay might be really useful. We could also add the loop attribute, which just makes the video loop. So if we go to the end of the video, for example, and we'll wait until it's over, it basically just restarts again. We could add the muted attribute if you want to mute the video, but since this video does not have any sound anyways, this doesn't really matter. But once we remove the muted attribute, you can see that we have this speaker right here, and once we add the muted attribute, you can see that we have this muted speaker right here. You could also create a poster, so basically a thumbnail, a preview image, however you want to call it, by using the poster attribute, and now define the poster you want to use. And we have this image basically inside of our folder that has the name image.png. So we could basically use that as a preview image. And now if I'm going to remove the autoplay, we should just see our preview poster basically, which yeah, looks terrible in this case, but this is something you could basically do. I'm going to remove it because I prefer the normal way. So the last attribute that I want to show you that you'll probably not use that often is the preload attribute, but you have 3 different options for preloading your video, which basically means once the user gets on the page, how should the browser load the video. If you use auto, the browser will automatically decide whether he preloads the video or whether he does not preload the video. If you use metadata, the browser will just preload metadata for the video. And if you choose none, the browser will basically not preload anything. And if you preload data, this basically means that once the user gets to the video is preloaded to a certain extent already, and this obviously means that the user will be able to see the video faster, but this also means that the user will use more data to load this video. If your website is mainly being displayed on a phone, you can imagine that this would take a lot of mobile data to preload the videos, and in that case it might not make too much sense to get the browser to preload the video. But in our case, we just put this to auto, for example, and yeah. And this is all you need to know about videos in HTML. Today, we learn about absolute and relative paths in HTML. First of all, to understand what a path is, we use the image tag because this really gives us the chance to understand them. And if I'm in the index.html file right now, I need to define the path to my image.png to display an image. So I can, in this case, just say, okay, the image is in the image folder and this will display the image basically. Now, what would happen if I would actually create a new folder and say that this is my images folder and I'll drag my image inside of the images folder. Now I have this image in the images folder and now we are not seeing the image anymore because the image tag can't find the image at this location. So we need to define a location. And if you think about a website, it's basically structured like a normal folder on your PC. And you can navigate within your folder, you can go into a folder, you can go backwards and so on. And you can do the same when writing code, but it looks a little bit different. So just think about a normal folder, but you have to navigate through the folder with code basically. It makes it a lot easier if you just think about this in terms of normal folders. Now, if we want to get our image, previously our image tag was in the same folder as our index.html, so the file we are basically editing right now. So if the image is in the same folder like the index.html or the file you're editing at this time, you can just use the name of the file, because it's obviously in the same folder, so you can just say image.png, but it's not in the same folder. So how do we get into the folder? As you already saw, we can just type images, because that is the path to our images folder. And by going into images, or by writing images / we go into our images folder. And now that we are inside of our images folder, we can see all of the content that is inside of our images folder. So we can basically select our image.png. And by doing so, you'll see we have the image right here again. But what would actually happen if we would create a new folder that says, for example, HTML files. And now I'll drag my index.html into my HTML files folder. Now, to get to my images folder, I first of all need to get back up into my HTML folder. And then from the HTML folder, I need to get into my images folder. And here inside of my images folder, I need to select my image.png. So I'm inside of the HTML files folder right now because I'm inside of my index.html. So I go one step up and then I go into the images folder. And I can go one step up by using .. And by doing so, we now went one folder up, so one step up. Now we are inside of the HTML folder. Inside of the HTML folder, I can now select my images folder by using images /. And by doing so, I go into the images folder again. Now that I'm inside of the images folder, I can select my image.png file. And by doing so, we should see our image.png, but we are actually not, because we didn't open our index.html with the live server at the right location. But as you can see, once we reopen with the live server, it now has the right location as well, right here, because now our index.html is inside of HTML files / index.html. So we needed to reopen that file, and now it displays our image once again. Now the thing that I explained to you is a relative path, because we are thinking in a way that is relative to the folder we are working in right now. So the path we defined here is relative to our index.html file, so the file we are working on right now. There also exists the option to define an absolute path. Now let's define an absolute path. If we use an absolute path, we always think as if we start from the root folder of the project. And as you can see, we right now opened the HTML folder. So HTML is basically the root folder of our project, and everything else is inside of this root folder. So HTML files is a folder inside of the root folder HTML. Images is a subfolder of HTML, and so on. App.js is a file inside of the HTML folder whatsoever. And to start from an absolute path, you just use a slash in the beginning. And as you can see, it shows already in the code editor everything that is basically inside of our root folder. Inside of our root folder, we have the app.js, we have the content.html, we have the HTML files, and so on. So if we want to get into images, we basically use a slash, images, slash, and by doing so, we are going into the images folder. And now we select our image.png, and we have our image right here once again. So there are two options to navigate in HTML. You can use absolute paths and you can use relative paths. When using a relative path, you always define the location of something relative to the file you're currently working on. If you use an absolute path, you always think as if you're working or starting from the root directory, and everything else works exactly the same. Navigating works the same. If you use // for example, you go one folder up. If you use images slash, for example, you navigate into the folder, or let's just say folder slash, so just the folder name and then a slash, you navigate into the folder, and so on. And that is all you need to know about relative and absolute paths in HTML. What is a comment in HTML? A comment is a piece of code that will not be executed. So it is basically just an information that you use for yourself or for other developers. I can create a comment by using this kind of syntax. And everything that goes in between those two lines, in between those two code blocks basically, is a comment and will not be executed. So I can basically just use whatever. I can, for example, write some basic information about this page. And if I save this file, you can see that you can't see anything. And the reason for this is that the code will not be executed in here. So you could basically give some information for another developer or for yourself inside of this code block. Maybe you want to have some more information down here and maybe some more information down here. And this is like really helpful about comments because you can organize and structure your code, get some extra information, and so on. And this is all you need to know about comments in HTML. CSS was invented in 1996 and stands for Cascading Style Sheet. It's the language that controls the style and layout of a website. While HTML builds the structure, things like headings, paragraphs, and buttons, CSS makes them look good by adding colors, spacing, fonts, animations, layouts, and more. CSS works by selecting HTML elements and applying rules to them. This rule, for example, targets all H1 elements and gives them the color red and a font size of 2 rem. There are three ways to use CSS. Inline, using the style attribute. Internal, using a style tag inside HTML. External, by linking a separate CSS file, which is the best practice. The cascading in CSS means that styles are applied in order of priority. Inline applies before internal, which applies before external. And if the same rules exist, the last one wins. CSS also uses selectors like classes.button, IDs like #hero, and pseudo-classes like :hover to style elements interactively. In short, HTML builds the foundation, CSS makes it beautiful. There exist three ways to embed CSS code into your HTML file. Let's imagine we have this h1 tag that has some form of heading, for example, inside. And now we want to target this h1 tag. The first way to do so is by using the style tag inside of the head. So we can use style right here, and now we can define our styles right here. So we can, for example, say h1, and now let's say we want to have a color for our h1 of red, for example. We're going to save the document. And as you can see, now we have a red heading. And we can also say we want to have a blue heading, for example. So we can define whatever color we want right here. And by using the color property, you just define the color of a font. There's also another way to achieve the exact same result by using the style attribute instead of the h1 tag. So we can say style right here, for example. And now we can say we want to have a color, for example, of, let's say, brown. And now our h1 has the color of brown. The third way to define colors, and the preferred method for you, will be the link tag inside of the head. So you can say that you want to use a link inside of the head element of type CSS. And as you can see, by using the shortcut, you generate a link that has the relationship attribute, which essentially defines that this is going to be a style sheet in our case. And inside of the href attribute, you define the path to the style sheet. And in our case, we want to have the style sheet in the exact same folder, because we have it in the exact same folder, and the name of the style sheet is obviously style.css. So by using this syntax, we've now defined that this style sheet in the same folder will be the style sheet that we're going to use to style our elements inside of HTML. So now, for example, we could say that we want to select the h1 element right here inside of our style sheet, and we want to give our h1 a color of, for example, let's use blue violets so we can see a difference. We're going to save the file, and as you can see, now we have this blue violet title right here. So to sum up, you can either use the style tag inside of the head, you can use inline styles inside of the tag right here, or you can link a style sheet by using link rel equals style sheet, href equals a name of your style sheet right here. So those three ways exist, and the preferred method for you should almost always be using the link tag. Target an element inside of CSS, there exist a couple of different selectors. The first selector is the element selector. You can use the element selector by going inside of your linked style sheet. So we've linked our style sheet by using the link tag right here. We've linked our style.css file, and now we can use an element selector by just using the element name. So in our case, we want to style an h1 tag. So the element name is h1. We are going to use opening and closing brackets right here. And inside of those brackets, we can now define our style. So we can say color should, for example, be blue. We're going to save this, and now our heading has a blue color. And to show you that this really works, we can also say that we want to have a p tag with some placeholder tag. And now the element selector would have the name p essentially, because the element is a p element, so a paragraph element. So we can say p will have a color of yellow, for example, which will look terrible, but as you can see, we now have a yellow color. The next selector we can use is the class selector. So we can also go to our tag inside of HTML and give this one a class of, for example, my-heading. Now we can copy this class name, go inside of our style sheet. We're going to delete both of those selectors, and by using dot and the name of the class right here, we can use the class selector. So now we've again selected our h1 right here, but this time we've used a class name. And now we can say we want to have a color, for example, of aqua, for example. And now we have an aqua color right here. Besides the class selector, we can also use the ID selector. So let's say our paragraph has an ID, for example, of info minus text. So now we've defined an ID for this paragraph, and we can target an ID by using the route instead of the point, followed by the ID name. So this is how you select an ID. Now again, opening and closing brackets. And let's say we want to use a color, for example, of, again, let's say beige. And now we have this text, which is barely visible because the color is pretty similar to white. Now there also exists the universal selector, which is just an asterisk. Again, we can use opening and closing brackets. And now we can just say, okay, let's use a color of red, for example. We're going to save this. And as you can see, now our paragraph as well as our h1 are red. And the reason is that the universal selector usually selects every single element. So now let's delete this, and let me show you some other selectors. Let's imagine we are having a div, for example. And inside of this div, we're going to have a paragraph. And inside of this paragraph, we have a couple of words, for example. And let's duplicate this paragraph, for example. So now we have this paragraph twice, and let's create a third paragraph that probably has a text last paragraph. So now imagine we wanted to select those paragraphs right here. In order to do so, we could essentially say that we want to target every p tag that is inside of a div. And this is really, really simple. We can just say, let's target a div that has a paragraph inside of it. And by using this syntax, you're saying we're targeting every p tag inside of a div. So now let's use this syntax, and we're going to say color is going to be red, for example, or Rebecca purple. And as you can see, now we have those texts that are essentially Rebecca purple, while the last paragraph that is not inside of a div does not have a color at all. But now let's imagine we would have another div, for example. And one of those p tags is inside of another div. Let's say this div has a class of, for example, container, and this div has a class of subcontainer, for example. So now if we would say, for example, dot container p, as you can see, we still have the same effect. And the reason for this is that this container is essentially a wrapper for this div and is essentially a wrapper for this paragraph and a wrapper for this paragraph. So both of those paragraphs are inside of this container div. So as you can see, it doesn't matter how deeply nested a paragraph is. By using this syntax, the effects will be applied. But if you just want to target the direct child, you have to use this symbol right here. And as you can see, now I'm going to save, and only the direct child will get this color. Why the nested child will not have that color anymore, because it's not a direct child of the container div. It's a direct child of the subcontainer div, but it's not a direct child of the container div. Now there also exists the adjacent selector, and let me demonstrate you by using a couple of p tags, for example. Every p tag will have a couple of words inside, and we're just going to duplicate it 4 times, for example. And let's say our first p tag will have a class of first, for example. So now we can say we want to target our first element, but let's imagine we wanted to target this p tag right here. So the first p tag that follows the p tag with the class first. And in order to target that one, we can use a plus symbol. So now we can say first dot first plus p, which essentially means select the first p tag that follows the element with the class of first. So this could also be a div right here. That wouldn't really matter too much. So we can just use a div here, and it wouldn't really make a difference because it still has the same exact class. We're going to save this, and we're going to say, give that p tag a color of blue, for example. And as you can see, now our second p tag has a color of blue, because this is the first p tag that follows an element with a class of first. If we wanted to select every single one, we would need to use this symbol right here, which essentially means select every single sibling on the same level. We're going to save this, and as you can see, we've now targeted every single sibling on the same level, so essentially everyone next to this p tag. If you would have a div afterwards and a p tag afterwards with some words, as you can see, p tag would still be affected while the div would not be affected, because the div is essentially not a p tag, so not a p tag that is a direct sibling to our .first class. Essentially, let me show you some tricks at the end. We also have, let's imagine we have an h1 that has some words. Let's imagine we have an h2, for example, that also has some words, and let's say we have an h3 as well. And that one has a word as well. So now, if we wanted to target all of them at the same time, we could say h1, comma, h2, comma, h3, and now we can define the styles for all 3 elements at once by saying color is equal to aqua, for example. And as you can see, all elements have the color aqua right now. We could also use some stacking, for example. So we can, for example, say class, and this one has, for example, class heading and class of hey bro, for whatever reason. And now we could say that we want to target our h1, for example, that has a class of dot heading, for example. And now we say this one should have a color of red or Rebecca purple. And as you can see, we've targeted that class right here. And it would also work if we would go ahead and say, okay, let's say we are going to write dot hey bro 1, for example. So this is wrong. So if we're going to delete the 1 right now, this is true, and we're getting this effect. So this syntax essentially means target an h1 that also has the class of heading and also has the class of hey bro. And if one of those things is not fulfilled, we are not going to apply the style. So if this one is hey bro 2, for example, so that class does not exist for the element, even though heading and h1 is essentially true, it is not going to apply the style. So all of those properties essentially need to be true to apply those styles. And sometimes you also have some attributes. So let's, for example, say we are going to use an anchor tag, which obviously usually has an href attribute that is probably going to target whatever site, doesn't really matter though, and probably has a text of Google. So we're going to have this anchor tag. And now we can say that we want to target every anchor tag that essentially, for example, let's say that has an empty string. Wouldn't make really too much sense in a real world application, but let's imagine we are going to target every anchor tag that has an empty attribute href. And we can do so by saying, let's target an a tag that has, and we're going to use those brackets right here to define an attribute. And now inside of these brackets, we can, for example, say if an anchor tag has an href that is equal to empty quotes, we can apply a color of, let's say, for example, brown. We're going to save this, and as you can see, now we have brown color for this Google attribute. If you would say Google right here, for example, and going to save this, you can see that the brown color disappears. And the reason is that this anchor tag does not have the attribute of href equals Google anymore. But if we are going to go into our index.html and say href is equal to Google, for example, now those brackets become true again, and we are going to apply the style again. To style text, we first need to create a sample text that we can use to style. And we use some placeholder text right here and save the website. And inside of our style.css, we can select this text now by using the P selector, for example. And first of all, let's say we want to change the color of our text. And we can do so by using the color attribute. And right here, you can basically select any color by just typing the name, for example. And the second option to change the color would actually be selecting a hash code, for example. So you could, for example, say use hashtag FFF, for example, which is white. Or you can say, let's use 000, which is black, for example. But you can also obviously define the hash code by using any other color, or you can hover over this color picker right here and just select a different color code and save the document. And right here, you can basically see the chosen color right now. So you can either use the name, or you can use the hash code to define the color. And the third option would be using RGB values by typing RGB. And inside of here, you can select the portion of red, the portion of green, and the portion of blue you want to have. And that scale goes from 0 to 255. The higher the value, the higher the portion of red we'll basically use. So if we say, for example, we want to use 250 of red, 0 of green, and 0 of blue, we get a red text. If we say we want to have a portion of 0 red and 255 of green, for example, we get green text. And the same obviously works for blue. So if we say 0 green, 0 red, and 255 blue, we get a blue text. And obviously we can also mix those two colors. So we could say we want to have 100 of green, for example. And you see the text change slightly. Now we can say we want to have 255 of red, for example, and we get a different color as well. So by using RGB, you basically say which portion of which color do you want to use to create a new color. Because in the end, every color is obviously made up of different colors, and by mixing colors, you generate a new color. And red, green, and blue are basically the base colors. So if you have 255 for each of those values, you get white. If you have 0 for all of those values, you'll get black. Now there's basically an extension to RGB, if you want to say so, by using RGBA. And if you use RGBA, you also have the alpha channel, which means you can also set the transparency. If I say, for example, that I want a transparency of 0.6, you see that the text is slightly transparent now. I can also say that I want to have a transparency of 0.1, which means the text is almost fully transparent. And the scale of transparency goes from 0, which means it's fully transparent, so it's invisible to the user, to 1, which means it's fully visible. The next thing you can do is basically change the font family. So we can use font minus family to define a font family. Now we have some base fonts that we can choose from. So we could, for example, say we want to use Impact, and we'll save the file. And as you can see, we basically have a different font right now. To change the font size, we can use the font minus size property. We'll save that. And now we can, for example, say that we want to use 16 pixels for our font size, which is basically a base font size. So nothing is really changing. But if we say we want to have 26 pixels, for example, we see that our font is a lot bigger now. To change the thickness of our font, we use the font weight property by using font minus weight. And right here you can see different values. 400 is basically standard, so nothing will change. 600 should also be a little bit bolder. 700 is actually even bolder. And right here we also can use bold, bolder, lighter, normal, and so on. So 400 is usually normal, and just feel free to experiment with those values a little bit. And you can also use names like bold to define a bold font, normal to define a normal font size basically, and lighter to define a lighter version, which does not exist for this type of font family. So we are going to delete this font family so you can see the difference a little bit better. And not every font supports all types of styles. So basically, if you have a font that does not support light, for example, then you'll just have the normal version of the font. But this would be the way to do it if the font supports different styles. You can use the text align property to align the text to the center, to the left, to the right, and so on. So let's say we want to center our text. We can just do so by using the center property. And if you use Visual Studio Code, you'll see basically an indication once you type a colon of what is possible anyways. So you could obviously center, left, right, and so on. We want to go to the right, for example, we save our file and now our font is at the right. Text decoration might be useful in some cases for you as well. You can basically define whether your text should be underlined, dotted, have a line through, and so on. So this is basically some additional styling if you want to say so. So let's say we want to have an underline because that is something that is really common. And once you save the document, you see that your text is underlined now. So yeah, you could also say you want to have a line through, for example. Now you have a line going through your text, which might not be the most common use case, but maybe you want to have that, and so on. So just experiment with that as well, and you'll see how it goes. So let's just delete those styles for the next styles, and let's create a text that is slightly longer by adding some characters or some words. And now we can add a line height, for example, which basically just is what it says. It basically just defines the height between your lines. So we can say that we want to have a line height of, for example, 30 pixels. And now, as you can see, the space between the lines is slightly bigger. The next option we have is the letter spacing, which again is just the spacing between the letters. So we can say we want to have a letter spacing of 30 pixels, for example, and now we have a pretty big letter spacing, which might be way too big, but in some cases you might want to have text like this, for example, since you think it's pretty cool or whatever. To understand units, let's create a div first of all, and let's target this div inside of CSS by using the div selector. Now let's give our div a certain width by using the width property and say that our div has a width of 100 pixels, and let's give it a height by saying it has a height of 100 pixels. And to make our div visible, we can use the background color property and give a background color of aqua, for example. And as you can see, we have our div right here. I already use pixels right here, and pixels is the unit you really use pretty often, and it's just a fixed size. So let me draw an example for you so you basically understand pixel. Imagine you have this type of monitor. This is basically what it looks like. Even though you can't really see it, your screen is basically divided into a lot of pixels. And if you have an HD screen, it contains 1920 pixels for the width, for example, and 1080 pixels for the height, for example. So a pixel is basically just a little square on your screen. And if you take a lot of squares on your screen and combine them, you get an image. And if you want to say so, every HD monitor includes 1920 pixels for every row and has 1080 rows. So basically, if you multiply that number times that number, you get the amount of pixels your monitor uses in total to display an image. So every image you basically see on your monitor is made up of pixels. The pixels are just so small that you can't really see them. But this is something you always want to keep in mind when using pixels. If you say that we want to use a width of 100 pixels, you say that we want to take up 100 of those pixels in this area, for example, to display our div. And the same obviously also goes for the height. The next option to define width and height, for example, is the percent option. So we could also say that we want to use 40% of the width, for example. And as you can see, we now take up 40% of the width. But what exactly is this percent sign? This percent sign says that we want to take up 40% of the width relative to the parent element. And the parent element right now is our body right here. So if we say that our body should, for example, have a width of 200 pixels, for example, you'll see our box getting a lot smaller because our body is a lot smaller now. And the body now just takes up 200 pixels, which is basically probably around that. And our div takes up 40% of those 200 pixels. So it's basically a lot smaller now. If we say that our body has a width of 1000 pixels, for example, you see that our div will get a lot bigger because our div takes up 40% of 1000 pixels right now. So basically 40% of the parent element width. M and rem are two different units which you mostly use to change the size of text. So we create a text to really take a look at it by using a paragraph, for example, and having some placeholder text. Doesn't even have to be that much, like that. And now let's target the paragraph by using the p tag and using opening and closing brackets. And now we can say that we want to use a font size, for example, of probably 2M. As you can see, this font is like super big. If we use 1M, it would basically mean just use the default font size. If we use 2M, it would basically mean use twice that font size, and so on. And if you use rem right now, you would not see a difference. So why is that? The difference between M and rem is that M is relative to the font size of the parent, while rem is relative to the font size of the root element. So to really show you the difference, let me change the font size of the root element, which is the HTML element. So this is the root element. And now we can change the font size to, let's say, 40 pixels. So we really see the difference. And as you can see, if we change the font size of our HTML element and we use a font size of 2 rem, for example, which is twice the font size of the root element, so basically 80 pixels right now, we have a font size of 80 pixels right now. But if we change this to M, for example, nothing is going to change. So why is that? That is because every child in HTML inherits the font size of the parent element. And since our body is a part of our HTML, so of our root element, our body will inherit a font size of 40 pixels as well. And the body is the direct parent to our p tag. And since M always defines the font size relative to the font size of the parent element, which is body in our case, and since body inherits the font size of HTML element, so the root element, nothing really changes. But if we go to our body element, which is the direct parent to our p tag, and we change the font size here, for example, to, let's say, 10, for example, 10 pixels, you can see a difference. So if we go and use 2M right now, we change the font relative to the direct parent element, which is the body. And if we use rem right now, we use the font size of the root element. So we change our font size relative to the root element's font size, which is 40 pixels. So this is basically the difference between rem and m. You can also say that rem refers to the root element because of the r in rem, and m always refers to the parent element because there's no r in m. The next properties I want to show you are viewport width and viewport height. And they are pretty much self-explanatory. The viewport width refers to the width of the viewport, and the viewport height refers to the height of the viewport. So basically the height of the screen and the width of the screen. So let's go and target our div element. We can, for example, say that we want our div to have a width of, for example, 40% of the entire viewport width by using this kind of syntax. And now we can, for example, define a height as well and say we want a height of, for example, 80% of the viewport height. So this is relative to the height of the viewport, for example. And now we can say we want to have a background color of, let's say, yellow, for example. And as you can see, our div now takes up 40% of the viewport width and 80% of the viewport height. So in case I increase the size of the viewport by making it wider, for example, you can see that the width of our container is also getting bigger. And this is all you need to know about units in CSS. If we create a div, for example, and want to give this div a certain height and width, we can use CSS to do so. First, let's target the div element, and now we can give that div a certain width by using the width property, followed by a colon. And now we could, for example, define the width in pixels. So let's say our div has a width of 100 pixels, and let's give that div a background color of red, for example, to see what we are really doing. And as you can see, we are not seeing anything. And the reason for that is that we don't have a height right now. So a div with a width of 100 pixels and a height of 0 is still invisible, basically. So we need to add a height, which we can do by using the height property. And now we can define a height of 50 pixels, for example. And now you can basically see that our div has a width of 100 pixels and a height of 50 pixels. And oftentimes you use width and height when it comes to defining the width and the height of a div, for example. So let's understand the box model in CSS. Right now we have this div container that has a height and a width of 100 pixels and a background color of red. To really understand the box model, it makes sense to right-click our website and press on Inspect and go into the developer tools. And once you see the element tab right here and scroll down a little bit, you can see the box model. So if we open our body now and go to the div and select our div element, you can see that the div has a height and a width of 100 pixels. So let's inspect the div inside of the box model. And as you can see, inside of the box model, you can see that we have 100x100 right here. So this is basically the width times the height. And in terms of the box model, the thing you see inside of here is basically the content. Right next to the content, we have the padding. Next to the padding, we have a border. And next to the border, we have the margin. And this is something you can really visualize by using the properties padding, border, and margin. So let's imagine we want to add a border to our content. So we can do so by using border. Then we can define the thickness of the border for the first parameter. So we can, for example, say that the thickness of our border is 10 pixels. There are different types of borders. We can, for example, say that we want to use a solid border, which is just a normal line. And we want to have a color of black, for example. And as you can see, we now have a border with a thickness of 10 pixels that is solid. And as you can see, if we take a look at our box model, we now have a content of 10 with padding of 0 and we have a border of 10 pixels. So if you want to add some space between the border and the content, you can use padding, as you can see right here. So we can use padding of 10 pixels, for example. And you don't really need to understand padding right now, but just remember that you can use the padding property to add some padding to our content. So now we have our content. As you can see, it visualizes once I hover over the content area of 100 times 100. Now we have a padding of 10, which is also visualized if you take a look at the box. And now we have a border of 10. So if we add more padding, for example, by adding 100, you'll see the difference pretty clearly. Now we have a super big amount of padding, we have some content inside, and we have a border. But now let's get back to padding of 10, for example. So if you want to add some space outside of the border, to the left and the right, for example, you usually use the margin. So let's use a margin of 20 pixels, for example. And as you can see, our container is now further apart from the top and the left because we added some margin around our content, for example. And this would make a lot of sense, for example, if you think about us having, for example, 3 divs, and now we have some spacing between our boxes. If we would remove the margin, you can see that the space is also removed because there's no margin around our boxes. Now, one thing you probably realize is that we add some more padding, like 40 pixels, for example, our boxes get a lot bigger. This basically means that once we have a content and we add some padding, that padding is added to the content. But oftentimes you probably want to define a width and a height, and then you don't want these boxes to get any bigger. And in order to do so, you can use the box sizing property, and the default value is content box, which just means you have a box around the content and padding and border is added on top of the content. So the box basically goes around the content. And the alternative is border box, which basically means width and height define the width and the height of the border box. So everything that goes up to the border. So if we just save this, you can see that our boxes are getting a lot smaller right now because width and height now defines the width and the height of everything up to our border. So everything up to this point. So padding, border, and content are all part of our box model. And the reason this is called the box model is because you can literally think about it in terms of boxes. You have a box, and inside of this box you have the content. After the content you have the padding. After the padding you have the border. And after the border you have the margin. And a lot of people use padding and margin to generate space around something. If you think about a paragraph, for example, with some text, and now we add some padding to this text, for example, of 100 pixels, you can see that this doesn't really make a difference if we use margin instead of padding. But if you think about the box model, it obviously makes a difference, and there is a difference between using margin and padding. Even though when using padding and margin with the paragraph, for example, you oftentimes can't really tell the difference. But it's really important to keep that in mind because oftentimes you really need to understand the difference between margin and padding. And this is all you need to know to understand the box model in CSS. Let's learn about backgrounds in CSS. First of all, we create a div that we can style in CSS. Now we target that div and give it a width of 100 pixels and a height of 100 pixels. The first property you can use to give color to a background is the background color option, where you can basically define a color by just typing in the name, like black, for example. Another option to define a color using the background color property is defining the color by using a hash. You can, for example, use hash FFF, which would be equal to white. And now you can also hover over the color and select a new color from the color picker right here, for example. And you can always use this hash to define a color. Another option besides this color picker in Visual Studio Code would be to use a color picker from Google, for example, by just typing color picker into Google, for example. And then right here, you can, for example, copy a color, and you have the hex code right here. You can copy the hex code and paste the hex code into Visual Studio Code. And now once we save the document, you'll see that we have this color. The next option would be to use RGB. We can use a value for red, green, and blue. So if we take 0, 0, 0 for red, green, and blue, we have black, for example. If we take 255 for red, we obviously have red. If we take 255 for green, we would obviously have green. And if we take 255 for blue, we would obviously have blue. And we can mix those colors. So we could, for example, make a combination of green and blue, and we would basically get this color. You can also use RGBA to add an alpha channel, which basically means you can set the transparency as well. 0 means that it's completely transparent, 1 means that it's not transparent at all, and 0.5, for example, means that it's 50% transparent. Besides the background color property, you can also just use the background property, and you could use that to define a color as well, for example. But background color is a little more descriptive, so if you're using a background color, I recommend using the background color property. You can also use the background image property to set an image, for example. If you want to use an image, we obviously first of all have to get an image, and we can use Unsplash, for example, to get an image, but you can get it wherever you want. In our case, we might want to get this image, so we download it for free. Once it's downloaded, we can drag it into our folder, for example. We can rename it to make it easier to target it. Let's say that's a car, for example. Now let's go into our document again, and we can define the path to the image by using the URL property and define the path to our image, which is car.jpg for this one. Once we save, we basically get this background image. As you can see, it's way too big right now, so we can use the background size property to define the size of the image. And if you want the image to fit the container, you can basically use contain, for example. So as you can see, the image now fits perfectly into the image. And you can also use cover, which basically means it's covering the entire space. So if we say we have like a width of 1000 and a height of 1000, for example, you can see that it will cover the entire image. So the difference between contain and cover is basically that contain will make the image fit, while cover makes the image cover the entire space, even if you have to cut off a little part of the image. But feel free to test it and you'll get the hang of it. So let's say that our image has a width of 400 pixels and a height of 400 pixels, for example. Since we have contain, it will fill out the entire height. Now we can also define a background position, for example, and we could, for example, say that we want to have it in the center, at the top, at the bottom, whatsoever. Usually, most of the times, you probably use center. And as you can see, our image is centered in the container right now. But it's also repeating, and that is something you can change with the background repeat property. Repeat like that, and you can basically either select repeat, which is default, or no repeat, which would be, the other value. And as you can see, our image is not repeating anymore, so you only have it one time. You can also define a gradient for the background by using the background property. But if you want to use a gradient, I definitely recommend using an online gradient generator. Obviously, you could do it by hand and learn all of those properties, but this is something you probably never do when it comes to a real application. So I'd recommend going to Google and just typing CSS background gradient generator. Then you'll probably just click the first link, but pretty much everything works. And right here you can basically create different gradients, for example a linear, a radial one, a conic one, whatsoever. And here you can, for example, choose a color. Let's say we want to have a red one to a purple one, the way it is right here. Then we click on a get CSS link. We copy it to our clipboard by pressing this button. And now we can just copy and paste this in. And as you can see, we have those properties, basically the background property combined with the linear gradient property. This property here defines basically the angle of the gradient, and those ones here define the background colors. And as you can see, we have our gradient right here. We can obviously also say that we want to have a 180-degree angle like this. So you can adjust that one either using CSS or just using the CSS gradient generator. I know a lot of people make like 10-minute tutorials just about gradients, but I really think that that's a waste of time. You'll use a gradient generator all of the time anyway, so I think this is the best method and the only method you really need to know. And this one here is pretty much self-explanatory anyways. You can change those colors whenever you want. You can change this angle whenever you want. And that is pretty much all you need to know about gradients in my opinion. So let's understand the difference between block, inline and inline block. First of all, we create two divs inside of HTML, which we can style later on. The first div will have the class of box1, while the second div will have the class of box2. Now we select the first div by using the dot notation for box1 and the second div by using the dot notation for box2. Let's say our first box has a width of 100 pixels and a height of 100 pixels as well. Let's give it a background color of probably blanche diamond, whatever that is. And let's just copy those properties and give it to box 2 as well. And change the color probably to some yellow, like this. Now let's use the display block property to see what is going to happen for both of these elements. And as you can see, literally nothing is going to happen because the div element is a block element by default. As we already know from HTML, there exist block and inline elements, and the div is a block element, for example, while the span is an inline element. So what is the difference now? A block element basically usually always takes up the entire space available, and every new block element starts inside of a new row usually. So usually there are not two block level elements next to each other. So if we say that this is an inline element, for example, as you can see, the element completely disappears. And the reason for this is that you can't set width and height for inline elements. Usually an inline element takes up the minimal necessary space to display the content. Since we don't have any content inside of the box and width and height properties do not apply, the box 1 element, so basically the div, completely disappears. So if I set this box 2 to inline as well, it will disappear as well. So what are the options right now? What if we wanted to have both of these elements next to each other, but we also want to keep the block level properties, like being able to define the width and the height for the element? And in that case, you can use the inline block property right here. And as you can see, it appeared right here. And now let's copy inline block to our second box. And as you can see, we have two inline block elements right here that go next to each other once they have the available space, as you can see. So basically, inline block combines the best out of a block and an inline element and allows those two elements to basically keep the block properties, like being able to define width and height basically, while also having inline properties, like just taking up the minimal available space and allowing other elements to sit right next to this element. Let's understand the flexbox. In order to do so, we first create 3 divs, having the name container 1, container 2, and container 3. 2 and 3, like that. Now we create a width and a height for each of those containers. Let's say 100 pixels of width, 100 pixels of height. Now we copy those values. We'll have a background color of yellow. And now we copy the container 1 and make the same for container 2 and container 3. We just choose a slightly different color for both of these containers to see a difference. So now we have those 3 containers basically. And as you can see, each div takes up the entire space of one row. So what if we wanted to have those divs next to each other? Obviously, we could use inline block, but that is definitely not something you want to do when you have the option to use a flexbox. And in order to use a flexbox, you need to wrap all of those divs with a parent element. And now we can give that parent element a class of, for example, parent container. Just make it clear. Now we copy this class parent container and create a selector for that class. And now we want to say inside of this parent element, I have 3 different divs. And inside of this parent element, I want to have all 3 divs next to each other. That's what we're basically saying. And in order to do so, we can use display, and we can set display, as already mentioned, to block, inline block, or inline. But we can also say that we want to have display of flex. And by setting display to flex, we are basically saying take every element inside of our parent container. So take every element that is inside of this div, every direct child basically, and place that direct child next to each other. And now the thing that is really nice about that is that we can basically also use the parent element to define the spacing of the child elements. So let's basically say we want to have all of those elements in the middle of our page. We can now use justify content of center and center our elements. We could also use align items to center, and we give our container, our parent container, of height of 100 viewport height basically. So the container takes up the entire space, and justify content basically says justify the content to the center, and align item says align the content to the center. And in this scenario, align items basically refers to the vertical axis. So align the items on the vertical axis in the center. So basically in this axis. justify content right here refers to the horizontal axis. So basically it refers to the row. So we basically use justify content to center along the row and align items to center along the column. But in order to understand how this really works, we need to flex direction, and the default value for flex direction is row. So flex direction row basically means take all of the content inside of the container and arrange it in a row, the way we did it right here. And now let me draw something for you so you really understand it. If our flex direction is set to row, it basically means that we have a main axis and a secondary axis. And since flex direction is row, our main axis, which we indicate by using M, is our row. And our secondary axis is basically our column, like this. Now there's a second type for flex direction, and that second type is column basically. So if we set the flex direction to column, for example, you'll see that our content is now arranged in a column. The primary axis is now the column, and the secondary axis is now our row. So this column is the primary axis now, while this row is the secondary axis right now. So what is the difference basically? Now the content is arranged from top to bottom, while it was previously arranged from left to right. That's obviously the first difference, but the flex direction also changes the way our justify content and align items property work. So let me show you. Let's set flex direction to row again, and let's remove align items again. Now if we set our justify content to center, justify content always refers to the primary axis. And since flex direction is row right now, our primary axis is the row. So justify content basically says along our row, justify our content in the middle, so in the center. So if we change our flex direction to column right now, our column row, so basically our column, becomes our primary axis, and justify content always refers to the primary axis. So justify content now says take our primary axis and align the content in the center along the primary axis, which is the column right now. So once I save this, you can see our content is now centered along the primary axis, which is now the column. So our content is centered along the column. And now if I would use align items always refers to the secondary axis, and our secondary axis, since we use flex direction of column right now, is our row. So align items will now say, if I set it to center the content along the secondary axis, which is our row right now. So I save, and our content will go to the middle of the row right now. So it's really important to understand that flex direction does not only change the direction the flex box basically arranges our content along, but it also changes the way justify content and align items work. And again, justify content always refers to the primary axis, while align items always refers to the secondary axis. And by default, if you don't use flex direction, the primary axis is usually the row. So obviously justify content can not only be set to center, but you can also say that we want to have some space around, some space between, or space evenly. So if I say I want to have some space around the content, it will have some space around every single box. Now I could obviously also say I want to have space between the content, and the difference is that it will have space between the content but not around the content, so there won't be any space to the left and to the right basically. Now you could obviously also say that we want to go with flex start, for example, and now our content is arranged to the left, so basically arranged to the start of the flex box. And we can also use flex end, for example, and now we go to the end of the flex box and we'll arrange our content right there. It works pretty similar for align items, so we could, for example, say align items, center, flex start, flex end, and so on. So we could, for example, say let's go to flex start basically, and we basically go to the start of the flex box along the secondary axis, which is our column right now. We could obviously also say, okay, let's go to flex end, and we'll arrange our content to the end of our flex box. Let's first of all go back to center because it looks a little bit better. And now let's say we want to have a gap in between of the items. So we could use the gap property for that circumstance. And we could say, okay, let's have a gap between every single item of 30 pixels. And now you have a gap between those items of 30 pixels. Now we could obviously also say, okay, we want to have 50 pixels. For this instance, let's say the width of our items is a little bit more and the height is a little bit more. So our items are getting a little bit bigger. Once we save, we basically have this box, if you want to say it like that. And let's also probably create a fourth container with a background color of, yeah, something like that. And we obviously also need to create that container in our HTML file, so we are going to do so. And as you can see, now our boxes basically get smaller. And in order to do so, we can also define inside of the parent container again how our flexbox should basically behave. And in order to do so, we can use the flex wrap property. And the default is basically no wrap, which means no matter what happens, even if the content gets squished like here, don't wrap. And the alternative is basically wrap or wrap reverse. You're just going to use it, and once you activate wrap, basically the content is basically going to wrap into a new row. You can obviously also use wrap reverse, which will just reverse the order of the wrapping basically. But most of the times you just want to use wrap to wrap into a new row. So now let me explain some important concepts. So first of all, let's take a look at the structure again. We have basically those 4 containers, and we have a parent container. Those 4 containers are inside of the parent container, and previously all we did basically happened to the parent container. So we activated display flex in the parent container, we justify the content inside of the parent container, we line the items inside of the parent container. But there's also a way to define for every single element how the element should behave once the amount of space basically changes that every element has, that is basically available to every single element. And that is something you can change for every single element. So we are not going to define a property for the container, but rather for every single element. And the first thing we can basically do is set a flex basis of 100 pixels, for example, and a height of 100 pixels as well. So flex basis in this case defines the width of our element, because our flex direction right now is basically row. If we would change our flex direction to column, it would define the height of the element. So flex basis basically always changes the value along the main axis, which is the row in our case. So we can use flex basis instead of width, while we can use height for the height. So let's use a flex basis of 100 pixels for every single element. Like that. So now we have all of those elements next to each other again. Let's change the gap to probably 10 pixels. But as you can see, there is a lot of available space right here. So couldn't we maybe say that we want container 1 to probably grow as much as he basically can if there's available space? And we could actually do so by using the flex grow property and setting that one to 1. And as you can see, our first container is now taking up all of the available space. Now let's say I want our blue container to grow as well. So I could go ahead and set flex grow for our blue container to 1 as well. And as you can see, our yellow and our blue container now grow and take up all of the available space if there is available space. But maybe we want our container 1, so our yellow container, to grow slightly more than our blue container. So we could, for example, say flex grow is 2 for yellow and 1 for blue. So blue will take up some available space, but yellow will take up a lot more of the available space. And we could obviously also say like 4. So now yellow will take up even more of the available space, while blue will take up a lot less of the available space. And obviously we could also go ahead and set flex grow for the green container, for example, and so on. So this is how you basically define how the element works when there is space available. And the default value for flex grow is 0, which means you don't grow. So if we set yellow to 0, for example, it means just take up the space that flex space is defined and don't take any more space. So we want to have 4 in our circumstance, for example. So now there's also a flex shrink property, and its value is 1 by default. So if we do that, nothing is actually going to change. But let's say that we have a shrink value of 3, for example. And let's say we have a shrink value for the blue box of 2, for example. Now our yellow and our blue box will shrink a lot more. So let's take a look. If I make the window a little bit smaller, you can see our blue box shrinked a little bit, while our yellow box shrinked a lot. Now for flex basis, flex grow and flex shrink, you also have a shortcut property, which is basically just flex. And for flex, the first value is basically the grow factor, the second one is the shrink factor, and the third value is the basis. So basically grow, shrink, basis like this. So let's remove flex grow, flex shrink, and flex basis. And let's say we want to have a grow factor of 5, for example. So we want this one to grow a lot. Now let's say we have a shrink factor of 0, for example. So it's not going to shrink at all. And then let's say we have a basis of 100, or let's say we have a basis of 100 pixels. And that is basically the basis, is basically the point where the element would start to shrink. So if there's space available, it will take up all of the available space basically, or a lot of the available space. It will basically not shrink once it hits 100 pixels. So it will, if you want to say it, shrink up to 100 pixels, because that is basically all the space that it just takes up because of flex grow. But once it reaches this basis, it is not going to shrink because we have a shrink factor of 0. So let's take a look at that. Now I'm going to make the window a little bit smaller, and it will shrink down to 100 pixels basically, and now it will not shrink anymore. Also, let me remove flex wrapped for this test, and now we'll basically take the window, we make it smaller, we make it smaller, we make it smaller, and at a certain point, once it reaches 100 pixels, it's not going to get smaller anymore. And we could also like say, okay, let our green container have a width of, for example, 300 pixels, which makes it a little more obvious. So now the yellow container is basically taking up a lot of space when there's space available, and once we shrink, it basically shrinks down to 100 pixels. And at a certain point, you can see our blue item is really shrinking a lot because we have like a flex shrink factor of 2, but our yellow item is not shrinking at all anymore because we have a flex shrink factor of 0. Like, I hope that is understandable. We could obviously also do the same for the other containers by just using the flex property. So we could basically say flex, and now we want to have a flex grow factor of 1, a flex shrink factor of 2, and a flex basis of 100 pixels basically. And by doing so, we could remove flex shrink, flex basis, and flex grow. I know that the flex box is a complex topic for a lot of beginners, but I really hope you understood everything, and that is all you need to know about the flex box in CSS. Let's take a look at the grid in CSS. To create a grid, we first of all create some divs in HTML. The first div is the parent element and has the class of container, and every other div will have a class of item.1, item.2, item.3, item.4, item.5, and item.6. So we basically have 6 items inside of one container. Now we create a selector for our container, and we create a selector for every single item and give every single item a background color. So as you can see, we now have 6 containers. Every container has the same width and the same height, and everyone has a different background color. Now, to use a grid, we can use display grid. And as you can see, nothing is going to change. And the reason is that for a grid, we need some additional setup. We need to define the amount and the width of the columns, and we need to define the amount and the height of the rows. And in order to do so, we can use grid template columns and grid template rows. So by using grid template columns, we define the amount of rows we'll have. So you can either use pixels or fractions. So let's start by using pixels. So let's say we have 2 columns, for example. The first column has a width of 200 pixels, for example, and the second one has a width of 200 pixels, for example. And as you can see, we already have our columns right now. So 2 columns. This is the first column, 200 pixels, and this is the second column, 200 pixels. Now let's do the same for our rows by using grid template rows. And let's say the first row has a height of 400 pixels and the second one has a height of 300 pixels, for example. And as you can see, we now have a gap between our rows. So first row 400 pixels, second row 300 pixels, and since we have a third row here, we should probably create a third one, 200 pixels. So now we have enough space for our 6 items. If I'm going to remove the width and the height for each box and save the document, you can see that each of these items now takes up all of the available space of the columns and the rows, so basically of the grid. And now it's really good to visualize. We have 2 columns. Each of these columns has a width of 200 pixels, and we have 3 rows. The first row has a height of 400 pixels, the second row has a height of 300 pixels, and the third row has a height of 200 pixels. Instead of pixels, we could also use fractions though. And fractions basically just means you have a certain amount of space inside of this container. We could, for example, say that we want to have a width of 100% of the viewport width, and we can have a height of 100% of the viewport height. which actually means that this is the width and this is the height. So everything is the width and everything is the height. So the entire window is width and height basically. And now we can basically say that we want to divide this available space and use that available space to basically create our grid. So we could, for example, say that we want the first column to take 1 fraction of the available space, while the second column, for example, should take 2 fractions of the available space. And once we save, you can basically see that the first column takes up 1 fraction and the second column takes up 2 fractions of all of the available space. So basically of the entire viewport width. So let's take a look at the grid template rows. We can do the same here. Let's say the first row should take up 1 fraction of the available space. The second row should take up 3 fractions of the available space. And the fourth row should take up probably 1 fraction of the available space. So as you can see, first row 1 fraction, second row 3 fractions, third row 1 fraction. And everything works as expected. You can also create a gap by using the gap property. So we can, for example, say that we want a gap of 10 pixels in between the items. And now it looks like that. And imagine you would have photos right here. This could be a perfect photo grid, for example. This could be a photo, this could be a photo, this could be a photo, and so on. Now, for every individual item, we could actually define how many columns and how many rows that item should take up. So basically how much space it should cover. So we could, for example, say that we want to have a third column, for example, that takes up 1 fraction. And now our grid has some available space at the bottom. So let's say I want our first item to take up the space from here to here, basically. So basically from spot 1, 2 to 3. You basically got to divide this into a regular table, if you want to say so, and then you can like really imagine what the lines look like. So this is basically point 1, this is point 2, this is point 3, and this is point 4. And if you go from top to bottom, this is point 1, this is point 2, this is point 3, and this is point 4. So you have point 1 to 4, and now you can go into the item and define for every single item how much space it should basically fill. And you can do so by defining grid columns, for example. And now we could say we want to start at position 1 for the first item, and we want to go up to position 2, 3. So we want to go from 1 to 3. And you can do so and indicate so by using the slash, for example. So let's say our second item is just fine, but now we want our third item, so the green container, basically to take up the space from, let's say, 1 to 2 to 3. So we just use grid columns again, and we say 1/3, and it'll take up all of the space. So let's say we want to have item 4, so the purple one basically, to take up the space from here to here. So we can go here, and now we need to define rows basically, because it should take up everything from row 1, 2, 3, 4, from 2 to 4. So we go ahead and use grid rows, and we say we want to go from row 2 to 4. As you can see, it's now displaying only the purple one and not the other ones anymore. And we can change that by using grid column, and we want to start at position 1, 2, 3 to 4. So we want to go from 3 to 4. And as you can see, we have our layout again. Now there would be a second option to do the same or to achieve the same. So let's just delete all of these things, and we have our base layout again. So let's say we want this item to take up basically 2 columns. So basically you want to go from here, 1, 2 to the right. And we can do so by using grid columns, so the same property basically, but we can use a different syntax. We can say span 2. So you want this to span over the amount of 2 columns, if you want to say so. So we basically start here and span for 1 and span for 2. And once we save, we have the same result. And obviously the same also works for rows. So let's just say we want the green one to take up 2 rows, for example. And we can do so by going to the green one and say grid row span. We are going from 0, 1, 2. So we want to span over 2 rows again. And once we save, we basically have the expected result. And this is all you need to know about creating grids in HTML and CSS. Let's understand media queries in CSS. First of all, we create a div with the class of container. Let's say that div has a width of 100 pixels and a height of 100 pixels, as well as a background color of yellow. Now we can change properties of this container, for example, by using a media query. You can create a media query by using add media. And after that add media attribute, you can define several properties if you want to. For example, we can define a min width, a max width, a min height, and a max height. So let's say we want to define a max width of 700 pixels. Now we use opening and closing brackets. And now inside of these brackets, we can, for example, define styles for the container that only apply when the width is 700 pixels or below. So let's say for our container, we want to have a background color of, for example, aqua when the width is below 700 pixels. So let's test that by making our window a little bit smaller. And as you can see, we get below 700 pixels, our container is basically turning blue. And once we make our screen larger again, it will get yellow again once our screen has a width of above 700 pixels. Obviously, we could also do the same, but say that we want to use the min width, for example. By default, if we have a width of above 700 pixels, our container has a color of blue, and otherwise it has a color of yellow. Obviously, you could change pretty much all of the properties. We could also say that we want to change the width to 200 pixels, for example, once we have a certain width, and now our container is a little bit bigger. And once the screen gets below 700 pixels, it will get smaller and yellow again. Besides min width, min height, and max height, you can also define media queries that consider orientation like portrait or landscape. And you can do so by using the and keyword and using an opening and closing bracket. And inside of these brackets, you can say, for example, orientation, and you can see you can either choose landscape or portrait. Let's say we want to use the portrait orientation. And once we save, as you can see, nothing is going to change. And we can also use landscape. And as you see, now we don't have that container anymore because those styles only apply to portrait, and we are not in the portrait landscape right now because we are in the landscape. So let's change that back to portrait so we see the difference. And now we could also add a third argument if we want to do so by defining a type of either screen, print, speech, or all. We can, for example, say add media screen and min width 700 pixels and orientation portrait. And if I save, nothing is going to change because we are obviously using a screen right now. And screen basically just means if you're using any form of a screen, it could be the screen of a mobile phone, it could be the screen of a PC, it could be the screen of a laptop. So just any screen, and those styles will apply. We could also say that we want to use print, for example, and then you will only see those styles when printing, basically. You can also say speech, which would be for screen readers and might be useful if you have like text to read out. And you can also use all, which is basically just the default value. But yeah, most of the time you can just leave those values. And the only really important value is basically the min width, min height, and max height. In some cases, you want to do some things maybe based on the orientation, so that might be useful. But that is basically all you need to know about media queries in CSS. Let's understand pseudo classes, starting with hover. In order to show you hover, let's create a div inside of HTML with the class of container. Now that we have that class, we are going into CSS. We are going to target our container. We'll give it a width of 100 pixels, a height of 100 pixels, and a background color of yellow, for example. To use the hover pseudo class, we are again going to target our container, but this time followed by a colon and the hover pseudo class. And by using this syntax, you're going to use the hover pseudo class. Now again, opening and closing brackets, and inside of this container, we can basically define the things that should change once we hover over the element. So in our case, let's say once we hover over the element, we want to have a different background color of maybe aqua. We are going to save our document. We are going to hover over the yellow element. And as you can see, we now have an aqua background. We could obviously also change the width, for example, once we hover to 150 pixels and the height to 150 pixels, for example. like this. And now once we hover, the height and the width should also change. And as you can see, it does. So hover defines what is going to happen once you hover over an element. The next pseudo class works for links, for example. So let's create a link to take a look at it. Let's say we have a link to Google, for example, and we're going to target the link by using the A tag. And now we can add the active pseudo class by using :active. So the syntax is pretty similar to the hover pseudo class. The only difference is that you have active instead of hover right here. Now we use opening and closing brackets once again, and we can say that we want to have a background color of brown, for example, once our link becomes active. And you'll see what active means once I click the link. And now I'm going to click it. You can see the background color is getting brown. And once I release the click, the background color turns to white again. So active basically means what is going to happen once the element is active. So once the link is clicked, for example. So let's take a look at focus next. But before, we can remove this code. And we'll remove this code inside of HTML as well. And in order to really understand focus, we are going to add an input field of type text, for example. Now we'll target this input field by using the input selector, and we'll add the focus pseudo class by using :focus. And the focus pseudo class defines what is going to happen once the element becomes focused. Once I click inside of this input element, the input element becomes focused. And right now you can see once the input element becomes focused, we have an outline around the input element. So let's say we want to remove that outline, for example, because that is something you really want to do pretty often. So let's say we have an outline of none once the user clicks inside of the input field. So let's click inside of the input field, and now we don't have an outline anymore. So let's say we also want to have a background color of probably blue, which would look terrible, but to visualize it, I think this works pretty good. And now we are going to click into the input field and we have a blue background. So this is how focused works. Let's take a look at the visited pseudo class. And in order to do so, we are going to create an anchor tag again, and that anchor tag is going to go to Google, for example. So we need the link to Google. We are going to get the link to Google by going to Google ourselves. Then we are going to copy that link. Basically, we are going to put it into the href. We are going to use target equals _blank to open it in a new tab. And now we'll target our anchor tag by using :visited. And we'll define a background color once we visited the link. So we say our background color once the link is basically visited is going to be brown. And if the link has not been visited yet, our background color is going to be white. And once we save, we basically see that we already visited that link, so the background color is going to be blue. So let me copy my YouTube link in here, and as you can see, we didn't visit YouTube yet, so not my channel at least. So the background color of Google, which is actually my YouTube link, so we can actually change that to YouTube, for example. And once I click on this link, we'll land on my YouTube page, and the link will have a background color of brown. So let's test that. We're going to click the link. We're going to land. My internet is terrible right now, so yeah, that might take forever, but you can see we actually loaded my YouTube page, and now our link has a background color of brown right now. So this is actually also working. So visited just defines how something should look after you visited it, basically. So let's close my channel page after you subscribed. So to understand first child, we're going into our HTML file, we're going to create a div, and inside of this div, we are going to create 2 paragraphs. Each of these paragraphs has some placeholder text of 5 words, for example, and then we're going to take this div, copy this div a second time, and this time we'll have an h1 at the top, for example, or let's say an h2. We'll have some placeholder text as well, and we'll have a second h2 at the bottom, for example. So this is the first div, and this is the second div. And let's give this div a class of cont1, and the second div a class of cont2. And let's style those containers just to have a visualization to differentiate them. So that is cont1. Let's copy that. Let's say cont2 has a background color of whatever, maybe some green. And now we have those 2 containers, basically. So the first container basically has 2 paragraphs. The second container has 2 h2 elements and 2 paragraphs. So let's target the paragraphs inside. And we can do so by using p : followed by first child, for example. And I think it's easier to understand once you just see the difference. So we're going to give the first child of the p tag basically a background color of, let's say, green, for example. So now our first P element inside of our first container has a background color of green. So why is that? The reason for this is that when it comes to having P tag siblings, colon first child will always select the first child of something. And since the P tag is the first child of this div, first child will basically select this P tag and give it a background color of green. If you go into this div, for example, the first child is the h2 tag and not the P tag. Therefore, this P tag and this P tag will not get a background color of green, for example. So colon first child always targets the first child, in our case, the first P tag, that is the first child of something, and give that one the defined styles. So let's say we want to have the last P tag, for example. So let's use P colon last child, and let's give that one a font size, for example, of 10. So that one is going to be pretty small now. And as you can see, the last child inside of the div right here will have a font size of 10. So if we would remove this h2 element, for example, our last P tag should also have a pretty small font size once we save. And as you can see, I saved, and now our last P tag inside of this container has also a pretty small font size, because that is the last child inside of the container as well now. Another option is to use nth child. And in order to do so, we are going to duplicate our paragraph inside our first container a couple of times. And now let's use P colon nth child. And now we can use opening and closing brackets, but here we also need some brackets. And inside of these brackets, we can define how many children we want to select. So I'm going to remove that first of all to see the difference. And now we can say we want to use the defined styles on every second child, for example. So let's use 2n, and that is basically the syntax to define the amount of childs we want to target. 2n basically means use every second child. And now let's give that child a background color of blue, for example. And as you can see, every second P tag, every second child that is a P tag basically, will have a background color of blue. We could also say let's do that for every third child, and we're going to save. And as you can see, we did the same for every third child. We could also do it for every child. Now every P tag has a background color of blue, and we can also use even, and now we will have every second child. And instead of even, we could also use odd to select the odd numbers. So let's delete that, and let's take a look at disabled, required, and checked. First of all, to use the checked pseudo class, we need to use a checkbox. So we're going to create an input of type checkbox, and let's just save the document. Now we just have this input, and let's say once our input is basically checked, we want to have a width of 100 pixels and a height of 100 pixels. So that should be a pretty big difference. Now I'm going to check it, and as you can see, we have a pretty big input. Next, let's take a look at disabled. So let's create an input field that is disabled, so input of type text, for example, and let's add the disabled attribute. Now we have a disabled input field, and let's say once our input is disabled, we add a background color of black, for example. And as you can see, now our disabled input field has a background color of black. Next, we can also target an input field that has the required attribute, for example. So let's add an input field of type text again, and let's add the required attribute again to this input field. And now we can also target this input field of type required, and we can say we want to have a background color of bisque, for example, for that required field. And as you can see, we now have a background color of bisque for the input field with the attribute of required. And that is all you need to know about pseudo classes in CSS. Let's learn the pseudo elements before and after. In order to do so, we are first going to create a short paragraph of 5 words. We're going to save the website, and pseudo elements are pretty straightforward. Before allows you to add content before an element, and after allows you to add content after an element. So let me show you. Let's say we want to target this paragraph. We are going to use 2 colons when using pseudo elements, and now we can add the before property, for example. Instead of this pseudo element, we can now use the content property to define a content. So we could, for example, say that this is some additional text, for example. And once we save, we have this is some additional text right before that class. Now we can also define a display of block to turn this before element into a block element, and as you can see now the second paragraph goes right below the first paragraph. Obviously we can also just define normal properties like we could do for every other element, like a background color of brown and so on. So we can do some normal styling to pseudo elements as well. Now we can also use p : after to define an element afterwards, and we can again say content should be this is after the text. And now we are going to save our file, and you can see this is after the text pop up right after our placeholder text. So let's also give that one a display of block so we can visualize this a little bit better. And now we have this is after the text right after our normal text. Obviously you can again use something like background color if we wanted to, and save the document, and now we have a background color as well. And this is all you need to know about pseudo elements in CSS. Let's understand transform in CSS. In order to do so, let's first of all create a div with the class of container. Now let's style this container by targeting the container class and giving it a width of 100 pixels and a height of 100 pixels. Let's give it a background color of yellow once again, and we're going to save the document, and we'll have this yellow container at the top of our page. So let's get that one into the center of our page by giving our body a display of flex, justify items of center and align items of center, so we see everything a little bit better. And this one will have a height of 100 viewport height. So now this yellow box is in the center, and transform has a lot of different properties if you want to say so. So we can use transform by just typing transform, and now we have some different options like translate, scale, rotate, skew, or a combination of all of these options. So let's start by using translate. And there exists translate, translate X, translate Y, and translate Z. But you usually only use translate X or Y, or the shorthand property, which is translate. So let's start by using translate X. And as the name implies, you can translate the content on the X axis. So let's use translate X by 100 pixels, for example. And as you can see, our content moved a little bit to the right. So we could also say, let's go 100 pixels to the left. So 100 pixels to the left on the x-axis, and the same obviously also works for translate y. So we could say go 200 pixels along the y-axis, or we could go in the opposite direction and go 200 pixels or minus 200 pixels along the y-axis. The shorthand property is obviously just translate instead of translate x and y. So we could say go 300 pixels along the x-axis and go 200 pixels along the y-axis. And now we have this result basically. The next property is the scale property, which is pretty self-explanatory. You have a scale factor, normal is just 1. If you are bigger than 1, you are basically scaling up. So 1.5 makes the element a little bit bigger, and 0.5 makes the element a little bit smaller, for example. Rotate works pretty much the same. You just rotate an element. You can define degrees, for example. So you can, for example, say, let's rotate the element by 180, or let's make 45 degrees, because that would basically be visual at least. You could at least see the difference, I'd say. And if we are going to rotate by 90 degrees, you should not see a difference, but it's rotated by 90 degrees now. Next option is skew. So we can basically tilt our content, if you want to say so, by using skew, and we can again use degrees for that option. So we can, for example, say let's skew our content along the x-axis again, if we want to, by 45 degrees. And as you can see, we skewed our content along the x-axis by 45 degrees. So obviously the same works for the y-axis again. And now our content is skewed along the y-axis. So the shorthand property is basically skew, where you can define a value for x, 40 degrees for example, and a value for y, 30 degrees for example. And as you can see, now our element is basically skewed. But that is something I've rarely ever seen, so most people don't use skew, but if you want to use that, you can. Obviously, you can also combine all of these properties, so you can, for example, say I want to translate 100 pixels into the x direction, 200 pixels into the y direction, then I want to scale by a scale factor of 1.5, and I want to rotate by maybe 45 degrees. And as you can see, we now have a combination of all of those transform properties. You can also change the transform origin, and that is also the reason why I wanted to have the element in the center of the page, because now it's a lot easier to show you the difference. So let's just use scale 1 for now, because that will not change anything, and I want to change the transform origin by using transform minus origin, And now I can set the origin to the top, to the left, to the bottom, or to the right. And I can also use a combination like top, left, for example. And this will basically just change the center, so the origin from where we apply those transformations. So now our origin is the top left. So if we are going to scale, we are going to start at the top left because that is our anchor point, if you want to say so. And especially if you have some experience with video editing, you know what the anchor point is. So this is basically the anchor point. So now we are going to start to scale our image from the top left. And now if I'm going to increase the size, for example, let's take a look at this element. I'm going to save the document. And as you can see, we started to scale our element from the top left, and it's basically going down here. So it's basically going to start to scale from here into this direction. And if I'm going to use a scale factor of 3, you should see it even better. So the transform origin might something that might really be useful, or you might want to do under some circumstances. Obviously also if you want to rotate around the top left, for example, that would make a lot of sense. You could now, for example, say let's rotate by 180 degrees, for example, or 170, it doesn't really matter. And now you basically rotate around this anchor point. And that might also be really useful if you start to animate things. And that is all you need to know about transform in CSS. Let's understand transitions in CSS. First of all, we create a container inside of HTML with the class of container. Now let's add a hover effect to that container by targeting the container and giving it a width of 100 pixels, a height of 100 pixels, and a background color of yellow. Now let's say once we hover over the container, we want to change the background color to brown, for example. And now you can see we are hovering over the container, and the container or the background color basically turns brown. But let's say we want to have a transition from yellow to brown, because right now this is really an abrupt change when we are hovering over the yellow container. So let's add a transition property, and there are different properties to define different properties of a transition. And the first one is the transition property we want to animate. And let's say in our case, we want to animate our background color. We could either say all, which would obviously animate all properties, or we can select a specific one like the background color, for example. Now let's add a transition duration. So basically, how long does it take for the transition to complete? And in our case, we can, for example, say 0.5 seconds. And as you can see, if we are hovering over our yellow container, we already have a change of the background color within 0.5 seconds. So now there are also different transition timing functions. And to really understand transition timing functions, I have this graph for you. There exists, for example, an ease timing function, an ease in timing function, ease out timing function, ease in out timing function, or a linear timing function. So let's take a look at a timing function, for example, by using transition timing function. And now we can obviously already see some different cubic Bezier timing functions. And now you also have ease in out, and ease out, and linear as well. And obviously linear just means the animation will play at a constant speed. If you have ease in, for example, right here, you are basically starting slow and then you're getting faster. If you have ease out, you're starting pretty fast and you're getting slower towards the end of the animation. The ease timing function basically starts pretty slow, gets a lot faster, and ends pretty slow again. So we could, for example, say, let's use ease, the normal ease timing function. So basically this one. Or we can also use ease in, out. Doesn't really matter for demonstration purposes. And let's save that and go back to our animation. We're going to hover over it, and now we have a different timing function. You can also add a transition delay, for example, which just delays the animation. So we can, for example, say, let's wait 1 second, and after 1 second, the animation will play. So let's hover over it, it'll take a second, and now the animation will play. And now there also exists a shorthand property for all of those properties, which is basically just the transition property. For the first argument, we can define the property we want to animate, which is the background color in our case, but we could also say all. So let's use all to show you that that works as well. Now the second argument is the transition duration. Let's say we want to have 1 second this time. Now we can use a timing function. Let's use ease in and out again, and let's use a transition delay of 2 seconds, for example. We're going to delete those properties to see that this really works, and now we'll save our file and we'll hover over our yellow container once it appears. So now our yellow container appears, 2 seconds, and the animation will play. And this is all you need to know about transitions in CSS. Let's take a look at position relative, absolute, and fixed. In order to understand that, we are first going to create a div, and inside of this div we have two other divs. Our first div is going to have the class container. Our second div is going to have the class subcontainer1, and our third div is going to have the class subcontainer2. So we basically have three divs right now. Let's give them a background inside of CSS. First of all, we'll target our normal container and give it a width of 500 pixels and a height of 500 pixels and a background color of aquamarine, for example. Now we'll target our subcontainer1. We'll give that one a width of 100 pixels and a height of 100 pixels and a background color of yellow, for example. We'll copy that and we'll paste it and do the same for subcontainer2, but we'll change the color a little bit to probably around blue. Now, as you can see, we basically have two containers inside of this big container. So first of all, let's understand position relative. Let's go ahead and set position to relative by using the relative property. As you can see, nothing changed at this point. To really change something, we can use top, left, right, and bottom properties. And the top property, the left property, the right property, and the bottom property always defines the gap, so basically the space you want to create from that position. So if we say top 500 pixels, for example, we say that we are starting from the top and we push our content 500 pixels away from the top. That is what we're basically saying by doing so. And as you can see, once I save, we're pushing our content 500 pixels away from the top. And we could obviously also say, let's push our content 100 pixels away from the left. So we go into this direction. And as you can see, we pushed our content 500 pixels away from the top and 100 pixels away from the left. So what does position relative exactly means? Position relative means that the content will be moved relative to its original position. Our original box was right here, and we said, okay, this is the original position. Now we'll move it 500 pixels away from our original position down here and 100 pixels from the left from the original position. So this basically means position relative always moves the content away from the original position, so basically relative to the original position. Let's replace 500 pixels with 100 pixels, for example, to have a better visualization. Now we could, for example, say that I want to move my second container relative to its original position as well. So we could again say position is equal to relative, and now we want to move it 100 pixels away from the top, for example. And this is basically the result. What if we change position to absolute though? As you can see, now we are right here. So what is the difference between relative and absolute? Absolute always takes the next parent element that has position relative, which is in our case the container. So if we go in here, we have this container that has position relative right now, as you can see right here. And our subcontainer2 has position of absolute. So the parent element, the next parent element that has position of relative is basically the container. So we say we move our position, basically if you want to say it like that, relative to the original container that has position relative. So if you think about that, we are basically going to have our subcontainer. Our subcontainer2 is going to move relative to the position of our container that has position relative, which is the entire box. So we're going to start at the top right here. And now we are saying go 100 pixels down from the parent element. So basically our container. And now if we would say go to the left for 100 pixels, for example, we go to the left relative to our parent element for 100 pixels. So if we're basically setting this to 0 and this to 0, we will exactly start at the top left, because that is where our parent element is basically starting. So if we would set this one to position absolute and say go down 100 pixels, the same would actually happen, because the subcontainer is also the child of our regular container. So we are basically saying again, we are moving our subcontainer 1 relative to the parent element basically, so our container. So position relative always means move the element relative to its original position, while position absolute basically means move the element relative to its parent element. Now you would also have the option to use position fixed. So we're going to do that for one of our subcontainers by using position fixed. So now we can, for example, say, let's start at the right by using right 0. So we have a gap to the right of 0. And let's start from the top. And let's also use 0 for the top. So we are going to start at the top. And as you can see, position fixed basically always refers to the position on the screen. So no matter what I do with the screen, it's always going to stay at the top right, even if I would like scroll down, for example. So imagine I would probably have another container, another div of container, so I could scroll. And as you can see, even if I scroll, let's make some more. Even if I scroll, the yellow box will always stay on the top right of the screen. So position fixed basically means just place the element on a fixed position on the screen and it will not move from that position, whatever you do. And that is all you need to know about position relative, absolute, and fixed. Let's learn about shadows in CSS. First of all, we'll create a div in order to do so and a paragraph with 5 words of text. We're going to save the document and we're going to go into our style.css file. We give our div a width of 100 pixels and a height of 100 pixels and a background color of brown, for example. We're going to save the document and now we have this div and we have this paragraph. Let's say we want to have a shadow for this div, for example, and we can do so by using the box minus shadow property. And the box minus shadow property takes 4 arguments, if you want to say so. The first one is the x offset, so x offset. Then we have the y offset. Then we have the blur. And the last one is the color, basically. Let's say we want to have an x offset of probably 20 pixels. Like this. Let's say we want to have a y offset of probably 10 pixels. Like this. Let's say we don't want to have a blur at all. And a color of black, for example. And as you can see, we have this shadow right now. And to show you that this really works, let's use a y offset of 20 pixels, which will shift our shadow to the bottom on the y-axis. And now we can add a blur, for example, of, 20 pixels. Now we have a blurred shadow, as you can see. And we can also change the color, if you want to say so, to red, for example. And now we have a red shadow. And you can also use RGB instead of regular color names, of course. Or you could use RGBA if you want to do so. So let's try to give our P tag a shadow as well, so our text basically. And if we just copy our box shadow to our paragraph and save, you can see that this looks pretty weird and this is probably not what we are looking for. So there's an alternative for text basically, that is the text shadow, and the properties are exactly the same. X offset, Y offset, blur, and color. So let's use an offset of 5 pixels on the x-axis, 5 pixels on the y-axis, a blur of probably, let's say, 10 pixels, and a color of black to make it easy. And as you can see, now we have a shadow for our text. And text shadow and box shadow pretty much work exactly the same. It's just important that you use basically text shadow for text and box shadow for pretty much everything else. And that is all you need to know about shadows in CSS. Let's understand animations in CSS. First of all, let's create a div that we can animate. And now let's give that div a width and a height of 100 pixels. And let's give it a background color of yellow, for example. Now we are going to save that and now let's animate that div. We can animate by using the add keyframes property. And then we have to give it an identifier that is basically the name of the animation. And we can, for example, say that we want to have the name move, for example. Now there are several options to really animate something, and the first one would be to use from, then opening and closing brackets, and then the second keyword would be to and opening and closing brackets. And inside of the from clause you define the initial state, and in the to clause you define the end state of the animation. So we could, for example, say that we want to use transform, translate, which basically just moves the element into a certain direction. Let's use translate x and say we want to start at translate x 0 pixels. So we start from the initial position because we are not translating at all. And then we are going to translate x, for example, 200 pixels. So we move our element 200 pixels to the right. And obviously we need to use the transform property. So like this, it should basically work. Now we need to define the transition property for our div element. And there are several different properties to do so. And the first one is the animation name, since we need to define which animation we want to use. And our animation name is move, because this is the name we gave to our animation. So let's give our animation name the name move, or define the animation name move right here for animation minus name. The second thing we need to do is define an animation duration. And we can do so by using animation minus duration. And let's say we want to have an animation of around 4 seconds. And as you can see, it's already animated. It goes from left to right, so it basically does exactly what we defined. There's also an option to define an animation iteration count. Right now you saw the animation basically just played one time, but that was actually it. But maybe we want the animation to play maybe forever, for example. And we can do so by using animation iteration count. So let's do animation iteration count, and the only option you might ever want to use is probably infinite. So you can use infinite right here, and as you can see, now our animation will repeat forever basically. The next property that might be useful is the animation direction. And you can, for example, choose normal, which is just a default value, so that might not be something that you want to type out. But you can also do reverse or alternate reverse, for example. So you could, for example, do reverse, and now the animation will play from the end to the start, basically. And alternate reverse basically just means you first play the animation in the normal direction, and then you reverse the animation. So that would actually look like this. You can also define an animation timing function, for example, and let's say we want to have an ease in out, for example, and we can do so by choosing it from here. You can also use ease in, ease out, so that is pretty similar to transitions basically. So let's choose ease in out. So the next property that might be useful is the animation delay, which just defines, as the name already implies, a delay. So you can, for example, say I want to do an animation, but I want to have a delay of 3 seconds, for example. And let's remove some of those properties because we really don't need them right now. And as you can see now, we're waiting for 3 seconds, and after 3 seconds the animation is basically playing. So that is the delay. And now let's take a look at the last property, which is the animation fill mode. And if you set the animation fill mode to forward, this basically means take the animation and you're going to stop the animation at the last frame. And you will see the difference once I save this file and the animation is going to play. So as you can see, animation is playing, normal playing, but now the animation, so the box in our case, stops at the last frame, and now the box will stay here. So if you want to start from here, for example, once the user loads the page, and then you want to animate your box, for example, right here, and then you'll go to the bottom, whatever you want to do, the box will basically stop at the end. So in this case, it will be the bottom, and the user will see the box for the rest of the time at the bottom. There's also the option backward. And this is something that is really useful if your initial state is basically different from the state your box is usually in. So our usual box is basically right here, but our initial state for the animation is right here, if you want to say so. And if we want to use that initial state or display that initial state before the animation basically starts to play, we'll have to use backwards. So let me remove this animation fill mode for now. And as you can see, we're starting at the left. Our animation starts here though, and once the delay is over, our cube jumps to the start of the animation and then goes to the right. Now if we would add our animation fill mode to backwards again, it will stay here at the start of the animation during our animation delay time, and then it will move. And now you can also say I want to use both, so I want to use backwards and forward. So we're going to start at the start of our animation, and we're going to stop at the last keyframe of our animation. I know some of this stuff might be really confusing, and again, you might not really use this animation fill method or fill mode too often, but if you want to use it, you know how it works now. There's also a shorthand property, and I really recommend everyone to just use the shorthand property because that is a lot faster and also a lot more clear in my opinion. So you're just going to type animation, and Visual Studio Code already indicates the properties that you have to fill in. So we can use a name, move for example. We can set a duration of 5 seconds for example. We could say we want an ease in, out, for example, delay of 0 seconds, so you can just leave that away, and we want an iteration count of infinite. And that is something you will probably do a lot of the times. And directional fill mode, you probably never use that or almost never, so we can just delete that. Because I mean, if you wanted to reverse an animation, why wouldn't you just type out the reversed order from the beginning? Like, doesn't really make too much sense to me, but if you want to use it, use it. And now we basically have this animation here and we will loop forever. And this is something that you might use a lot of the times if you are working with animations. Now there's also a different option. We only used from and to right now, but we could do the same by using 0% and 100%, for example. And now we have an animation that works exactly the same, but we use 0% and 100%. But we could also say, okay, this is like 25%. And if you want to create animations with a lot of keyframes, you should definitely use percentages. So now we could also say 50%, we want to transform, we want to translate. Now we do not just want to translate X, we also want to translate Y. So we translate to 200 pixels on the x-axis and let's say to 200 pixels on the y-axis. So let's save that. We're going to the right, we're going to the bottom, and now we're going back to the top. Let's say we're going to 75% and we want to have a translation to the left again. So we're just going to use this translate statement. We remove the first one and we obviously need to add transform. And we need to add translate 0 to the x-axis. So we're going to the left now. As you can see, we're going to the right, to the bottom, to the left, and now we're going back up to the top. And maybe it makes more sense to start at 0 right here, because that would make the animation look a little bit better. And as you can see, that is how you can animate something inside of CSS with just a few properties. Let me introduce you to filters in CSS. First of all, to apply a filter, let's use an image that we can use to apply filters on. And we take our car.jpg file and now we will give our image a class, or we don't even need a class. We're going to style our image by using the image tag. We're going to use a width of maybe 500 pixels. We're going to save the file and now we have this car basically. So let's apply some filters, and you can apply a filter by using the filter property inside of CSS. And if you just type out the filter property followed by a colon, Visual Studio Code should already suggest you a couple of filters. And one of the filters will basically be blur. You can define a blur amount inside of the blur property of 10 pixels, for example. And as you can see, we now have a blur. Instead of the blur, let's add the brightness, for example. So let's again write filter, brightness, and let's maybe say we want to have a brightness of 1, which is the base value, so the default value. We can also say we want to have 1.3, which would be a little bit brighter, 2 would be a lot brighter, and if we go to 0.5, for example, or 4, it would be a little bit darker. Now we can also increase the contrast by using the contrast property and say, yeah, let's have a contrast of 1, which is default, 2, it's a little bit more, and 0.3, it's a lot less. The grayscale basically just adds a grayscale, if you want to say so. Let's add 1 right here, let's add 0.3. So this basically just turns your image into a gray scaled image, if you want to say so. You can also use drop shadow by using the filter property. So this is a little similar to the box shadow, if you want to say so. So we could also use an X offset 10 pixels, Y offset 10 pixels, the blur amount 10 pixels, for example, or let's make a stronger blur by 20 pixels by using 20 pixels, and let's use black as the color. And as you can see, we now have our drop shadow right here. And this is basically the X value, that's the Y value, that's the blur, and that's the color. And that is just how you could add a drop shadow by using the filter property. And this is all you need to know about filters in CSS. Let's understand specificity in CSS. And in order to do so, we'll first create a div, and we'll give our div a class of container class, and we give it an ID of container ID. So we have a container class and container ID now. So let me use container class to give our div a width of 100 pixels, a height of 100 pixels, and a background color of yellow. And once we save our document, we have our styles applied to our div container. So what if I would use our ID to style the exact same element? So let me do that. Let me use hashtag container minus ID, and let's say I want to have a background color of aqua, for example, but now our div has the background color of aqua. So the container ID is basically overwritten the container class. So that means if you have a class and an ID, the ID seems to be more important than the class, and it does not just seem to be a matter of the order, because if I put our container class right after the container ID, the container ID would still override the container class. So it seems like targeting an element by ID seems to be stronger than targeting an element by class. And that is something that you just have to remember. An ID is always stronger than a class. But there's more to it. What if I would just use the div element, for example, and say I want to have a background color of bisque, for example. And as you can see, I'm saving the file and nothing seems to happen. So a normal element seems to be weaker than an ID, for example. So let me delete the ID and see what is going to happen. Once I delete the ID, you can see we now have our yellow class. So a class seems to be stronger than a regular element as well. So an element seems to be weaker than a class when it comes to specificity, and it seems to be weaker than an ID. So let me take the width and the height to the div so that we can see it. And once I delete the container class property, or the selector basically, and save the document, now we can see bisque right here. So now our element selector seems to work. So an element selector works when you only target that element by using an element selector. If you have a class selector, the class selector has priority over the element selector. And if you have an ID selector, for example, like so, the ID selector has priority over class selector and over the element selector. And now there's one thing that has even more priority than the ID selector, and that is inline styles. And you can obviously define an inline style by using style. And let's say we want to have a background color of, for example, let's take blue violet. And once we save, our container now has the color blue violet. So inline styles even override ID selectors. But usually you don't really want to use inline styles, so that is something that is not really that important because you want to avoid them anyways. In addition to that, you could also use the important keyword right here and say, okay, that one is really important, please override every other selector, and important has the highest priority. So if you use important, this will basically override anything. But again, I want to mention that this lesson, to a lot of people, this one is like really important, but to me, I think it's kind of useless. You never want to use important anyways. You should write your code in a way that does not even force you to use important in the first place. In the second place, I feel like you should only target your files in CSS by using a single class or ID. You should not use class and IDs separately to target the same element. So even that doesn't really matter. And I would not really suggest to use element selectors at all anyway. So if you have an ID and you want to target a specific element, use the ID. If you want to target multiple elements, use the classes of these elements. Element has a lower specificity, then you have class, ID, inline styles, and important overrides everything. And that's all you need to know about specificity in CSS. Let's understand how to use different fonts in CSS. First of all, we create a p tag inside of HTML, so we'll see the difference later on. So we have this font right here. And now we can add a different font by going to Google Fonts, for example, and searching for a different font right there. So we can browse fonts right here by clicking on the link. Once the website is loaded, we can basically scroll through thousands of fonts and choose a font that we want to use. So we could, for example, use JavaScript if we want to do so. And now on the website, we can press the Get Font button. And right here, you can, for example, click the Get Embedded Code button. And right here, you see two options. You can either use the link to import the font, or you can use an import statement to import the font. And all you have to do is basically copy the code right here. If you copy the link, you're going into your head in the HTML file, and you just copy your links in there. And now you can use the font by copying the font family line, for example, going into your CSS file. Now we can, for example, target the paragraph. We go back to our page to see the difference. And now we paste the font family, StoryScript, sans serif in there. And we'll save our file and you will see a difference. And now, as you can see, we have a different font right here. Now, obviously, the link is just the first option and there's a second option, but I usually prefer the link option. But you can obviously also like delete this again. Now we have our base font again. And now we try to use the import method. So we are going to go to the add import method right here and we'll copy this link And as you can see, we need to import this one in a style sheet. So we are going into our style CSS, which we are already in basically. We're going to paste this URL. And now again, we can copy the font family, story script, sans serif. We're going to paste that into the brackets of our paragraph. We'll save our website. And again, we have the same outcome. So we basically have our font once again. This time we use the import method. I would highly recommend you to use the link method though, because that one is better when it comes to performance and loads the font a little bit faster, because obviously the head gets executed prior to the CSS file. So head gets executed, you load the font, and you immediately have the font. And the other option is obviously you load the font once you load the CSS file, and that might take a little longer. So definitely recommended to use the link inside of the head when importing fonts in CSS. And that's all you need to know about fonts in CSS. So I've defined an H1, an H2, and an H3 inside of this HTML document. And now let's use variables to create a style for those headings. To define a variable, we have to use colon, root, followed by opening and closing brackets. And inside of this root element, we can now define our variables. So let's say, for example, we want to have a variable dash dash Goku, for example. So you use a dash dash followed by the name of the variable that you want to use, followed by the value for this variable. And then in our case, let's say the variable has the value black, for example. Now let's also create the variable dash dash Vegeta, for example, which will have a value of blue, for example. And obviously you can also use useful names like dash dash primary, for example, or primary color, which could be yellow, for example. So now we have three variables right here. To use those variables, we can now say h1, for example, should have a color. So we define a color property. And now to use a variable, we use the var keyword, followed by opening and closing brackets. And as you can see, we can now select the variable we want to use right inside of those brackets by using dash dash and the name of the variable. In our case, let's use dash dash Goku. And maybe Goku doesn't make too much sense because Goku is black as well. So let's use Vegeta probably. That wasn't probably the smartest move. But we need a different color. And as you can see, now we have a blue text right here for Vegeta. And we can also use dash dash primary color right here. So now we get this effect. So as you can see, by using variables, you can start to define a lot of styles. You can also say dash dash border radius, for example, and you could say your border radius should be 20 pixels, for example. And now you would have a variable that defines the border radius for your document. So every time you want to use the variable, you're just going to use var followed by the variable name. And if you want to change the border radius for the entire document, you don't have to go into every single element, for example, H1, H2, and change the radius, but you can just go to this one spot and say, okay, the entire document should now have a border radius of 10 pixels, for example. Or we want to use a primary color that is probably not yellow, but maybe red, for example. And as you can see, or orange, and now we have this orange text right here. Let me introduce you to object-oriented CSS. And in order to do so, we will first of all create a div. And in my opinion, object-oriented CSS is the most efficient way to write CSS code. And therefore, I really recommend everyone to use object-oriented CSS when it comes to writing CSS code. And object-oriented CSS just means that you separate structure and skin. So let me give you an example. Let's say we have the class of box, and that box has a width of 100 pixels and a height of 100 pixels. And that dot box notation is basically the structure of an element because it defines the structure, so height and width of an element. In our case, of a box. Now we could create a second structure, for example, of circle, and now we can again use a width of 100 pixels and a height of 100 pixels and a border radius of 50%, for example. So we get a circle. And now that is again the structure because it defines the structure of a circle. So what if we want to use different colors, for example? We could, for example, create one class for dot yellow, if we want to say so, and that one will have a background color of yellow. Now we could create a second class for dot green, and that class will have a background color of green, for example. Now we're going to save our file, and if we want to create to this, for example, let's say our first div should have a class of box. Now we have a box, but we can't see anything because we don't have a color. So let's say we want to use yellow as the color, and we're going to save our file, and now we have a yellow box. And if I want to have a yellow circle now, for example, instead of a box, I can just replace box with circle. And as you can see, now I have a yellow circle. I can go ahead and for a second class, I can, for example, say I want to have a box, and a box should be green. And now I have a green box. I could also get a green circle though if I wanted to get so by just changing that one class. And as you can see, now if I want to have a box, I just have to change from circle to box. And if I want to have a different color, I just have to change the color. Otherwise, if I wanted to have one box here and then another box here, I would need two classes. But imagine I would like want to have 10 circles and every circle has a different color. Now I would obviously have to copy this box 10 times basically and give every single box a different background color like this. So box 1 would have background color green, box 2 maybe blue. I mean, you get the idea. It's not like I have to type all of this out. But in our case, we just need those 4 classes, and I can say, okay, now here I probably have yellow again. Here I could, for example, have blue. Then I could have aqua, for example, and so on. And I could also create like more classes. I don't just need to have a box and a circle. I could also like have a rectangle. And now I can give that one a width of, for example, 200 pixels and a height of 100 pixels, if I want to say so. And then I can go ahead and maybe I can create a rectangle. And I think you understand that, especially when having a lot of possible combinations, and when you use colors you usually have a lot of possible combinations, this style of writing CSS is very efficient. You could also like create one class for center, for example. So whenever you want to have something centered, for example, you can just use that class and it would center basically an item. So if I want to have a circle center, for example, I can use center as a class right here. And now, whoops, control needs to be center. And now once I save, I have my item center basically. Now I could obviously also create a class for flex centered. And I could create one class for flex, whatever. I mean, you get the idea. You can create a lot of different classes, and each of these classes has a different purpose. And this obviously makes especially sense to basically separate structure from skin. And this is why I recommend everyone to use object-oriented CSS when writing CSS code, because it, first of all, in my opinion, looks a lot better and it makes everything a lot cleaner and easier.
It's your favorite NPC, and today I teach you everything you need to know about JavaScript. We go through variables, data types, functions, loops, if statements, arithmetic operators, and a lot more. Most courses don't really show how to use JavaScript for the web, but that's exactly what it is made for. So later in this course, I also show you how to use JavaScript to select, add, update, delete, and manipulate HTML elements directly on a website. So let's go. What is JavaScript and why should you care? JavaScript is the language that makes the web come alive. Buttons that react to user interactions, animations, dynamic user interfaces, all of that is JavaScript. And it doesn't stop there. The same language runs on servers, powers mobile apps, and can even be used for games. So should you learn it? In my opinion, definitely yes. JavaScript is one of the most widely used languages worldwide. It has a massive community, is essential for building websites, and opens doors to many other areas. So what does it do? It's essential if you plan to build interactive websites, APIs, games, chatbots, and more. In addition to that, the most important web frameworks like React are built on top of JavaScript. Learning JavaScript is one of the most important steps for any developer, and it's quick to get started. To get started using JavaScript, we will need a code editor, and you can use pretty much anything you like, and I recommend you to use Visual Studio Code. So you can, for example, go to Google, type in Visual Studio Code, go to the first link right here, click on the link. Once the page is loaded, you can press this download for Windows button, for example. Once it is downloaded, you can press on this file right here. Now we have to accept the agreement, press next, next, install. Now we're waiting for the installation to finish. And now we can just press finish right here. Your Visual Studio Code should look pretty similar to mine right here. Now we can install a couple of extensions that I recommend you. The first one is going to be the live server. So you type live server in here. Now let's select the first icon right here. And right here, you should have an install button. So just press this install button. The live server helps us to open an HTML file and get live updates for our website. So let me show you. We can create a project, for example, by saying that we want to open a folder. So we can go to the desktop, for example. let's create a new folder. So we can, for example, say new folder JS course. Let's create that folder. We're going to select this folder. And now we created our project right here. And every file we will create right now will be created within this folder. So we can, for example, create an index.html file. Let's create a basic template by using the exclamation mark. And now the power of the live server is that we can use open with live server right here. This will open this inside of a live server. And every time we have changes inside of our document, we just have to save and the live server will automatically update our website. So this is the power of the live server. The second extension that I recommend will be Code Runner. You don't really need that one, but I'm going to use this one during the code because Code Runner helps us to run JavaScript code inside of the console. Let me show you. So again, you can just go to the first one right here. Once you typed in Code Runner, now you're going to press install. Once you've installed it, you can now, for example, create a index.js file, so a JavaScript file. You don't need to understand this yet, but just remember this is a JavaScript file. And now we can, for example, write some JavaScript code. You don't need to understand this code yet as well. But now since we have Code Runner, we can right-click the file and press Run Code. And this will execute our JavaScript code inside of the console. But again, for this tutorial, it's not really necessary for you to have Code Runner. I just want to explain this so you understand what is going on. How can we use JavaScript? To use JavaScript instead of HTML, there are three possible ways. The first one would be using the script tag. Usually you use the script tag at the bottom of the body. So let's first of all create the script tag. You have an opening tag and a closing tag. Instead of those tags, you can write JavaScript code. What would be the easiest line of JavaScript code? That one would be, for example, console.log hello guys. You end every single statement in JavaScript by using a semicolon. What does this line right here say? This one says, go to the console and log the statement hello guys, for example. So whatever you have inside of those brackets will be executed and output inside of the console. What is the console? Usually when we talk about the console, we're talking about the browser console. So I can, for example, say that we're going to right click and open that page with a live server, for example, just to get our updates live. Now you can right click anywhere on the page and press inspect. If you press inspect, you have this HTML overview of your entire document and you also have this console right here. And as you can see, inside of the console, we are getting hello guys right here. Why are we using the script tag at the bottom of our HTML file? The reason for this is that we want JavaScript code to be executed after our HTML code. Because first of all, you usually want to execute the entire HTML code. So if we have this header, for example, that says npc ayo, we want this header to execute first because maybe instead of our JavaScript code, we want to manipulate this h1 tag. If we would run the script right here, first though, we would try to manipulate this h1, which does not even exist yet because the HTML code has not been executed yet. So it's important to use the script tag at the bottom after you executed all of your HTML code. Now the second option would be to use a script link, for example. So you can also say script and let's say :module, for example. So right here we have a script of type module and a source attribute right here. So this is similar to CSS. Instead of the source, you need to define a path to an external JavaScript file. So we don't have this JavaScript file yet. So we can, for example, create one by saying index.js. You can use any name right here. You can also say ayo.js, but it's important that the ending is .js, which stands for JavaScript. So let's just use ayo.js to show you that this one works. We're going to link to our ayo.js file instead of the source attribute, which defines the path to our file. Right now, this is the path. Let's go to our website. And as you can see, we don't have anything inside of the console because we don't have any JavaScript code yet. So let's do the same thing again. Let's go to the console and use console.log. npc has no biceps. Let's console.log that one. And as you can see, we are getting npc has no biceps. So this one works as well. Now, the third option is to use the script tag instead of the head. Usually, a lot of people will say that this is something that you should not do because obviously the head will be executed first. And as I said, you should pretty much never execute your JavaScript code before executing your HTML code because you might want to manipulate HTML elements instead of JavaScript. but if those HTML elements have not been rendered yet, you will get a problem and an error. So how does this work? You can define a script tag instead of the head, and I recommend you to use script:module, because this defines this as a module. You don't need to know what this is right now, but remember, this might be a little bit better. And now again, we need to define a source. The source is again ao.js. So this one looks exactly the same as the previous one, right? And like this, it would be pretty bad. So there's one attribute that you definitely need to set if you want to use a script tag instead of the head, and that is the defer attribute. As you can see, this Boolean attribute is set to indicate to a browser that the script is meant to be executed after the document has been parsed. So this means wait for the HTML code to execute, and after the HTML code has been executed, execute the script. And by using this method, you can also embed the script inside of the head. And I usually prefer to keep my script in the head, but remember, all of those methods work. So as you saw, you can use the console to output JavaScript code, but there's also a second way, which is the code runner, so the plugin that we've installed previously. So we can just go and click on run code. We'll open a terminal, and the JavaScript code will be executed. I will use code runner from time to time because this makes it visually more appealing for you guys, but remember that you can just use this console right here in the browser. There mainly exist three ways to define a variable, and the first one is using the var keyword. So we can, for example, say var followed by the variable name, which could be name, for example, and now we could either end the variable declaration by using a semicolon, or we can directly assign a value to our variable, and we can do so by using the equal sign followed by the value we want to assign to our variable name. So we could, for example, say our name is Pascal, for example. And now we end that statement by using a semicolon. The second way would be to use the let keyword. And now we can, for example, again say let first name, for example, be equal to Jonas in our case. And this would be another option to declare a variable. And the third way would be to use the const keyword. And now we could, for example, say last name equals whatever. So now we have three different ways to declare a variable, but what is the difference between those ways? Using the var keyword was basically the old way, and variables defined by using the var keyword usually have a function scope. We'll get to that later on, and this is something you definitely want to avoid. So from my experience, never ever use var. So let and const are basically the modern ways to define variables. And the difference between let and const is that let is basically reassignable. So I could, for example, go here and say first name now equals Pascal as well, for example. And this would work. But if I would do the same with our last name, which has a const variable, it should not work and we should get an error. If I say, for example, let's say, hey, and this is our last name now, and now I want to console.log our last name, for example, and I'm going to run the file, you can see that we are now basically getting an error inside of the console. If I go ahead and delete the last name and just log our first name though, and I run the code once again, as you can see, we now get the output inside of the console and everything works just fine. It's also a convention that you use capital letters when you're declaring a constant variable. And a good example for a constant variable would be pi, for example, which is equal to 3.14 whatever. And for variables defined using the let keyword, you usually use camel case, which basically means the first word of a variable uses only lowercase letters, while every other word uses a capital letter as the first letter. And an example would, for example, be camel case. And as you can see, first word only lowercase letters, and the second word starts with a capital letter. And if I would have another word like another word, this is how you would do it. And this is just a convention, so it's good if you just keep that in mind. Let's understand data types in JavaScript. When defining a variable like our first name inside of JavaScript and assigning a value to this first name, we implicitly tell JavaScript that we have a specific data type. And in our case, this data type is a string. So if we are going to console.log the type of our first name, for example, we will see that in our console we now have string. So this one is basically a string. A string is basically just a number of characters, so plain text. To tell JavaScript that this is a string, we are usually using quotes, and you can either use double quotes like this, for example, or you can also use single quotes, and you can also use the backtick character, for example. So all of this basically works to define a string. And a string could be our name, obviously, for example. The second data type would be a number, for example, which is basically, as the name implies, just a number. So we can, for example, say let age be equal to 27, and this would be the data type number. Boolean is basically either true or false and is mostly used to implement logic. So we can, for example, say let is above 18, for example, be equal to true. Now, if we just declare a variable, for example, by saying let hello, and now we use a semicolon, so we don't assign a value, and now we're going to console.log the type of hello, for example, we will now be able to see inside of the console that the data type is undefined. So undefined basically just means that the variable has not yet been defined. But you can also say that our variable hello should be equal to null, which basically means we are explicitly saying that this is an empty value. And now to check whether hello has a value of null, we can use hello equals null. And if this is true, we are going to see true inside of our console. So we're going to run the code, and as you can see, we now have true. If we are going to set this one to undefined, for example, and if we rerun the code, we now get false in the console. So those are the most important primitive data types in JavaScript. Let's understand the type of operator in JavaScript. Let's imagine we have a variable like first name, and that first name equals a string of Pascal, for example. And now let's use console.log, and let's imagine we want to know the type of our first name. So let's say we are going to use type of by writing type of, and now we are going to use our first name. And by using this statement, we will get the type of our first name variable. If we are running the code now, we will see that we have an output of string. So our first name is basically a string. This could obviously also work if we would have an age like 24, for example, and now we want to know the type of our age, and we are going to run the code again, and now we see that this type of age is basically a number. And this is especially useful when working with if statements, for example, later on, and you want to compare the type of a variable to, for example, another type. Using the plus operator with strings and numbers has a different meaning. Let's imagine we have a first name, which is equal to Pascal, for example. Let's say we have a last name, which is equal to whatever, for example. And now we'll use the plus operator inside of a console.log statement by using first name plus last name. What do you think is going to happen if we use an arithmetic operator on strings, for example? Let's just run the file, and as you can see, we now have Pascal whatever. So when using the plus sign with strings, it basically just concatenates both of the strings. And I could, for example, also go ahead and say I want to add another string in between, and I just want to add some tabs, for example. And if I'm going to run the exact same code, you basically see that I added some tabs in between those two words. So you can concatenate as many words as you want. If I use numbers, for example, though, let's say I have a num1, which is equal to 10. And if I use a num2, which is equal to 20, and I'm going to use num1 plus num2, it now does not concatenate those two numbers, but rather just uses addition for those numbers. So when using a plus sign with numbers, use it for addition. When using it with strings, you just use it for concatenation. Let's understand the most important operators in JavaScript. Let's imagine we have num1, which is equal to 5, for example, and we have num2, which is equal to 10, for example. Now we can, for example, create a third number, which is equal to num1 plus num2. And now let's just console.log num3 inside of the console. And once we run our code, you can see that we have 15 inside of the console. Besides addition, we can obviously also use subtraction. And if we run the code, we now get -5. To multiply two numbers, we can use the asterisk symbol. To divide, we can use the division symbol. To get the remainder, we can use the percent sign. And I want to show you how this one works. Let's say we have 15, for example, for the first number, and let's say we have 10, or let's say we have 5 for the second number. Now, if we use this modulo operator, so this percent sign, and we're going to run our code, we'll have 0 inside of our console. Because if you divide 15 by 5, you basically have a remainder of 0. Because 15 divided by 5 works perfectly fine. But if we say 17, for example, divided by 5, we can divide 15 by 5, and this works perfectly fine. But 17 divided by 5 does not really work, and you have a remainder of 2, for example. So this will output the remainder, and I'm going to show you how this works. So we're going to run the code, and now we have a remainder of 2. And now to raise num1 to the power of num2, we're basically going to use the asterisk symbol twice. So now let's save the file and run this code again. And as you can see, we get this number. To make it a little bit easier, let's say we're going to raise the number 3 by the power of 2, and let's run the code, and we get 9. So now let's imagine we just have num1 and we are logging num1 inside of the console. Now to increment num1, we could also go ahead and say num1 is equal to num1 plus 1. And this would obviously increment num1 by 1. And if we're going to log this in a console, we obviously get the value 4 because 3 plus 1 is 4. Now there's also shorter spelling for the exact same thing by going ahead and saying num1 plus plus. And this means exactly the same. And now if we are going ahead and logging this in the console, we again get 4. Obviously, you can also use the decrement operator by using minus minus, and now once we log this in the console, we get 2. There are also different modifications to the assignment operator. So now as you saw, we can basically say we want to assign a value to our number by using a single equal sign. And this basically means whatever you have at the right will be assigned to the variable at the left. Now there also exists a plus equal sign. So if we are going to say num1 is equal to num1 plus 10, we are basically saying take num1, which is 3, and add 10 to this number. Now there's also a shorter way to say the exact same thing by using plus equal, for example. And now we can, for example, say we just want to add 10. And this basically means as much as num1 is equal to num1 plus 10. And now if we are going to log this in the console, we get 13. Obviously, you can also do minus equals, and this just means take num1 minus 10. So we're going to run the code and we get minus 7. You can do the same with multiplication and with division, for example. Let's understand escape characters. Let's say, for example, we want to console log text inside of the console. So let's say, hello, this is my story, for example. And as you can see, this works perfectly fine. If I'm going to run this in the console, we get, hello, this is my story. But imagine I wanted to put this into quotes, for example. And as you can see, this doesn't work because I obviously can't use quotes inside of quotes because quotes tell JavaScript that this is a string. And this is basically a syntax that is not allowed. And to get rid of this error, there exist escape characters, which are basically just indicated by using a backslash. So if we use a backslash, for example, as you can see, this right now works. And now we can use another backslash right here, for example, in front of our quotes, and this basically starts to work. And as you can see, once I save the file, VS Code automatically just replaces the double quotes with the single quotes because this would be an alternative. So you can just use the double quotes inside of the single quotes, and if I'm going to run the code, we get this output where we have the quotes. Obviously, this does not just work for quotes. We could also use the escape character on an escape character, for example, because obviously the escape character has a special meaning inside of JavaScript, so you can't usually just use an escape character. So if you want to use an escape character, you have to escape the escape character, basically, if you want to say it like that. And now we basically have one backslash right here next to our this statement. You can obviously also do the same for new line, for example. So by doing this, so by using this syntax, you can create a new line, as you can see here. And you can obviously also do the same for a tab or a single quote, for example. Let's understand how to work with text. There are several properties and methods you can use when working with strings, and I'm going to show you the most important ones. So let's use a console.log statement, and let's say we want to have the length of our text. So let's use short text.length to access the length property. And now once we save the file and we're going to run the file, we can see that we have 32 characters. So this string basically contains 32 characters. So let's imagine I want to access the first character of a string. And I can do so by using the index notation. So basically by using the bracket notation. So we're going to say that we want to access short text. Now we use the brackets. And now let's say we want to get the first character. And when using JavaScript, counting does not start from 1, but it starts from 0. So our first character has the index of 0. Now we're going to save this and we're going to console.log this. And as you can see, we now have an age. So now let's say we want to have the second character, which has the index of 1. Age is 0, E is 1. So now we should get the character E inside of the console. And as you can see, we get E inside of the console. Now let's say we maybe want to have the S right here. So we are going to start here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and s should be 16. So let's see if this works. We're going to run the code, and as you can see, we're getting an s. So this is basically how counting in JavaScript works, and understanding how counting in JavaScript works is not just important with strings, but with pretty much everything. So just keep that in mind. So let's imagine we wanted to transform this text to uppercase. Then we can just go ahead and use the dot to uppercase method by doing so. And every time you access a property, you're just going to write it like this. And if you want to use a method, you're going to use opening and closing brackets. And if you're using VS Code, you'll also get an indication right here if you're going to hover over the property or method, whether this is a property or a method. And as you can see, we have this method indicator right here. So we know for sure that to lowercase, for example, is a method. So let's use to lowercase. And if you hover over the method again, you get an indication right here, which says that this is a method, which tells you, okay, I need to use brackets. As you can see, we now have everything in lowercase, which does not change too much because only our H basically had a capital letter, but yeah. So let's do the exact opposite, and let's say we want to have to uppercase, for example, because right here we should really see a change. We're going to run the code, and as you can see, we now have everything being uppercase. We can also use dot includes to check if a substring exists, for example. So let's just go ahead and use dot includes, and now we can define the substring we are searching for. So let's see if we have this inside of our short text, for example. We are going to run this and we are getting true because this obviously exists. Now let's say this, for example, we're going to save this, we're going to run the code, and now we're getting false because this with two s's does not exist. The index of method, for example, gives you the index of a certain substring, for example. So let's say we want to get the index of this. We're going to save the file, run the code, and index 5 is basically the index of this, because we have 0, 1, 2, 3, 4, and 5. If we want to slice out a part of a string, we can use the slice method by defining a start and an end index, for example. So let's say we want to use slice and we want to get the word this, for example. Then we're going to start at letter 5 and we're going to go up to 6, 7, 8, and let's go to 9 because the last letter is basically excluded while the first letter is included when using the slice method. So let's run the code and we're getting this. Substring is pretty similar to slice. We're going to run the code, and as you can see, we're getting the exact same result. We can also say that we want to use replace, for example, and we can say we, for example, want to replace this instead of our text with bro, for example. And now we're going to save this and we get, hey bro, is my short text, yup. And obviously this mustn't make too much sense, but as you can see, this kind of works. We can also use the split method to split a string into an array, for example. So we are going to use the split method right here, and let's define a character where we want the split to happen. So let's say every time we have a space bar, we want to have a new item inside of our array. So now let's just save this. Let's run the code, and now we have this array which has a new item every time we use a space, for example. So we get an item in our array for 8, for hey, for this, for is, for my, and so on. And you don't need to understand arrays just now, but keep that in mind for later. And now let's imagine we are working with a website and we have a user who puts in like 100 white spaces at the end of our string, for example. And obviously this is nothing we want to save in our database, for example. So what we can do now is we can use the .trim method to trim the text. So basically to remove every white space from the end or from the beginning. So let's save this, let's run the code, and as you can see, we now get this text which should not have any white space in the end. I think it's better to visualize this once we get white space in the beginning. Let's just save this, let's run the code, and as you can see, we have a lot of white space right here. And if we use our .trim method right now and we're going to run the code again, as you can see, we now removed all of the white space from the beginning. There are a couple of important math functions in JavaScript that you might use from time to time, and I'll show them to you. The first one is math.round. So let's console.log the result, for example, of math.round, and let's say we want to have 1.34. We're going to save this, we will run this code, and as you can see in the console, we're getting 1. So math.round essentially just rounds this number. So for anything below 0.5, it will take the smaller number, and for everything greater or equal to 0.5, it will take the bigger number. If you always wanted to have the smaller number, you could use math.floor instead of math.round. And now we're going to run this code, and now you can see we still have 1. We can also say, let's say 1.4, and now we're going to run math.ceil, and this will always use the bigger number, or round up to the bigger number. If you want to determine the minimum or maximum value, you can use math.min, for example. So for math.min, let's for example say we have 1, 2, and maybe 3, and we're going to run this code, and we're getting 1 because that is the minimum number. Now we can also use math.max. We're going to run the code again, and now we're getting 3 because this is the biggest number out of those numbers. Now you can also use math.pow, for example, to raise one number to the power of another. So let's, for example, say 2 to the power of 2, for example. Let's run this code, and this should be 4. But, for example, if we would say 2 to the power of 3, for example, then it would be 2 times 2 times 2. So essentially this will be 8. So this works exactly like, normal math. We could also say that we want to get the square root of a certain number. So let's, for example, say we want to get the square root of 16, which should be 4. So we're getting 4 right here. If we want to get the absolute value of a number, so we just want to get the value without a minus or whatever, then we can just say, okay, let's get the absolute value of minus 17, for example, and the absolute value will be 17, because the value of minus 17 is 17. If you just want to get the sign of a certain number, you can use math.sign, for example. Let's run this code, and right here you can see we're getting -1 in the console. Now let's do this, and we're getting 1. So essentially, if you have a negative number using math.sign, you get -1. If you have a positive number, you get 1. And let's also test what is going to happen once we use 0. And as you can see, if we use 0, we get 0. Then we also have math.py to return pi to the user, so you don't have to memorize it or type it out. You can just use math.py like this, run the code, and now we are getting this number. And we can also say we want to get Euler's number, so we can use math.e, for example, run this code again, and now we're getting this number as well. So you don't have to remember pi or Euler's number, and you can just use math.py or math.e to print out that number, for example, or use it for your calculations if you wanted to.
Let's learn about arrays in JavaScript, and there are two ways to define an array. And the first one is to basically just define a variable like fruits, for example, and now we can create an array by using brackets. And imagine an array basically as a list of items, and inside of these lists you can save pretty much whatever you want. We could, for example, say let's have an apple inside of this list, let's also have a banana inside of this list, and let's also have an orange inside of this list. And you separate these items by using a comma. And now let's, for example, say we want to log these fruits inside of the console, and if we run the code, we can basically see this is how the array looks like inside of the console. But arrays are basically not just limited to one certain data type. We could also obviously say we want to add some strings in here, but we can also add some numbers, for example, right here. And now we could also add Boolean values if we wanted to. And this in JavaScript works perfectly fine. If you want to access a certain element inside of an array, you can again use the bracket notation. And now let's say we want to access the first element inside of our array. Now we can do so by using the 0, for example. And again, for arrays, similar to strings, counting starts from 0. So our first item is the item with number 0. Our second item is the item with the number 1, 2, 3, 4, 5, and so on. And now once we save this and run the file, we get apple inside of this list. So let's say we want to have our second item, which is banana. We can do so by using the index 1, and we can access banana. The second method to create an array would, for example, be let sports be equal to new array. So the new array syntax would work exactly the same. And now you use opening and closing brackets. And inside of those brackets, you can also define your items. Now we could, for example, say football, let's say soccer, and 2 items are enough for the demonstration, I'd say. So now let's just log sports inside of the console, and now we get football and soccer, so basically an array as well. And obviously we can access the items the same exact way. You can also create nested arrays. Let's say we want to have a nested array, which includes, for example, an array, and inside of this array we want to have more arrays. So let's, for example, say we have an array inside of this array, and the first array includes some numbers, for example, and let's say our second array includes some fruits, for example.
And let's have a third array, which includes maybe Boolean values. And now we have nested arrays. So we have arrays instead of arrays. And now we can console.log our nested array, for example. And this works perfectly fine. As you can see, if we want to access an item though, we are now going to use a 0 to access the first item inside of our array. And obviously the first item inside of our array is again another array. So we are now going to get this item because this is the first item inside of our first array. So we're going to run the code. We're going to save this, run the code, and now we get this first array as mentioned, which is just the first item inside of our first array. Let's imagine we want to get this first item inside of our nested array though. So now we first have to go to our first item inside of our first array, which is obviously this array. And now we need to access the first item inside of this array. So we can access this item by using brackets twice basically. Now we are going to save this and run the code. And as you can see, we now get a 1. So now let's imagine we have a nested array inside of the nested array. So let's say we have arrays in here as well, 1, 2, 3. Now we have another array, 4, 5, 6, for example, and we're going to save this. So now we have a nested array inside of a nested array inside of this array. So now we can access our 4, for example, by saying, let's go to the first item inside of our first array, so 0. Let's go to the first item, or to the second item in our case, inside of our array. So we're going to use a 1. And inside of this array, we want to access the first item again. So we use a 0. We're going to save this, run the code, and now we get the 4 as mentioned. And for a lot of beginners, this might be a little bit confusing, but I just recommend you to test it a little bit and you'll definitely get the hang of it. Let's understand the most important methods when working with arrays. So let's imagine we have an array, for example, which is our numbers array, for example, and this numbers array includes numbers from 1 to 5, for example. Now let's say we want to add an item to the end, for example. Let's say we want to add the number 6. So we can go ahead and do so by using numbers.push. So the push method allows you to add an item to the end of an array. So now we can say, for example, we want to add the number 6 to the end. And now we are going to console.log our numbers. And you will see that we now have an array that includes the numbers from 1 to 6 because we added the number 6. Now let's say we added this number 6, but we want to remove it once again because we don't like it. So we can do so by using numbers.pop, for example. And this will just remove the last item of an array. And since we have 1 to 6 right now, and we're going to remove the 6 once again, we should now just have the numbers from 1 to 5. And as you can see, we now have the numbers from 1 to 5. So let's remove our push method, for example, and just run this again. And now we will remove the 5 and we will have the numbers from 1 to 4. Something you should probably remember when using the pop method is that the pop method returns a value. So we can, for example, say let returned number be equal to numbers.pop. And now we can console.log the returned number, and numbers.pop basically takes the number 5, pops it from the array, and now stores it inside of returned numbers. So inside of this variable. So we're going to run our index.js once again, and we now have the number 5 inside of our console because this was the number that we basically took from our array, and now we saved it inside of this variable. The equivalent for pop is basically shift, which removes an item from the start. So in contrast to pop, it does not go to the end of an array, but rather goes to the start of an array and removes an item. So now we should basically get the number 1, remove it from this array and store it inside of returned numbers. So if everything worked, we are going to get 1. And this worked, as you can see. So now let's also go ahead and console.log our numbers, which should now be everything from 2 to 5. And as you can see, this is how it just worked. We can also obviously add an item to the beginning of our array by using the unshift method. So let's go and use unshift. And now let's, for some reason, just say I want to add a basketball to the beginning of our array. So I'm going to do this and run our index.js file. And as you can see, we now have a basketball in the beginning of our array. Let's understand a function inside of JavaScript. Let's imagine you have a console.log statement that allows you to console.log the number 15, for example. And now you have another console.log statement that allows you to log the number 14, for example. And now you just run the script
and this will output the number 15 and 14. Obviously, if you would have a lot more console.log statements, for example, or pretty much anything else, it would get kind of repetitive. And this is where you can use functions. A function basically allows you to execute the same code by using just one line over and over again. So you can define a function by using the function keyword. Now you need to give your function a name, which could, for example, say log in the console, or whatever you want to use. After the name, you use opening and closing brackets where you can add some arguments, and we'll get to this later on. And then you have the body of your function, which is indicated by opening and closing brackets once again. And inside of this body, you can define what you want this function to do basically. So let's say we want to log something inside of the console. So let's remove this console.log statement. And let's say inside of the console, we want to write hello from this function, for example. And now we're going to save this function or this document. And if you're going to run the code, you can see that we're basically not seeing anything. And the reason for this is we just defined the function, but we didn't call the function yet. And if you want to use a function, you always have to call the function. And you can do so by using the exact same name that you defined for the function and writing it out. And then by using opening and closing brackets followed by a semicolon. And now you can save the file, run the code, and as you can see, we now have hello from this function. And now we can obviously also duplicate this function a couple of times. And if we run the file again, you can see that we just executed the code inside of this function block a couple of times. So obviously for this use case, it might seem kind of useless, but imagine we would have a lot more console.log statements in here, for example, or like usually function blocks are a lot more than just this, obviously. But let's say we just have some more console.log statements. And by using this, for example, let's have some different statements right here. And by using a function, we now can create all of those console.log statements just by typing out the name once. And I understand that it might not make too much sense if you just see this example, but especially when your functions get extremely complex, it might save you, or it will save you, a lot of code. So this is why functions are super important in JavaScript and in pretty much every programming language. Another thing that is really useful about functions is that you can define parameters inside of this function. So let's say we want to have a first name as a parameter, for example. And let's say we also want to have a last name. And now inside of this console.log statement, we, for example, want to greet a user. So let's say we're going to use console.log, and now we'll add our first name, for example, followed by a space, for example, and now we'll also add the last name. And now if we are going to save this code and run the code, as you can see, hello, undefined, undefined, because we didn't define anything inside of our function. So now if we define a parameter, we should ideally also, inside of our function call, define the arguments that will feed basically those parameters. For example, we could say that the first name is, for example, Jonas, and the last name is, for example, Bro. So now we have a first name and a last name defined as an argument. The function will basically take this argument, put it in here for the first name. So this one will be the first name, and this one will be the last name. And now it's going to console.log hello, first name and last name, because this is what we defined inside of our function body. So let's just run this code and we will see hello Jonas Bro. So as you can see, by using parameters, you can define pretty complex logic inside of your function, and this function will now behave different for every input you use for this function. So now we could also greet, for example, someone else. We could, for example, literally greet someone else if we wanted to do so. And now we could run the function once again, and now we are greeting Jonas Bro and someone else. As you can see, by using those parameters, you can make functions extremely flexible. And also, just a short note, when defining the function, you basically call these things parameters, and when calling the function, you basically call these things arguments. So this is just a naming convention, doesn't really matter too much, to be honest, but yeah. Let's understand the return statement. So let's imagine we want to create a function that basically adds two numbers. So we have num1 and we have num2, for example. And inside of this function, we want to add num1 and num2. But if we are going to call this function right now with two numbers like 5 and 10, for example, and we're going to run the code, you will see that nothing is going to happen. So as you can see, literally nothing happened. So how can we change that? Obviously, we could just go ahead and console.log those numbers, but maybe we don't want to console.log those numbers. Maybe we want to store those numbers in a variable. And this is when you can use the return keyword. So you can, for example, say whatever the value of num1 plus num2 basically is, just return this from this function. And now we could, for example, say that we are going to generate a num3, for example, and this one, or a result. And this result basically gets returned whatever this function returns. So let's say we want to have 10 and 10 for this one. So we are going to execute this function. This function takes 10 and 10, basically adds 10 and 10. So we will have 20, and 20 will be returned to our variable. So now we have this result, and now we can, for example, say let's console.log this result to see the result. We're going to execute the code, and as you can see, now we have 20. Since this function now returns something. And returning something is really, really important when working with JavaScript, because obviously you often want to store those values that you generate with a function instead of a variable, for example, or do pretty much anything else with it. Something that is really important to note is if you have like two return statements inside of a function. So let's say we have a third number like num3, for example, and now we also want to return num2 plus num3. And as you can see, this here is already grayed out, because once one return statement inside of a function gets called, the function also stops basically. We are not really there yet, but you'll understand the purpose of having several return statements inside of a function later on. So this is something I just want you to be aware of. So, but yeah, usually once you hit the first return statement, the function basically stops. In some cases, you want to create a default parameter for a function, for example. So imagine we have this greet function, and we are just going to console.log, for example, hello, and then we will, for example, add a first name, like so. So now we obviously also need to accept this first name inside of our function as a parameter. And now we can call this function, so greet, for example, and say Ali, for example. We're going to run this file, and as you can see now, we will see hello Ali, because we are calling this greet function with a value of Ali. But now let's, for example, say we also want to define a default value in case the user does not enter a name. So we can just use the assignment operator and say that our default name should be Jenny, for example, in case the user does not enter anything. So now we can also call the greet method by not using any arguments at all. And this is completely fine right now, since we have a default value, so a fallback value. We are going to run the code, and as you can see, one time we are seeing hello Jenny, and the other time we are saying hello Ali. Since right here we don't have any arguments at all, and right here we define an argument of Ali. So it's as simple as that. And obviously you could also say the age is, for example, 25 if the user doesn't enter an age, and now you can, for example, say plus you are plus age, for example. We're going to run this again, and as you can see, now we also have an age. Right here, we are defining a function inside of JavaScript, but there's also a shorter way. So let's imagine we want to create a greet variable or a greet function, but we are defining it as a variable, and this greet variable is equal to an arrow function. So let's take a look at the syntax of an arrow function. An arrow function always starts with a pair of parentheses, and you can place your parameters inside of this pair of parentheses. So you can, for example, say we want to accept a first name. Now an arrow function has the name arrow function because you use an arrow right here. Now you again have an opening and a closing pair of parentheses, and this is basically your method body. So right here you can, for example, say console.log, and let's just console.log our first name. You could also write this exact same function by using this function keyword, but you can also use an arrow function. And in a lot of cases, an arrow function might be the more convenient way to do it. And if you wanted to call this function, for example, now you could just do it like a normal function, and let's pass in a first name, for example, and now we're going to run the code, and you should see Pascal in the console. Let's understand the if statement, and the if statement works basically exactly the same as in reality. So imagine if it rains, it's basically rainy, and if it doesn't rain, it is sunny. So you can do the exact same logic inside of JavaScript, for example, by using an if statement. So let's imagine we have a variable that said let rains be equal to true. So right now it's basically raining, and now we can use an if statement to check whether it's raining or not, and if it rains we do something, and if it doesn't rain we do something else. And we can do so by using the keyword if
which says that we are going to use an if statement, then we are going to use opening and closing brackets, and inside of those brackets we are going to use the condition, and the condition right now is if rains is equal to true. Now we are going to use opening and closing brackets once again, and inside of these brackets we are going to say what we are going to do if it rains. So if rains equals true, and this here is basically the comparison operator, which basically means if the thing on the left is equal to the thing on the right. And if it rains, we are going to console.log it is raining, for example. And now we can also do something that happens if it doesn't rain. So we can use an else statement, and we can, for example, say if it doesn't rain, so else, if rains is not equal to true, we're going to console.log the sun is shining, for example. We're going to save this, and now we can run the file, and you will see right now is raining. So if we set rains to false, for example, so it's not raining, and we're going to run the same code again, we can see the sun is shining. So we are getting this else statement. Let's do another example. Let's say we have an age, for example, and let's say our age is 17, for example. Now, obviously, we maybe want to check if the age is above 18 already. So we can say if age is greater than 18, we're going to console.log you are 18 already. And let's use greater than to check equality as well. And we're going to save this. So if our age is greater or equal to 18, you're already 18. So let's say else our age is you are not 18 yet. And now once we're going to run the code, we will see that you're not 18 yet because we are 17. So if we are going to say that we are 18, we will see that we are 18 already. But let's imagine we also want to check whether our person is between 18 and 50. And we can do so by adding another else if statement. So if you want to check more conditions, you have the option to do so by using else if. And else if works pretty much the same as if. You're going to write else if, so this is the keyword. Now you have opening and closing brackets to add a condition. So first of all, let's check whether our person is less than 18. So he's not 18 yet. Then we can say you are not 18 yet. Now let's use the else if statement to check whether our age is greater or equal to 18. And we can also say, let's check whether our age is less or equal to 50. And now again, we're going to use opening and closing brackets. And inside of this code block, we can again say, what do we want to do if our person is greater or equal to 18 and our age is less or equal to 50. And then we can basically say we are going to console.log you are between 18 and 50. And else our person is obviously above 50. So we're going to say you are older than 50 years old. And now once we run the code with 17, for example, we get the first code block, you're not 18 yet. Now we're going to say we are 25, for example. We're going to run the code and we see you're between 18 and 50. And now if we say we are basically 51, for example, and we're going to run the code again, you're older than 50 years old. So now this is how you add an if statement, an else if statement, and the else statement. Let's understand comparison operators. And you basically use comparison operators to compare two things. So let's imagine we have a number 1, which is equal to 5, for example, and we have a number 2, or let's say num1, num2, and the second number is equal to 6, for example. And oftentimes you use comparison operators when working with if statements. So if you say, for example, if num1 is equal to num2, we are going to do something like this, for example. But let's just log the result of those operations in the console for now. So let's say we first want to check for equality. So we're going to say num1 equals num2. And now we're going to console.log this, and we see that we are getting false because num1 is 1 and num2 is 5, and num2 is 6. So they are not equal basically. So let's say we have 6 and 6. And now we're going to run the code again, and we're getting true because obviously 6 is equal to 6. Now we can also, instead of 2 equal signs, we can use 3 equal signs, and we're going to run the code and we will get true. So what is the difference between 2 and 3 equal signs? And it's pretty simple, to be honest. 3 equal signs basically means you are checking for strict equality, which includes the value and the data type. So right now those two are basically equal because they have the same data type and the same value because they're both 6 and both the numbers. So let's imagine we have a string here for num1 though, and the value of num1 is basically 6 as well, but the data type is obviously a string. So we're going to run the code, and right now we are seeing that we get false in the console, because obviously the value is the same, but the data type is not the same. So now if we just use two equal signs though, we would get true in the console, because it does not check for strict equality, it just checks whether the value is the same or not. If you want to check for inequality, you're going to use an exclamation mark before an equal sign, which basically means not equal. So it's num1 not equal to num2. And we're going to save this, run the code, and as you can see, this is false, because num1 is not equal to num2, if you want to say it. So it's not unequal. So once we basically say that this here is 4, for example, we will get true because those numbers are not the same anymore. Obviously, you can do the same with the double equal sign, for example. If you're, for example, going to say they are the same, but they have a different data type, again, this should be true. But if we remove the quotations and we're going to run the code, this is going to be false, because now they are equal. Obviously, there also exists a greater and less than sign, and a greater equals and a less equals sign, which most of you basically know from school. So let's assume we want to check whether num1 is greater than num2, then we can do so by doing so. We're going to run the code and we get false, because right now num1 is less than num2. We could obviously also do a less than sign, which is going to check whether num1 is less than num2, and this is obviously true. Now we can also use greater or equal to sign. We're going to run the code, and let's say they are equal, for example. Then we're going to run the code and we get true, because they are right now just equal. And we can also do less or equal than sign, and this is true again, because they are basically equal. And those are the most important comparison operators that you especially use when working with if statements, but basically for all types of things as well in JavaScript. Let's understand logical operators in JavaScript. First of all, let's imagine we have an age that is basically equal to 17, for example. And now you can use logical operators basically everywhere, but oftentimes you use them within an if statement, so we are going to do exactly that. So let's imagine we have an if statement and we want to check whether the age is greater than 18, for example. So we can say if age is greater than 18, but now let's also imagine we want to know whether our person is under the age of 25, for example. And now we can, for example, use an AND operator. So basically using two AND symbols, and this is a logical AND connection. So now we can also say if age is greater than 18 and if age is less or equal than 25, for example. And now we can console.log, whatever, for example, doesn't really matter, to be honest. And now once you run the code, and let's say our person is 19, for example, we're going to get whatever, because that's what we just logged inside of the console, if the user is between 18 and 25. And now you could obviously connect as many things as you want to. So you could obviously also say and name equals whatever, but obviously this doesn't make sense in our case. And if you work with logical operators, it's basically just like using normal language. You can just read it like normal language if you write your code in a good way. So if our age is greater than 18 and our age is less than 25 or less than equal than 25. And the same works basically with the OR operator. So instead of and, we can also say OR, for example. So if our age is greater than 18, or if our age is less than 3, for example, less or equal than 3. So now we can also say, okay, our person is 4, we will basically get nothing in the concept. So let's also say now he's 2, for example. Now we're going to run the code, and now we get whatever in the concept, because the person is not older than 18, but he's less or equal than 3. So if you use the AND operator, both of these statements have to be true, because you use AND. If you use the OR operator, just one of those statements has to be true. Now you can obviously also use the NOT operator. So let's imagine we are having a variable that is married, and that variable is true, for example. So if we want to, for example, check whether our person is married, so is married is equal to true, and instead of this syntax, you can also just say if is married. And this would be equal to saying is married is equal to true. So if our person is married, we are going to console.log whatever. And as you can see, we are console.logging whatever. But right now, let's say we want to console.log whatever if our person is not married. And you can do so by using the not operator. So this exclamation mark is the not operator and just reverses the value that is basically there. So obviously if we are checking for a person that is basically not married and we run the code, we're not getting whatever because our person is not married. But once we say our person is not married, so is married is false, and we're going to run the code, we are getting whatever in the console again. Now there are two more operators that are really important and often forgotten, and one of them is the nullish and one of them is the optional operator. So let's imagine we basically have a user. So we are going to create let username be equal to null, for example. And now we are going to console.log our username, and we're going to see what we see in the console. And as you can see, we are seeing null. And now you can use the nullish operator to give the fallback value for this username. So if the username is null, for example, let's say he is just called Sven, for example. And now we're going to log the username again, and now we see Sven on the console, because if the first value is null or undefined, let's take a look and show you that this works as well. So if the first value is null or undefined, we are basically using Sven as a fallback for the username. And this is especially useful if you work with databases later on and you, for example, have some values where the user does not have to enter a value. So maybe he doesn't have to enter his age. And now if you just have undefined for the age, it's probably not that good for your app. And you want to display an age or say, hey, you didn't enter an age, for example, whatever. Could be a case. And then you have a fallback text that could, for example, say you didn't enter an age, for example, like enter an age, like so. And now you could, for example, say let age be either equal to whatever you get from the database, could be something you enter here. And if it doesn't enter anything, you would obviously get undefined, and then you have this as a fallback text. So this would be a real case scenario. And now let's also say let's username just be equal to null. So we're getting this null value, and now we are going to console.log our username. So now let's say we want to log our username inside of the console. We're going to run the code and we're getting null inside of the console. So now let's say we want to log username.text inside of the console, and we're going to log this. And as you can see, we are getting an error because username does not exist. So obviously the property text does also not really exist because username is null and .text doesn't even exist. So now we can use the question mark to check only if the username really exists. We're going to look for the text property basically. So let's just run the code again. And as you can see, we're now just getting undefined because we don't have a text property and our username is null. And if you think about a database again, it makes sense if you get a lot of null values, for example, that you first check whether there even exists this property. And if it exists, you can obviously use the value. And if it doesn't exist, you're just going to interrupt the code and return undefined, which obviously makes your code a lot more error prone. Let's understand switch statements in JavaScript. So let's imagine we have this if statement where we basically compare aura to certain values. So if we have 0 aura, we are having 0 aura. Otherwise, we have little aura, small aura, some aura, big aura, or giant aura. Or wait, what? So basically, this is the switch statement. I didn't really get a better example, guys. So yeah, you have to take this one. So now we want to replace the same code with a switch statement. So sometimes if you want to compare values to one or another, it makes sense to replace an if statement with a switch statement because this is sometimes a little cleaner. So what we're going to do is we're again going to use switch. And right here, we are going to use opening and closing brackets. And we say what value we want to compare to. And in our case, we want to compare to aura. And now we're going to use opening and closing brackets as well. And right here, we can define a case. So let's say we want to use case 0. And if we have case 0, we want to console.log no aura, for example. And then after every statement, you basically want to break out of the loop because otherwise the code would just keep running and it would execute every single case. And in some cases you might want to do this, but most of the times after you did one of those cases, you want to break out of the loop and just return the value that you had defined inside of this case. So now we can just copy and paste our console.log right here. Let's say little aura, we're going to break out of the loop. And now we can just copy those cases right here couple of times, and now we have case 2, we have case 3, we have case 4, we also have case 5, and now when we have case 1, we're going to log little aura, we are going to log some aura, still some aura, big aura, huge aura. And now similar to an if statement where you can basically use an else block, you can also define a default value right here. And you can say, okay, console.log wait what, if none of those statements basically fit it. So let's take a look. Let's run our code. So the index.js, and right now we have huge aura. So let's say we have an aura of 3, for example. Now we still have some aura at least, let's say. And now if we're just going to enter some random values, we should basically just see wait what. So this is basically how an if statement, or how a switch statement works. And now also let me show you how it affects the code if we are going to remove the break statement. So let's say we are going to say we want to have 1 aura or 0 aura, for example. And as you can see, now we have no aura, little aura, some aura, and still some aura in the console, because we are just breaking out of the loop right here. And all of the statements before don't have a break statement, so we are going to console log no aura, and then we're just going to keep going, little aura, some aura, still some aura, and right here we are breaking out of the loop. So you really need this break statement to break out of the loop once you did whatever you wanted to do most of the times. Maybe in some cases this might be what you want, but most of the time I can tell you it's probably not what you want, so you should add a break statement right here. There's a way to write this entire if condition instead of one single line. So first of all, let's say we are going to check the condition by saying sunny. Then we are going to use a question mark, and this question mark essentially says, if this condition equals true, what should I do? And in our case, we want to console.log it is sunny, for example, if this condition equals true. So now we're going to use a colon right after this condition. And after this part, we are saying, what should we do if this condition is false? So if sunny is false. And if it's not sunny, obviously we want to console.log it is not sunny. And now let me run this code. So let me run this index.js. And as you can see, we're getting it is sunny 2 times because we're getting it from this if statement and also from this ternary operator. So a ternary operator, really simple. You have the condition right here. After the question mark, you just define what you want to do if this condition is equal to true. And after this colon, you define what you want to do if this condition is equal to false. So you could also just say 1 equals 1, for example, console.log. Maybe we want to log 1 if 1 is equal to 1, and maybe we want to log 2 if 1 is not equal to 1. So let's run the code, and as you can see, we're getting 1 because obviously 1 is equal to 1. Let me show you the difference between var and let and const in regards to scope. So let's imagine we have a function. That function has the name greet, for example, and we're just going to console.log greet user. And this variable, if we define a variable that has the name x, for example, and we're going to say x equals 10, and we're going to console.log x, and we're going to call this function, and now we're going to run the code. You can see that we have 10 inside of our console. So this works just as expected and would also work if we would use let or const. But now let's say that we are going to use an if statement right here, and we say if 5 is equal to 5, for example, which obviously is true, we are going to set var x equals 10. So now we are basically defining our variable inside of this block, inside of this if statement block. We're going to run the code, and as you can see, we are again getting 10, even though we are using our console.log outside of this block. So let's use let, for example, instead of var, and we're going to run the code, and as you can see, we're getting an error. So why is that? So var defines a variable inside of the function scope. So basically inside of the scope of the function where you define it. So even if you go down 10 blocks and define it within an if statement, so within the block of an if statement, you can use it wherever you want inside of the function. While let and const are basically scoped to the block where you defined it, so you can't do this. But if you would go ahead and use the console.log and log it within the block where you find x using let, you can use it, obviously. And like this it works. But if you get outside of the scope of the block where you find your variable using let or const, you get an error. If you use let or const, you can just use it within the block where you defined it. So within the scope of the block where you find it. And if you use var, you can use it wherever you want inside of the scope of the function. Let's understand objects in JavaScript. And this is, in my opinion, probably the most important concept that you'll get in JavaScript, because objects are basically able to represent everything you could represent in the real world. So let's imagine you have a car. Now we're going to define a variable, for example, that has the name car. And similar to a real car in the real world, we can define properties that define how our car behaves, for example. And we can say we are defining an object by using opening and closing brackets like this. Inside of these brackets, we can now define certain properties. So we could, for example, say our card has a certain speed. And now to define properties, we're going to use a name, a property name like speed, for example, and then a colon followed by the value. So our speed could, for example, be 254. Now we could also, for example, define a name for our car. So since I really don't know anything about cars, I'm just going to use whatever, for example. And now let's say this car also has a price. So this price is maybe $19.99. Really realistic, guys. But yeah, as you can see, you can basically say pretty much whatever. You can also say has owner. So does this car already have an owner? And this could, for example, be false. So now you have this car, which could basically represent a real car in the real world, for example. If you are, for example, imagining to code an online store where you sell cars, this could be an object that represents one of the cars you're selling, for example. Obviously, this could also be a t-shirt if you wanted to create a t-shirt right here, whatever. So this is how you create a car. So how can you access the properties of a car? So to do so, let's console.log some of the properties. And there are two main ways to access a property of a car, or to access the property of an object. And the first one is using the dot notation. So I can, for example, say car. So type in the name of the object, which is car in our case, followed by a dot. And now you already see Visual Studio Code gives you all of the properties you've defined. So now we can, for example, access our name. We're going to console.log the name in the constant. As you can see, we get the name of our car right here. So dot notation would be the first way. The second way would be bracket notation. And both of these ways work perfectly fine. So you can just choose whatever you want. So obviously we can use brackets, and then we can just use the property inside of quotes, basically. So we can say we want to access our price. We're going to run the code, and now we get the price inside of the console. So how can I update a certain property? And this works pretty much exactly the same. We can, for example, say car.price is now equal to 29.99. And now we're going to console or run the code once again, and we're going to see in the console we updated the property. And you can obviously also use the bracket notation. So let's say we want to update the price, and now we want to have $199.99. And as you can see, this works exactly the same. To add a new property, you can basically use the same kind of notation once again. So let's say now we want to have an owner name. So the car does not have an owner, but it has an owner name. Makes a lot of sense, but doesn't really matter in this case. Let's say the owner of this car is Jonas, for example. And now we're going to use our owner name, and we're going to console.log it. And now we see we have an owner name. And you can also do the same by using owner name, for example, by using this notation, or let's say owner names. And now we're having Jonas and Vinny, for example, and we're going to run the code, and we don't have an owner name, but we should have owner names. So we're running this, and now we have Jonas and Vinny. So as you can see, you can also add a property by using dot or the bracket notation. So dot and bracket notation works for pretty much everything. How can we delete a property? And in order to do so, you can just use the delete keyword. So you can say delete car.speed, for example. And now let's log speed inside of the console. And as you can see, we get undefined because we just deleted it. And obviously, you can also use the bracket notation if you want to. So this would just result in the same result. Now you can also check whether a property exists. So we could, for example, go ahead, say car.hasOwn property, and now we can name the property, which could be speed, for example. We're going to run the code, and now we see that this is true because we obviously have speed. If we say we want to check whether we have speed 1, we're going to get, whoops, I have to save the file. We're going to get false because we obviously don't have speed 1. So now instead of using hasOwn property, we can also use another syntax, which could be using quotes, using opening and closing quotes, stating the name of the property we are looking for. And now we're looking whether speed is in car. So whether the property speed is in our car object. We're going to save the code, and we're getting true. So obviously if we are looking for speed 1, for example, we're getting false because we don't have speed 1. So let's take a look at functions instead of objects. Let's imagine we have this object that is, for example, Jonas, which is just the human being. And this person obviously has, for example, an age of 27 and a name that could be Jonas. So let's say we also want to have a function for Jonas. So how can we create a function? Let's say the function's name is greet, and we can define a function by stating the property name once again, which is greet. So this is the function name. Now we're going to use the function keyword. We're going to define the function right here, and now we can console.log hey bro, for example. And by doing so, we now define the function. As you can see, it works pretty much the same as it works with pretty much every other property as well. So you can just use the property name and then you define the value, which is in our case a function. So now we can, for example, say jonas.greet. We're going to call the function by using those opening and closing brackets. And now we're going to run our file and we will see hey bro inside of the console. So this works, but there's also a shorter way to write the exact same. And now let's say wave, for example, is a function that we want to create. We can just go ahead and say wave. Now we can use opening and closing brackets, and then we can just use those brackets again. And then we can just use the method body right here. And inside of this method body, we can say console.log I am waving kid, for example. Now we are saving this, and now we have the exact same functionality without specifically defining a property name. Because right now, I mean, we define a property name, but we did it in another way. And this is the way we basically did it. So now we can also say jonas.wave, for example, call the method again by using opening and closing brackets. And now we can say run code. Hey bro, I'm waving kid. And now this is basically the result we are getting. Let's learn about classes in JavaScript. So we already discussed objects. So you can, for example, say you want to create a car, and that car has different properties, for example, like speed, a name, and so on. And maybe you want to have a second car, and that second car has obviously maybe some different properties. Maybe one has a speed of maybe 10 kilometers per hour, and the other one has probably a speed of 100 kilometers per hour. So obviously, if I wanted to create like 10 classes, I would have to write out everything over and over again. And this wouldn't be like really that great, to be honest. So there's an option to basically create a blueprint for an object. And that is a class. So a class basically defines the basic structure of an object. And the object is then the defined class, basically. So obviously, if you take a look at humans, every human or pretty much all humans are basically the same. Like all of the time they basically have a brain, they most of the time have a body, at least I hope so, and so on. So they have different properties that are common within every single human. But obviously, if you take human A, so for example, if you take Jenny and if you take Max, they probably have a different name, a different age, maybe a different gender, and so on. So they all have in common that they have a gender, that they have a name, and that they have an age. But the age might be different for all of them. So we can basically create the blueprint by using the class, and we can create a class by using the class keyword. And then, for example, we could say person. And you usually use a capital letter when creating a class for the first word. And for every other word, you also use a capital letter. So if I would have person hello, for example, whatever, this doesn't make sense. But yeah, if you would use or would write person hello, for example, then you would use a capital letter for the second word as well, since this is just a convention. So now let's create the blueprint for a person. And inside of this person, we can, for example, say that every single person can greet, for example. So we can create a greet function inside of this class, and we can say console.log hello guys. And now we can, for example, create different persons by saying person1 is equal to new person by writing so. And then we can say, whoops, obviously you need to write it like that. And then we have a person2, for example, that is also equal to new person, for example. And now we can save this and we can run our code, for example, and we have two persons, but nothing is happening. So now we can, for example, say person1 can greet and person2 can also greet. So now we can call this function for person1 and for person2. So the purpose of a class is to basically create a blueprint for objects. So again, let's create a class of type person, and let's say this person can, for example, greet, and if it person is going to greet, we are going to console.log greeting in a console. So now let's create two persons, for example, person 1 by using new person to create the person, and let person 2 be equal new person as well. So obviously we now have two persons, but those persons are literally completely pretty much the same. So what is the purpose of doing this? Obviously this doesn't make too much sense, but you can use a constructor within a class to create different types of persons if you want to say so. So let me show you. You can create a constructor inside of a class by using the constructor keyword, and inside of this constructor you can now define several properties that a person should basically have. So we could, for example, say he should have a first name, a last name, an age, maybe muscle mass, and some speed. And now we are going to use opening and closing brackets once again. And when using a constructor, you basically use this syntax. You use this, so this keyword, then the name of the property, first name is equal to first name. Now we are using this dot last name is equal to last name. And I'm going to explain what this means in a second. And this dot age is equal to obviously age. This dot muscle mass is equal to muscle mass, and this dot speed is equal to speed. So what does this mean now exactly? This always refers to the created object. So let me show you, or let me draw it for you. So let's imagine you create a person 1 and you create a person 2. So now you have this. It's the first person, maybe she's happy, and here you have the second person, and maybe he is not that happy. So now you create one person by using the new person constructor syntax basically, and you create this person. Let's say you create the happy person. So now this refers to this object. So basically refers to the object that you just created. Now you use this line, for example, and create a second person by using new person once again. And now for this object, this refers to this object. So basically to this object. So to the second person. So it's actually really simple. This always refers to this object that you just created. So now we can use those properties. Those constructor properties are basically properties that we can use right here, that we can fill in here. So let's say we have a first name of Jonas, second name of hey or bro. Now we have an age 24, muscle mass 0, and speed 0, for example. So now we have this first person. And now let's create a second person. He has maybe the same last name and has, maybe he's 100 years old, has a muscle mass of 200 kg and a speed of 400 kilometers per hour. Like legit person, but yeah, okay. So whatever. When you define basically your parameters inside of this constructor, those are the parameters that you define or that you use right here. So those are the arguments that you're basically feeding to those parameters. And now those parameters are basically what you have right here at the right. So by using a parameter, you say whatever this dot first name is going to be equal to the parameter that we just used right here. So basically this is the parameter that is here, and you could also have another name. You could, for example, also say this dot name is equal to first name, but by convention you just use the same names. And now if you would create this dot name right here, which is equal to first name, you could also say console.log person1 dot name, for example, and now you can log it in a console and you would have Jonas. So basically those are the properties that you assign to the object, and usually you just use these parameters to give a value to these properties. So I hope this makes sense. Every object has a property and you can use parameters to define specific values for those properties. And now this dot first name basically refers, once you create this first person, this refers to this person. And once you create the second person, there exists basically one this for person 1 and one this for person 2. And this always refers to the object that just has been created using the constructor. So what is the purpose of this? Now you can basically use this inside of the function, for example. So now you could, for example, say console.log this dot first name. And now this for the first person refers to the person 1. So basically to this person, and this for the second person refers obviously to person 2. So now when we go and we are going to use person1 dot greet, for example, we are using the greet function for person 1. This refers to the object that has been created for person 1. So this refers to this object. This object has a name of Jonas, or first name of Jonas, last name of bro, age 24, muscle mass 0, speed 0. So this refers to this object. And now we're going to call for this object, the greet function. And once we go run code, I'm going to save the object, I'm going to run the code, and as you can see, we get Jonas inside of the console. Now, obviously, we can do person2.greet as well. And now for person2, this obviously refers to the object that has been created by using the new person constructor basically for person2 with the values of Pascal, bro, and so on. So we're going to run the code, and now we get Jonas for person1 and Pascal for person2. So as you can see, by using this, you can really do a lot of stuff, and it is pretty nice that this always references the object that has just been created using the constructor for exactly this object, basically. And I know it might be a little bit confusing for a lot of you, that's why I really tried to explain it as detailed as possible, but just try it out a little bit and you definitely get an idea what this basically makes. Let's understand getters and setters in JavaScript. So first, let's create a class that is the class person, and this class will have a constructor, and let's say our person has a first name and an age, for example. And now right here we can, for example, say this dot underline first name is equal to first name, and this dot underline age is equal to age. And you're basically always using this underline symbol when you're trying to encapsulate a property, basically. So when you only want to give the possibility to access this property by using a getter and a setter. To some people, getters and setters might seem useless at first, but I'm going to show you the power of them. So if you wanted to create an object, let's say person1, for example, and we're going to create a new person object by saying first name is Jonas and age is maybe 24, we can now say person1 dot first name or dot age is equal to 25. And obviously you could run the code, and now you could also console.log person dot underline age, and if we run the code now, we get 25, even though we set 24 for the age when using the constructor. And now we could also say, okay, our age should probably be -3, and this would be perfectly fine. So now let's use a getter and a setter to basically get and set the property. So a getter, as the name implies, allows you to get the property. So we can use get age, for example. And by doing so, we define a getter for getting the age. Instead of here, we are going to use those brackets, and we are going to use a pair of brackets once again right here. And now we can say that we just want to return this dot underline age, for example. So what this method basically, or this getter basically does, is it allows you to get the age by using the age property from now on. So we can, for example, say console.log person1.age, for example. So as you can see, we are using this property right now instead of underline age. And now if we are logging this in the console, we can see we are now getting the age of -3. So as you can see, this is basically the syntax you use for a getter. You use the keyword get, then you use a name, and this can be any name. You could also say whatever you wanted to. So this would work as well. So this is then the name of the getter. And right here, you basically say you want to return the age of this specific object. So in our case, of this object right here. So now let's also define a setter. And a setter allows you to set the value basically. So let's say we are going to create set, and we're going to say age. And we also want to set the age. But now if we want to set the age, we also need a value to set an age basically. So we're going to accept a value that the user can enter. And right here, we are going to say this dot underline age. So the age of this person basically that we just created using the new person constructor is equal to our value that we just entered here as a parameter. So now we can do so. And now we can, for example, say we want to use person1 dot age, and as you can see, this here is a setter now. So we could obviously use this here as well, but this wouldn't be a good this wouldn't be a good way to do this. So instead of using the property right here, and this underline basically means do not access this property without using a getter or a setter. So basically this is just a convention that tells other developers, please do not touch this property directly, but use getters or setters instead. And in this case, we're going to use obviously the setter to set our age. to -3. And if you run the code right now, you see the same result. So it doesn't really change too much, right? And I know at first it might seem pretty useless to a lot of you, but what you can do inside of a setter, for example, is you can do some logic or implement some logic that allows you to validate those values. So we could, for example, say if value is greater or equal to 0, then we can set this.h equal to value, and else we could, for example, console.log not valid, for example. And now if we are just going to run the exact same code, we will get not valid because we basically have an error and our value will still be 24. So a setter and a getter is definitely something that you should implement in your code to basically validate logic and just reduce the risk when writing an application, for example.
Imagine you would want to access the keys, the values, or the keys and the values inside of an object. And in JavaScript, there exist methods to do that. So let's take a look at them by console.logging the results of those methods. So let's imagine we just want to get the keys for this entire object. So for this me object that includes the properties name, age, biceps, and IQ. So essentially the keys name, age, biceps, and IQ. We can do so by using object.keys, as the name implies. And then we have to pass the object inside of those brackets. So in our case, it's me. We are going to save this and now we're going to run the code. And as you can see, we get the keys. So name, age, biceps, and IQ. We can also say that we only want to get the values of this object by using object.values. So we're going to save this, run the code again. And now we only get the values inside of this array. If in case you wanted to get the keys and the values, you can just say that you want to get object.entries. Now we're going to run the code, and as you can see right here, we get nested arrays. So we get an array of arrays, and every nested array contains essentially the key and the value. Let's take a look at the mutability of objects and arrays. So for example, if I wanted to add a property to this user's object, I could just say user.speed, for example, is equal to 100. Now let's console.log our user. And let's run our index.js file. And as you can see, we're getting our new object with a name, an age, and a speed. And the same obviously also goes for fruits. So if I want to say fruits.push, and I'm going to push maybe a monkey to the end of my fruits array, and I'm also going to console.log my fruits, you can see that we are now having a monkey at the end of our array. Even though we used cons for fruits and cons for users, that does not mean that we cannot change the content of those elements by using, for example, the push method or user.speed or user.property name. So all this really means is that we can now, for example, if we wanted to say fruits is equal to another object or to maybe another array, this here should actually not work. So if I run the code, we're getting an error because I tried to reassign a constant variable, which is not possible in JavaScript. So I cannot reassign the variable, but I can change the content inside of the variable right here. So what if I wanted to prevent the user or myself or other developers from changing the content of an object or of an array? Then I can just go ahead and say object.freeze, for example. And now let's, for example, freeze our fruits. I'm going to save this. And again, I'm going to put this right here. I'm going to clear the console so we can see what's going on. We're going to run the code. And as you can see, we're again getting an error, because we are trying to do fruits.push. Since we used object.freeze for our fruits array, it is not possible to mutate this fruits array in any way. So you cannot add content, you cannot reassign the variable, you can't do anything with it besides reading it. So just remember, if you want to make an object or an array immutable, feel free to just use object.freeze. Let me introduce you to the different ways objects and primitive types store data. So let's imagine we have a variable which is a number that is equal to 10. And now we're going to console.log this number 10. And as you can see, we now have 10 inside of the console. Let's create a second variable with the name of y that is equal to x. And now we're going to use y plus equal 10. And now we're going to console.log x, and we have 10 for x. And now we are also going to console.log y, and we will have 20 for y. So x is 10, y is 20. So this would be the normal behavior that you would imagine, right? So how are objects and arrays different? So let's imagine we have an array. Our array is, for example, numbers, and we are just storing some numbers, 1, 2, 3, 4,
inside of this array. Now we have numbers1, for example, and we are just going to set this equal to numbers, for example, and now we are going to console.log numbers, and we're going to console.log numbers, numbers1, like so. We're going to run it in the console, and now we have the exact same arrays. But now let's just go ahead and say numbers.push, and we're going to push a monkey to the end of our array. We're going to save this, and we're going to run the code, and as you can see, now both of our arrays have monkey at the end, even though we just added the monkey to numbers and we didn't add it to numbers1. It would look the exact same if we would use an object, I can tell you that. So how do those different types basically work? Let me show you. So if you have a variable, let's say you have the variable x, and this is basically, imagine it as a package basically. So you take the variable x and put it inside of a package. So now you have a variable y, for example, that you're creating, which is equal to the variable x. So you basically imagine it like that. You take the x, take the value, and put it inside of the variable y, so basically inside of the package y. So you take the value, put it out, put it in there, and now you have the value one time inside of package x and one time inside of package y. So this is how this works. So now you basically have two packages, if you want to think about it like that. But objects and arrays work a little bit different. Let's imagine you have an array, and say this is a package as well. So you have this array, and this array is equal to maybe 1, 2, 3, and 4. And now you just want to duplicate this array. So you have this numbers, you have this numbers variable, and this numbers variable is going to point to the place where you stored those numbers. So basically to an address, if you might think about it like that. And now you want to duplicate the numbers array and create a second numbers array, which is numbers1. And now instead of copying every single number to a second package, if you want to think about it like that, you're going to take the pointer, and now the second variable is going to point to the exact same address. So you're just pointing to an address, and obviously if you change something inside of this one package, you will change it for every single thing. So let's say we add 5 here. Now you will add the 5 to every single thing that points to the address, because you obviously just have one package and every variable just points to the package. So obviously if you change something inside of the package, every pointer to the package will obviously have the same value now, because it's just pointing to the package, reading the value, and getting this value back to the user. On the other hand, if you have normal primitive types, so strings, numbers, booleans, and so on, you basically duplicate the complete package with the value inside basically. So now you have basically one package that has the variable x and another package that has the exact same value that has the number y. So if you add 5 to package 1 and 10 to package 2, obviously you have two different values now inside of those packages. So this is how complex and primitive types work in JavaScript. Let's understand this bind, call, and apply. Let's imagine we are having a user object, and inside of this user object we're going to greet the user, or creating this function. Inside of this greet function we are going to console.log this, for example. Now right below, let's say we want to call user.greet and we want to execute the function. We're going to run the code, and inside of the terminal we see that we're getting back this line of code. So what is really happening right here is that this, in this case, points to the object that has called this function. So this points to this user. What would happen if we would go ahead and copy this function to another variable though? So let's say our copy is going to be equal to user.greet, and now we are going to call our copy as a function. And now if we execute that code, I really recommend you to take a look at this inside of the browser. So if we open our console right here, you can see that we're getting undefined. In contrast, let's call user.greet right here. So we see everything side by side. So one time we get the pointer to our object, and the other time we get undefined. So why do we get undefined right here? By saying that copy is equal to user.greet, we are just saying that our copy is equal to this function. So this will call this function. But at this point, the reference to the user will be lost. So it will not copy the reference to the user. It will just copy the function call. So this would be pretty much similar to creating a function that has the name greet, and then you essentially say that copy is equal to this function. The context in which this function exists in the context of the user gets lost. Now if I wanted to say that this copy should also reference the user or consider the user, So if I wanted to bind this essentially, I can, for example, say after user.greet that I want to bind this to the user. So I want to bind this copy to the user. I'm going to call copy right here. So let's just execute the code. Let's reload the page. And as you can see, we are getting greet and greet. So for both of those executes, we get the pointer to our object. So now let's get rid of that line right here. And let's also get rid of that line right here. So again, we're just saying instead of our copy, we will copy the user.greet function. So right now we are getting undefined again. So now let's imagine this function right here would have an argument of name, for example. And let's say we're just going to console.log this, and we're also going to console.log our name. So now we need to use a name right here, for example. And now if we're going to log that one, you can see that we're still getting undefined and we're getting the name Pascal. So isn't there a way to immediately just call the copy once, bind whatever object we want to use to this, and then immediately execute that? And there is something like that. So you can say copy.call, for example. So you can use the call function. Right here, you have to define what do you want to bind this to. And in our case, let's say we want to bind to our user. So now we are binding this to the user. We can execute that one. And as you can see, we're getting, again, the pointer to our user for this. And we're getting the name right here. There's also another method to do the exact same thing. And that is copy.apply. Again, what do we want to bind this to? In our case, we want to bind this to our user. And right here, the difference is that you have to apply the arguments by using an array. So we can say Jonas, for example. Going to save that one, going to refresh our index file. And now we have Pascal and Jonas. And again, this is bound to our user object. So if you want to bind something permanently, you can also do it like this by saying .bind user. So now this copy will always be bound to this object right here. If you only want to bind the user one single time when calling the function, you could just use call or apply. So let me show the difference. Let's remove that one again. And if I'm going to call copy afterwards, so after the call and the apply method right here, we will get undefined in the console. Let me refresh. Oops, and we need to remove that. So now let me refresh. And as you can see, we're getting the pointer to our object for those two calls right here. And even if I'm going to say this one has a name, for example, let me refresh, we are still getting undefined and the name. So this here does not seem to point to our object anymore. So bind will always bind, call and apply will only bind for one single call.
The while loop and the do while loop are both loops to repeat a certain task a certain amount of times. So imagine you want to do something 10 times, for example. Then you can define a variable, for example, let I be equal to 0. Now we can create a loop by using the while keyword. And inside of this loop, we can, for example, say while I is less than 10. We want to console.log I, for example. And if I would just start this loop would basically run forever because I will never be incremented. This means I will always be 0 and this loop will always keep going and going and going. And this would be an infinite loop. So to break out of this loop at a certain time, we need to increment I every time we run our loop. So I'm going to say right here, we will do I++ to increment I by 1 every time we run this loop. And you really have to think about this loop in the following way. We basically run this loop for the first time. I is equal to 0. We are going to console.log I, and then we will increment I. So in the next iteration, we will check this condition. I is 1, I is still less than 10, so we are going to console.log I, and we will increment I by 1. In the next iteration, I is equal to 2, which is still less than 10. We are going to console.log I, and we will increment I by 1. So we are going to repeat this until I essentially reaches 9. We are going to run this loop again. We will increment I. And for the next iteration, we will check, okay, is 10 less than 10? 10 is not less than 10 because 10 is equal to 10. So at this point, we are breaking out of this loop. And now I'm going to show you how this works. And I'm just going to run the code. And as you can see in the terminal right below, we will now have the numbers from 0 to 9. So essentially all of the numbers that are less than 10. Now there also exists a slight variation. So imagine we're going to put 10 in here. And now we're just going, I'm going to clear the console so we can see the difference. And now I'm going to run the code. And as you can see, we don't have any output. And the reason for this is in the first iteration already, 10 is not less than 10. So this loop will never run. But there's also an alternative, and that is the do while loop. So let's say we're going to have do right here. Now we'll have the body, and inside of this body we are going to console.log I, and we will also increment I by 1 inside of this loop. So we have the exact same loop. The only difference is that we are starting with the do. And right here we have the condition after our brackets. And for this condition, let's also say while I is less than 10. So since we have the exact same loop, this loop shouldn't run as well, right? Because I is never less than 10. So let's try this out. And let's also run the code. And as you can see, we get the output of 10. And the reason for this is this loop always starts with the do block. So we are going to execute this block no matter the condition, because essentially this one here comes first. And after we've executed the call block, we are going to check the condition, which is not true in this case. So at this point, we will stop the loop. So the difference between while and a do while loop is that the do while loop will run at least once, while the while loop does not have to run once if the condition never equals true. Another way to repeat a certain task a certain amount of times is a for loop. And a for loop is somehow similar to a while loop, but the syntax is a little bit different. So let's create one. So let's say for, then we need opening and closing brackets, and we create a body similar to the function. Right in here, we need three things. The first one is the initial value. Then we need a condition, and then we need to increment our initial value. So let's say our initial value is basically I is equal to 0. Then we need to separate our initial value from the condition by using a semicolon. For the condition, we can say, let's run this loop as long as I is less than 5, for example. So we will run it 5 times, 0, 1, 2, 3, and 4. Again, we have to separate condition from increment by using a semicolon. And for the last one, we say I++. But you can obviously do anything you wanted to do here. So you could also say I plus 2, for example. But in our case, let's increment it by 1 every iteration. And inside of this for loop, we can, for example, say console.log, and we are going to console.log our variable I. Now let's run this file. And as you can see, we repeat this 5 times, 0, 1, 2, 3, and 4. And then we break out of this loop. So a for loop is really, really easy. You just use it to do something a certain amount of times. You define a start value, you define a condition, and you define an increment. Let's imagine we want to output all of the keys of this object, for example. This is really simple by using a for in loop in JavaScript. So we're going to use the for keyword. Now we will define the name that we're going to use for the key. So we can, for example, say let key, but you could also say this can be pretty much anything. But in our case, it makes sense to say that this is the key because it is the key of the object. So let key in user. So for every iteration, this key holds one of the keys of this object. So let's also create the body. And for every iteration, this for loop now says, iteration 1, this key is equal to this name key for this object. In the second iteration, we take this H key, and in the third iteration, we take the city key. So now let's just console.log our key to show you that this really works. I'm going to run the code again, and right now you can see we get an output of name, age, and city. So to summarize, this iteration loops over an object, for example, and holds one of the keys for every single iteration. So you can essentially use a for in loop to loop over an object, for example. But there's also the for of loop that allows you to conveniently loop over arrays, for example. So let's say we have a const fruits array that is equal to maybe a banana, an apple, and let's say a melon, for example. And now let's use a for of loop to loop over those fruits. So we can say let fruit of fruits. And now let's console.log our fruit, because I think this is the easiest way to really understand it. We're just going to run the code. And as you can see, now for our for in loop, we get the keys of this user object. And by using the for of loop, we get the values or get an output of the values for those fruits. So essentially the for of loop holds the value of one of the items from an array, for example, for every single iteration. So for iteration 1, for example, it goes over this array, takes the first item, so our banana, console.logs our banana, and goes on to iteration 2 since we have a second item. For iteration 2, fruit is equal to apple, it console.logs apple and goes on to the third iteration. And since we only have 3 items, after 3 items, it's going to break out of the loop. And the difference between those two things is essentially that right here, you can, for example, say if you have an object that you want to say, you want to get user of key, for example, and by doing so, you can, for example, also get the value of an object. So let's run this code after I cleared the console.
And as you can see, now, for example, we are able to get the value of an object as well. So a for in loop is really good if you want to loop over objects and get key or value of the object, while a for of loop is really good if you just work with an array, for example, and just want to get the value or the individual values of this array, for example. Let's take a look at nested loops. And nested loops are a lot easier than a lot of people think. Let's imagine we have an array, for example, that includes mixed data, for example. It doesn't really matter too much. You can give this whatever name you want. And let's say we have an array, and inside of this array, we have a couple more arrays. So essentially nested arrays. And our first array, for example, includes a couple of numbers. Our second array could include a couple of animals, for example, so a monkey or a zebra. And our third array could include true or false values, for example. So let's say true and false. And now let's say we want to loop over this array. So there are a lot of ways to do it, but let's in our case say we want to use a for of loop, because that would be the way to work with an array. So we're going to say for let array be of mixed data. And now let's just console.log out our array. So we're going to run this code. And now you can see we're getting 1, 2, 3, monkey, zebra, true and false as separate arrays, as you can see right here. Since we have a nested array, we will also need to use a nested for loop, because in our first iteration, we are looping over this array. So in iteration 1, we get this item right here. In iteration 2, we get this item right here. And in the third iteration, we get this item right here. But if we want to access the items inside of the nested array, so essentially the individual items right here, we obviously have to use another for of loop to get or to loop over the individual items. So inside of our first iteration, for example, we are getting this item right here. So let's create inside of this first iteration another for let value of array. And now we're going to console.log this value. So let me explain this to you again. And I obviously need to use those brackets right here. So this was my bad. So in the first iteration of mixed data, we are getting this array right here. This array contains this array right here. So this array variable contains this array right here in the first iteration. Now, inside of this first iteration, we are again calling a for of loop. And now we are looping over this element right here, because this is the element that we are holding inside of our array variable. So now we say, for every single iteration, one of those values will be equal to this value, or will be stored inside of this value variable. So again, we are in the first iteration for this outer loop, and now for the first iteration of this inner loop, we will store the value 1. So we're going to console.log the value 1. Now we're going to the second iteration, so once we reach the end of this for loop, we're going back to the start of this for loop. So now we have the value 2 for this for loop, and we will print out this value right here. Now we go again to the third value, we take the third value, print it out, we are going back, and now we see, okay, this array is pretty much done, so we are going to finish this for loop. So we are going to go to the next line. We reach the end of this for loop now, so we are going back to the start of this for loop. Now again, let array of mixed data, we're going to get the second array of our mixed data array. We take this array, we go to the next line, we reach this for loop. Again, we start the value of monkey inside of this value, print it, go back to the for loop. We see zebra as the second item, print our zebra, go back, we see, okay, there's no more item inside of this array, so let's keep going. We are going to the end. We see, okay, for loop is over, we are jumping to the beginning again. And this is really how this executes. And I really wanted to explain this properly. I really hope you understood this. I know this can be maybe a little bit confusing for a lot of beginners, but you will definitely get this pretty fast once you're trying to and once you're working with it. Let's imagine you accept the user input and the user inputs this number. So you get this number as a string, but maybe you want to use this number like a real number. But obviously if I would go ahead and, for example, now console.log this number and add hello to this number, for example, and I'm going to run this file, you can see that we are just adding a string to another string. So this is not really how it works. And if I would go ahead and add, for example, a 3 to this number, as you can see, it's like not working at all. So how can I change that? There are two ways to convert this string to a number. The first one would be parse int, for example, and you insert the number inside of these brackets, and now you can run the code, for example, and as you can see, we're getting 6. So parse int turns this string into an integer. So basically a whole number. So 1, 2, 3, 4, whatsoever. But since you can see that this is a float, it might make more sense to turn this one into float. And there also exists a way to do that, and we can just use parse float. Now we're going to run the code again, and as you can see, we now get 6.1423 whatever, because that is essentially the number that this has been converted to. So a floating point number. Imagine we are having an array of numbers from maybe 1, 2, 3, 4, 5 to 6. And now we want to go over this array and do something to every single element, for example. And this is something you can do with the map method, for example. So let's say we're going to create let numbers2 be equal to numbers.map. And this works a little bit like a loop. And right here we are going to use a callback function. So essentially you use an arrow function for that one. So right here, we are going to get a value, and this value in our case is a number. And I'm just going to type this out and explain it in a second. And right here, we are essentially using an arrow function. Our parameter is our number, so we can also write it like this, for example. And now we are just going to return the number, but we're going to double the number. So we're saying number times 2, and obviously this one needs to be numbers1, for example. Or just changed numbers. So it is a little bit more descriptive. So what is a map method essentially doing? So essentially the map method iterates over an array. In our case, over the numbers array. It works a little bit like a loop. It takes the first item of our numbers array, puts this number in here. So inside of this placeholder that we've defined here as a parameter, so inside of this number variable, takes this variable, executes this block of code right here, so number times 2, and returns, in our case, the number. Then, again, since this line is executed, it goes to the beginning again, takes a look, what is the second number inside of this array? The second number inside of our array is the 2, so now number is 2. We're going to run this block of code again. We are going to return number times 2, so 2 times 2 equals 4. We are going to return this and go to the next iteration. So this here is always the parameter that holds the value for one iteration and changes during every single iteration. And the nice thing about this map method is that it also returns an array. So if you want to store the values, you can just define another variable to store the array that this numbers.map method, or the map method in general, returns. So what this map method basically returns is an array that looks like this, for example, 6, 8, 10, and 12. So this is basically what this map method in our case will return. And now we can obviously use this changed numbers array again and say we want to console log it, for example. So we can say console log change numbers. We're going to run our code and we're getting this output, so the exact same output that I've shown to you. And obviously you're not limited to saying numbers times 2, for example. You can also say you want to do any calculation, for example, or you can actually do whatever you have in mind. So the map method is really, really useful. And especially if you get to React later on, for example, this can be something that you definitely need to know. So I know a lot of beginners underestimate this, but this is, in my opinion, probably the most important method that you really need to learn in JavaScript. In some cases, you might want to filter out some elements of an array. So imagine we have this array and we want to filter, for example, every even number. So we can just go ahead and create another variable and say that one is the filtered numbers variable. And in our case, we are going to say numbers.filter. So the filter method is somewhat like the map method, but it also slightly differs. So what we can do is we can again say we're getting one single number for every iteration. We can again use an arrow function right here, and we can say we want to return the number if the number divided by 2 has a rest of 0. So let's console.log our filtered numbers before I'm really going to explain what is going on there. So let's run this, and as you can see, we're now getting a new array that is equal to 2, 4, and 6. So we're only getting the even numbers. So again, similar to the map method, we have an iteration. During every single iteration, this number holds one of those numbers inside of our original array. So inside of our numbers array, since we are using the filter method on our numbers array. Again, the filter method is a method that you use on an array. So in the first iteration, number is equal to 1. And now we are going to execute this code of block. And we will return our number if our number divided by 2 has a rest of 0. So if number divided by 2 works. For example, 3 divided by 2 is 1 rest 1. If we divide 4 by 2, for example, we get 2 with a rest of 0. So in this case, it works. So every time this statement equals true, we are going to return the number as it is. And if this statement does not equal to true, then we're not going to return the number. So essentially, we are filtering the numbers. So we're taking number 1, putting it in there, executing this line of code. This line of code is false. We're not returning 1. 2, this line is equal to true. We are returning number 2. For 3, this here is false, not returning number 3. 4, this here is true, returning number 4. And this is how it works. So in the end, we are getting the numbers 2, 4, and 6. And obviously, you could put in any logic you wanted to instead of this filter method. So you can define the logic and filter whatever you wanted to. You could also filter an array of strings or an array of objects if you wanted to. So you can define pretty complex logic right here. And this, again, really important if you want to work with React, for example. Imagine we wanted to reduce all of those values to a single value. And in those scenarios, you can use a reduce method for arrays. So let's say const sum, for example, is equal to numbers dot reduce. So we are going to call the reduce method. And this one works a little bit different from the filter and the map method. Again, we need a callback function. So we need to define a function that we're going to execute for every single iteration of this reduce method. So let's say we're going to get an accumulator. So this one essentially always stores the accumulator result, so the intermediate result. Now we will also have a current value, and this current value will essentially change for every single iteration. Obviously the accumulated value will also change for every single iteration, but the current value will always hold one of those values during every single iteration. So iteration 1, it will be 1, iteration 2, it will be 2, iteration 3, it will be 3, and so on. And then we are going to define our callback function. And after this function, so after our method body, we can define an initial value. And in our case, we want to use an initial value of 0. But let's say maybe we want to use 100 as the initial value, so really see what the point of this initial value is. So this is essentially the start value. If we would start from 0 and we would now use or create a sum for all of those values, we would say 0 plus 1 plus 2, so 3, 6, and so on. But since we're going to start at 100, we will say 100 plus 1 plus 2 plus 3 and so on. And obviously you don't have to create a sum, but in our case we're going to create a sum. So we are just going to say that we want to return for every iteration the accumulator plus the current value. So how does this work? First of all, let me console.log the value so we see that this really works. So we are going to run the code, and as you can see we get 121. So how does this work? The accumulator always has the current value. Since we are starting with 100 for the first iteration, our accumulator holds the value 100 since this is the start value. Now the current value for our first iteration is 1. So this current value holds 1, and now we have 100 plus 1. Since 100 is the starting value, so the accumulator value, and our current value is 1. So we are getting 101, ending the first iteration and going on to the second iteration. Second iteration, accumulator is 101, and our current value is 2. So again, we're going to say 101 plus 2 is equal to 103. We're going to store 103 inside of our accumulator and going on to the next iteration where we say, okay, current value is 3 right now. So we're doing, again, the exact same logic for every single one of those elements. So 3, 4, 5, 6. And then we're ending up with that sum. So we can also obviously say for the starting value, and that's probably the common way, that we're just going to use 0. And now we can console.log this again, and we're just getting 21. So yeah, makes sense, I would say. So imagine you also want to add a couple of parameters in the end, but you don't really know how many parameters you want to add, or it's up to the user how many parameters he wants to add. So in that case, we can, for example, say that we're going to use the rest operator. So for example, we can just use a comma followed by dot, dot, dot. And let's, for example, say right here, the user is able to enter some numbers, for example. And let's say we're just going to say console.log, and we will just log our numbers. And right here, after Ali, for example, we can now say 1, 2, 3, 4, or 100, for example. And now we're going to run this code. And as you can see, we are now getting hello Ali, and we're also logging those numbers in the console. So obviously you are not limited to logging the numbers. You could also use a reduce method on those numbers. So you could, for example, say numbers.reduce, for example. And in our case, we are having an accumulator we're having a current value, and we are going to say we will just return accumulator plus current value, and we're going to start with the value of 0. And let's just say we're just going to console.log this one here. We're going to save this, and now we're going to run the code again. And as you can see, we are now getting 110, since obviously 100 plus 4 plus 3 plus 2 plus 1 is 110. So as you can see, you can also do pretty complex logic if you wanted to with these rest parameters, and this is obviously up to you. In some cases, you might want to spread the properties from one element to another. So let's imagine we, for example, want to create a new user. So we can, for example, say const new user is equal. We are again going to create an object, and right here we are saying dot dot dot. So this is the spread operator syntax, and now we're going to say dot 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 followed by user, because we want to spread all of the properties of our user into our new user. And now we also want to add an age, for example, of let's say 25. We're going to save this, and we're going to console.log our new user, so you really see what's going on right here. I clear the console, and let's run this file. And as you can see, now we have a new user with the name of Ali and an age of 25. So what is exactly going on? This spread operator basically just says, take whatever you have right here, spread it right here, so take all of the properties out and put it in here, and that's essentially it. And you can also use the spread operator for arrays, for example. So we can say const new numbers is equal to another array, and now we again want to have or extract all of the values, so spread all of the values of this array inside of our new arrays. So we can, for example, just say dot 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 numbers, for example, and now let's also add 4 and 5 and 6 instead of this array, and now we're going to log console.log new numbers. We're going to save this and run the code. And as you can see, now we're getting this new array that includes all of the numbers of this other array, so of our numbers array, and the new numbers that we've added. So you can also use the spread operator to clone something. Now we're essentially saying we have this array, take the values of this array, and spread those values into this new numbers array. So we're going to run the code. And as you can see, now we're just getting 1, 2, 3. And this is a really good way to copy the values of one array or one object to another object or array. Oftentimes, when you work with a database, you get values like those ones, for example. So you get an object that has, for example, a name, an age, an email, username, password, whatsoever. So imagine this is an object that we're getting from the database. But now maybe we don't want to work with the entire array all of the time. Maybe we want to extract the username, we want to use the email, and so on. And there is a way to destructure the properties from this object. And it is really, really simple. You're just going to say const or let whatever you want. And then you're going to use those brackets if you want to destructure an object. And right here, you just have to define the names of the object that you want to destructure. So let's say I want to get the name. Then the key of our name property is obviously name. So I can say I want to get the name. Then I also want to get the age, for example. And maybe I also want to get the email. And now I destructured the properties of this object by saying equals user. So now I'm saying essentially get me the property name, age, and email as a variable from the object user. So now let me show you that this really works. So now we can console.log our name, for example, or let's say name, since this is a predefined name inside of JavaScript, we cannot use name like that. So we can, for example, say name, colon, first name. So we are renaming our name to first name. So we're going to say console.log first name. We're going to run this file. And now we're getting Ali inside of the console. Now you can also say console.log age. And now we should log our first name and our age. And as you can see, we're logging name and age. So essentially, by using this syntax, you are extracting the properties, and by using a colon followed by another name, you can rename the property if you wanted to. But you can also destructure arrays, for example. So you could, for example, say const num1, num2, num3 is equal to numbers. So this syntax essentially says, take the first value and save it to a variable with the name num1, take the second variable, put it into num2, and the third variable and put it into num3. And to show you that this also works, let me console.log num1 and num2. We're going to run the code, and as you can see, we get 1 and we get 2. In JavaScript, you oftentimes have code that could throw an error. If you think about fetching data, for example, and you're talking to an API, you're getting some data right here by using the fetch request, it is likely that this fetch request will reply with some data, for example. But it's also possible that the server is down, for example, or the user does not have internet or anything else. And then you will have a problem. And if you don't use a try-catch block for that one, your program will terminate if this one throws an error. So you have to put this one into a try-catch block so that your program does not terminate, but instead does proper error handling. So let me show you how this works. So let's say we are having a try right here. So whatever is in this block will be tried. So this could be a fetch request, for example, and oftentimes this is something like this. But in our case, let's just say we're having a variable that is equal to x, and we're going to say that one is equal to 5. And now we'll also have a catch block. If we get an error, we are having an error argument right here. And then we can, for example, say that we just want to console.log our error. So let's also go ahead and say console.log, and we're going to console.log x. But let's say this one here is x being equal to 5, and this will not throw an error. So we will see 5 in the console. But now let's, for example, say that we're going to use strict. And by using strict, this would throw an error. So we're going to run the code. And as you can see, we're now getting an error. But this time, this error message is not the one that we are getting previously, but it's the one that we're logging right here in the console. And you will see that this is true if I'm just going to say an error occurred, for example. So we're just going to log this in the console. We're going to run the code again. And as you can see, now we only get the message, an error occurred. So we caught this error right here and had a console.log statement. And now you could also have a finally block after your try-catch block if you wanted to. So you can say finally, for example. And this block will always be executed, no matter whether this is a success or an error. So we can say console.log I will always be called. We're going to save that one. We're going to run the code. And now we get an error occurred, I will always be called. Also, if this here is let x being equal to 5, and I'm going to run the code, you will get 5, and I will always be caught. So whatever you want to try comes into the try block. If you get an error, you're going to catch that one here. And if you want to do something, no matter success or an error, you're going to use the finally block. Let's understand JSON, so JavaScript object notation. If you have this user, for example, and you're having a database, so you have your website right here, and you have a database, for example, right here. If your website talks to a database, there also needs to be a language for talking to the database, because the database does not understand this plain object. And the language that your website and the server use to talk to each other is going to be JSON, so JavaScript object notation. So let me show you how this user looks inside of JSON. To create a JSON file, you're going to say index.json, for example. So you have the .json ending, and inside of JSON, you will have opening and closing brackets. Now you will have a username, but you have to have the key inside of quotation marks, like this. Now again, you have a colon, and right after you have the value, which can be Goku, for example. For our next key, we would have our age, for example. So we can again say age. Age is equal to 24. Now we have a biceps size, which is equal to 12 centimeters. And we are also going to have a boolean of has brain. So has brain, and that one is equal to false. And as you can see, this really looks like a normal object. The only difference is that this is JSON. And the difference between JSON and normal objects is also pretty easy. You just use those quotation marks right here for the keys, which you would not have to use for an object. And the rest stays pretty much the same. And if you talk to a database, so if you send this data, you're going to take this object, you will turn this into JSON data, and then you will send it to the server. If you get it back from the server will send you this JSON object. You can then parse this JSON object the way we've done it previously by, for example, using json.parse. And then you can use it as a normal object again. Let's understand callbacks in JavaScript. Imagine we're having a function that says, for example, greet, and essentially just does something. And we're going to pass a callback to this greet function. So we'll say that right here, we will pass a callback. This here is going to be a function that we'll define later on. And we are just going to execute this callback right here. And we will pass two arguments. We will say Pascal, for example, or let's just use one argument for this simple demo. And we are just going to call this callback with the argument Pascal. So we don't have this function yet. So what we're going to do is we're going to define this function. So we will say function, say hello, for example. We will accept a name right here. This name will be Pascal later on, as you see. And now we are going to say console.log name. So we're just going to console.log our name instead of this callback function, because that function is essentially what we are going to use for our callback right here. This callback will later on be called right here, and we will pass this argument as a parameter to this callback function. So now we're going to say we're going to call greet, and as an argument, we have to insert a callback function, which is say hello in our case. We're going to end that line, and now we're going to run the code. And as you can see, we're getting Pascal in the console. So a callback function is essentially just a function that you call within another function. And if you think about an array of numbers, for example, where you just have a couple of numbers inside of the array, and you're going to loop over those numbers by using the map method, right here you can also see that we're having a callback function. So we are passing a function right here. We are getting one of those numbers every time we loop over those numbers, and then we're going to execute some form of code. So even if you're not going to use callbacks the way I showed it to you, you will oftentimes use callback functions the way we're seeing it right here. So it's important to understand that this right here, for example, is a callback function that will be called back several times by this map function right here. Let's understand promises in JavaScript. So imagine we're going to have a promise that we will create, which is equal to new promise. So we're going to create a new promise object. This promise object will have a callback function that accepts two parameters. One of them is resolve and the other one is reject. We're going to use an error function right here. And let's define a variable that has the name success that is going to be equal to true. And we're going to say if success, so if success is equal to true, then we're going to resolve this one and we're going to say it worked. Otherwise, we're going to say that we're going to reject and it did not work. So now we have a promise. If we have success right here, we're going to resolve the promise. Otherwise, we're going to reject the promise. And this is obviously a very, very simple case. In reality, you usually use promises to fetch data, for example. So now we just created this promise, but we're not really using it right now. So we need to use it. So we can use a promise by saying promise, in our case, dot. Then we can call the then block. The then block will be executed if the promise will be resolved. So let's call that one. Right here, we again need a function. We're going to get a result. The result is what we're getting back from this result function. And now let's just say console.log, and we're going to console.log the result. Now we can also add a catch block right here. So we're essentially chaining methods right here. And instead of the catch block, it's a pretty similar procedure. The difference is that we're not getting a result right here, but we're getting an error right here. And obviously the names are up to you. You could also say that this is a result as well, but the convention is that you call this one error because it's more like an error. And we're just getting this text right here if we're getting an error. So we can also just say console.log, and let's just console.log the error. We're going to save that one. We're going to run the code. And as you can see, we're getting it worked because success is true right now. But this one can also be false. So we're going to run this one again. And now it did not work because success is equal to false. So a promise is just something that says, I will promise you that in the future, you will get a result. And once you get this result, I'm going to get back to you. And I'm either going to resolve the promise and get you the result, or I'm going to reject the promise and I'm going to give you an error message. So last time we took a look at a promise, but why is a promise even useful? And a promise is really useful because you can do a lot of things, especially when working with APIs. So an API is an application programming interface. But what is an application programming interface? So imagine someone, for example, has a lot of data about the weather. So I can make this data available for pretty much everyone who wants to use that data. So if you're having an app, for example, so let's say you're creating this website right here, and you want to use this weather data, then you can talk to this API that maybe someone else has created, or you have created this API, doesn't really matter. And you can say, hey, give me that weather data, for example. Then the API is going to respond, and this API will give you the weather data. So you do a request, and you're getting the data. So a response essentially. So request and response. So this is the request and this is the response, even though this looks, pretty weird. And in the internet, there exists millions or billions of APIs. So maybe someone has an API for weather. Someone might have an API that includes all of the bicep sizes of bodybuilders, what a drawing. And then you can like get the bicep sizes of bodybuilders, for example. And then you could display those values on your website, for example, like so. And that is the purpose of an API. So I think now you can guess that an API is like really, really useful. It can also be pretty useless, and I'll show you a pretty useless API. So we can, for example, search for a random user generator right here. And as you can see, we have this random user generator URL right here. So we can click on this one. And as you can see, we have instructions on how to use this API. And usually when using an API, you get something like a link like this. And you don't have to use this link instead of JavaScript. You can also just say that you're going to paste that link in here. We're going to do this call to the API. And as you can see, we called the API by using this link. And now we're getting back data from the API. So essentially, we're having this results right here that includes a gender, the gender is female, a name, a title, and so on. So we're getting a lot of data by calling this API. And now we can use this data. In our case, the data is completely useless, but sometimes you might maybe want to get useful data like muscle sizes. So how can we get this data instead of JavaScript now? We can use the fetch method right here. We can say that we want to use our URL right here in a pair of strings. And now this returns a promise. So this promise that we've used previously. So once we get the promise, we can use .then. We are going to get a response. And let's say we are just going to console.log our response. And we can also use catch. We're going to get an error and we can just console.log an error. So let's save that one. We're going to run the code. And as you can see, we're getting this object right here, which looks absolutely terrible. And the reason for this is that the response object does not really make too much sense because it includes JSON data and you want to get this JSON data. So in order to get the data, we're going to say response.json. And most of the time when you work with an API, you get JSON data, you want to get this JSON data, so you use this type of syntax. But the point is that response.json, so this method essentially returns another promise. So now we have to use a chain of then methods. So we again have to call then right here, and we only need one point, like so. And in here, we're getting the data. So we can say data, and now let's just console.log our data. We're going to clear our console and let's run our index.js file. And as you can see, now we're getting the data object. And as you can see, we're getting the results field, for example, instead of our data. So maybe we want to get our gender. So first of all, let's log data.results, for example, because this is an object that has the results property. So we can log that one. We're going to clear the console and we're just going to run our file again. As you can see, now we are inside of our results object that again has the gender, for example. So we can say data.results.gender. By doing so, we are going to access the gender property right here. We're going to run the code. And the reason for this not working is that this here is essentially an array. So we're going to access the first element of this array, which is this object. We're going to run that. And now you can see that we're getting male as an output. But obviously this here looks absolutely terrible. So I recommend you to usually just create an index.html file. Then you create a basic template and then you're just going to link your script tag inside of this file right here. So inside of the index file, you're going to open that one with a live server. And now inside of this live server, you can also inspect everything. And right here, you also get the output of female in this case. And now, for example, you could just say, okay, let's log the data right here. And it's a lot better to see the data inside of the console right here compared to the console right here. But that is like just a personal preference. So right here, you can, for example, see the result has info, results, and so on. So you could also access the info, for example. And also I want to say that what you're getting right here is just a normal object. So if you work with that object, it works the normal way. You can access properties by using the dot notation, for example. So if you want to get the info, for example, which is a normal property of this object that you're getting, by converting this JSON data right here to an object, so to this data object. And inside of this data object, you can now access the individual properties right here just by using a normal dot notation, the way you would do it usually when working with objects. So you can, for example, say this object right here has the info property, so you could access this info property by saying data.info. We're going to refresh the page, and as you can see now we're accessing the info. The info again is another object, so it's a nested object. It's an object inside of an object. So if you want to access the seed right here now, again, instead of this data object, instead of this info object, you just have to access the seed property by using the dot notation. You can reload, and you could just say that this here is the seed. And you don't need to use the dot notation. You can also use the bracket notation. But I prefer the dot notation usually, and I think most people do. But I just want to show you, this is just normal work with objects, and these objects that you're getting by using a promise are not different from objects that you're creating yourself when working with JavaScript. So also, every time you call an API, you're fetching data again. And since we're just getting a random user every time we call this API, you will see that we will get a different URL right here, or different seed right here every time we call our server. And we would also get a different gender, a different name every time we call or fetch data from this API. Obviously, if you have something like better data, it shouldn't change too often, I would say. Instead of using a promise, you can also use the modern syntax of async and await. So let's say we are going to create a function that is responsible for fetching data, and instead of this function, we are going to fetch the data. What kind of data are we going to fetch? Let's say we're also going to fetch the random user data. So now we have this API right here. And let's say we want to call the exact same API, which will generate a random user. But if you use the modern syntax of async and await, you need to declare a function as async. By using the async keyword in front of the function keyword, you say this function will be async. Every time you use a fetch, for example, to fetch data from an API, the call is obviously asynchronous. So it takes some time to complete the call. Because if you communicate with an API, you send a request. This request will, for example, be transmitted via your LAN cable or via the air, depending on what kind of device you use. But no matter what you use, transporting this signal takes some time. So you send the signal, request data from the server sends the signal back, and this takes some time again. So in total, you have to wait a little bit until you get a response. The time is not that long, but you have to wait some time. And that is the point. So once you get to this line and you want to fetch the data, it might take a couple of milliseconds, seconds, whatsoever to get the response from this fetch request. So we need to await the response. So by using await, we are saying we have to wait for this response until we can get the data. And now we can say that we want to get the data and store the data instead of this result. So we can say const result is equal to this fetch request. And now let's just console.log this result right here. Now let's also call this function. And now let's run this code right here. And as you can see, we're again getting the entire result. Let's also now delete this data right here. And let's take a look at this inside of our index.html file. So we're getting this response right here. This response again concludes JSON data. So we need to say const data is again equal to result.json because this is JSON data. And as I've said previously, this one here returns a promise as well. So we need to await that one as well. And once we get the data, we can, for example, say that we want to console.log our data. So let's refresh the page. And now we're getting this data. And now we could, for example, access our info.seed if we wanted to, the way we did it before. So info.seed, going to save that one, going to reload the page. And as you can see, we're now getting the seed right here. So this right here is the alternative to using a promise to fetch data, for example. And every time you do something that takes some time, so every time you do something that is asynchronous, you can use async combined with await. Let's understand the strict mode in JavaScript. Imagine we are having a variable x that is equal to 5. And now let's console.log our variable x. We're going to run the code. And as you can see, we're getting 5 in the console. So even though this is not the perfect way to write that statement, we're not getting an error. Because usually we should have a let or a const keyword here. A var keyword is not the recommended way, but would be better than not having anything right here. So how can we prevent this behavior? We can activate strict mode by saying that we want to use strict. We're going to end the statement. we're going to run this code, and as you can see now, we're getting an error. So what strict mode does, it says, be really strict about my syntax, and every time I do something that is not perfect, throw an error. And I know to a lot of you this might seem like something that is unnecessary or tedious, but using strict mode can definitely prevent a lot of errors and can help you to write cleaner code. Let's understand the call stack and the event loop. So imagine we are going to have a couple of console.log statements. So 1, 2, 3, and maybe 4. And we're going to end each of these statements by using a semicolon. And now we are going to run the code. And as you can see, we're seeing 1 first, then 2nd, then 3rd, then 4th. So how does all of this work? So JavaScript is only using one thread. And this means that it is executing the statements sequentially. And it can't execute two things at the same time. It can always only execute one single thing. So it executes this line, goes to the next line, executes this line, goes to the next line, executes this line, goes to the next line. So it does not execute those lines parallel, but one after another. So now let's imagine we're going to have a call right here of set timeout. We're going to wait until a certain time is over, and then we're going to console.log the number 5, for example. And let's say for a timeout, we're going to use 1000 milliseconds, so 1 second. Let's run the code again. And as you can see, we're getting 1, 2, 3, 4, and 5. So even though this line is the third line, it will be executed last. And what is happening here is that JavaScript will execute this code sequentially. But if you have something that could block the code, like a set timeout function, for example, that would block the entire thread for a second, JavaScript will usually pass this task to something else. If you work with a browser, for example, it will give this task to the browser, and the browser will get back to JavaScript once the second is essentially over and say, okay, now you can execute the code. And if you don't work with the browser, it is usually Node.js, for example, that is responsible for doing this. But if you're working with HTML, CSS, and so on, it's the browser. And this is really important because otherwise this line would block the entire code afterwards. And that would obviously be a terrible user experience if you imagine you have like 10 seconds here, for example, and then you would have to wait for 10 seconds to execute the rest of your code. Let's understand scope chain and closure. Let's say we have a function that has the name print, for example, and inside of this function we have the value set, for example, which can be equal to, let's say, 5, for example. Now let's also say instead of this function, we define another function that can be print2, for example. The name doesn't really matter too much. And we're just going to define set once again. So we say this time set is going to be equal to 6. And now let's say console.log, let's log z right here. And we're going to call print2 inside of this function. Now we are going to call print right here, and we're going to run the code. And as you can see, we're getting 6 in the console. And the reason for this is scope chain. So as you know, usually a variable exists within the scope of a function. So in this case, everything right here belongs to the scope of this function, so of the outer function print. And everything right here belongs to the scope of the inner function print2. So now when we want to access the variable set, it works like this. It first takes a look within its own scope and checks whether it has a variable set. If it has a variable set, it is going to use that variable set. If it does not have a variable set, for example, it is going to go one level up and it is going to look here for a variable set. If it has the variable set, it is going to use this variable set. As you can see, now we have 5. If it does not have a variable set, it is going to go one level up. And let's say we have a variable set of 3 right here. We're going to run the code. And if it finds the variable set right here, it will use that one. And it's going to print it out. So right here we have 3. Otherwise, it did not find the variable and we're getting an error. So when accessing a variable, it starts from inner to outer. Now let's take a look at closure. So let's say we're going to have a function that has the name outer, for example. And inside of this function, we define a variable. So let count be equal to 0, for example. And inside of this function, we will return another function. So let's say this is the function inner, for example. And this function just says count plus plus, so increments the count by 1. And we need the function keyword right here. And now we're also going to console.log the count. So now let's say we are going to have const counter, which is equal to outer, like that. And now let's say we're going to call counter, and we're going to call counter once again. Let's run the code. And as you can see, we're getting 1 and we're getting 2. So somehow this inner function, so this function is able to keep track of the count, even though we've defined the count instead of the outer variable. And what is happening here is called closure. So every time you return a function inside of another function, this inner function is able to keep track of the variables defined in the outer function. And I know this can be confusing, and I'm also going to be honest, you barely ever need this. So it's cool if you have heard of it, but it's very unlikely that you need this. Let's understand hoisting and temporal dead zones. Let's imagine we are having a function that could be, say, hi, for example, and instead of the function body, we are going to say that we'll console.log hello, for example. Now, what will happen if we are going to call this function, say hi, right before we declare this function? Let's just try this. We're going to run the code and we're getting hello instead of the console. So this actually seems to work. And the reason for this is hoisting. When you define a function like this, the JavaScript compiler will take this function, place it at the beginning of the file, and execute the code like this. So no matter in what order you define the functions and call them, the function definition will always be hoisted to the top. But what about variables? Let's imagine we are going to console.log a variable x, for example, and we are going to define this variable x and set it to the value of 5. Now let's run this code again. And we're getting undefined. So why are we getting undefined? The reason is that for the variable declared by using the var keyword, the JavaScript compiler is only going to take this var x definition, will put it right here, and afterwards it will assign the value to the variable x right here. So it's only going to hoist the declaration or the initialization of the variable x, but it will not hoist the assignment to the variable x. What would happen if we would use let or const, for example, instead of var? So let's run the code, and as you can see, we're getting an error. Now you might think that the variable x will not get hoisted if you use let and const, and somehow you can think about it like that, but what is really happening that the variable x will be hoisted right here, and the assignment will happen later on, but from this point on to this point on, we have a temporal dead block when we're using let or const. So this essentially means you cannot access that variable before its assignment. But to be honest, I know a lot of people say that this is super important, but in my opinion, it's not really that important. All you have to think about is that you should essentially, when working with JavaScript, define your variables at the top and also assign the value at the top. And while it might not really make a difference whether you define your functions before or after calling them, it's definitely best practice to define the functions before calling them. So if you stick to the conventions, you should definitely not have any problems anyways. So you probably know how to create a function like this. But as you can see, this is a really inconvenient way to add variables and strings together. And imagine you would have maybe another string, for example, and then you have another variable, and you always have to say plus, 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 and you probably don't want to do that. So there's also a better method inside of JavaScript to get the exact same result. So let's use backtick characters like this. And inside of these backtick characters, we can say hello, for example. Then we are going to use a $sign followed by these kind of brackets, and inside of these brackets you can now define or can now use JavaScript variables, like first name, for example. Now you could also go ahead after those brackets and say you are, and now let's say we also want to get an age of the user, age for example, and now we can again use a $sign followed by brackets, age, years old. And as you can see, it's a lot easier, especially if you want to concatenate a lot of variables, to use this kind of syntax. So now let's just greet the user in the console. Let's say we have Jonas, for example, and he is probably 1 year old. And we're going to run the code. And as you can see, hello Jonas, you're 1 year old. Or 1 year old, probably not the best idea, but yeah, as you can see, the logic definitely works. Let's understand modules in JavaScript. First of all, if you use index.html to link your JavaScript file, you will have to say that this script tag has a type module to really declare this as a module. And if you want to have the shortcut, this is pretty simple. You're just going to say script::module. So you automatically define this one as a module, and then you can link your index.js file. And we also need the def attribute here to say this one will be parsed after the entire HTML code. Now inside of our index.js file, this one here is now declared as a module, so we can use this one as a module. So imagine we want to have a function and we want to get this function from another file, for example. So let's say this are helper functions, for example. So this one is the helper.js file. And this one just declares a function that says, say hello, for example, and it's just going to console.log hello in the console. So this is pretty simple. But now we want to use this function instead of this file, for example. So how can we do it? Can we, for example, say import helper? This does not seem to work. So we have to export this function from our helper.js to use it inside of our index.js. To export a function, we can say export function, say hello. Now this function is being exported, and now we can import, say hello from helper. And as you can see, this is the syntax. So you have opening and closing brackets. Then you have the function name inside. You're going to say from what kind of space do you want to import that one? We want to import that one from ./helper. And I recommend to say .js right here. Otherwise, I oftentimes get bugs. And then you can use this function right here. So you can now, for example, say hello. You can call the function right here. So if I'm running this code, you say we're getting an error. And the reason is that I'm executing that one using Node.js, as you can see. And Node.js does not really see that this here is declared as a module by using HTML. So I have to execute this code inside of HTML. I'm going to reload the page, and right here you can see that we're getting hello. So this seems to work. So we have now used this function instead of our index.js file that has been exported from our helper.js file. And now we could also export a lot of functions inside of this file. So we could also say goodbye. That function is just going to console.log by, for example. It doesn't really matter too much. And now we can also say we want to export that function right here. And now we can say goodbye, for example. We also want to call that function. We want to execute that function right here. And this now works as well. So now we're getting hello and bye. So this works. But now we can also export something as a default. So we could, instead of saying export function, say goodbye, we could go down and we could say right here, for example, export default, say goodbye. Now we're going to save that one. And now we can, instead of importing like that, we can say import, say goodbye. And as you can see now, the syntax is slightly different. Instead of using those brackets right here, we're just going to say that we are going to import say goodbye from helper.js without the brackets. And now we can still call it the same way. We can refresh our code and we will get the exact same result. The reason is that now this here is a default export. The reason we do not need brackets here is because we cannot have many default exports right here. So this is not valid. If this would be another function, this would not work. You can only have one single default export for every single file, but you can have as many normal exports per file. So by using this syntax, you can essentially import as many functions as you want. If you do this syntax, you can just import one main function from every single file that you have exported as a default, essentially. So to sum up, if you want to use import and export, you have to declare it as a module. In a lot of frameworks, JavaScript files will by default under the hood be handled as a module. So if you can use import and export over there, this just means that the framework does the work for you of declaring this as a module. So if you ever work with a framework, which you potentially will, this is important to remember. Once it is declared as a module, you can use export to export function. You can use export default to export something as a default. And you can use import to import something. By using brackets, you are importing normal exports. By using import without brackets, you are importing a default export.
What is JavaScript? JavaScript is a programming language that runs directly in the browser. It allows websites to be dynamic and interactive. It works hand in hand with HTML for structure and CSS for design. But what can JavaScript actually do? It can react to user actions like clicks, typing, or scrolling. It can change content and styles dynamically, validate forms, show pop-ups, or even load new data, all without reloading the page. JavaScript is the most widely used language for web development, and every modern browser supports it. Frameworks like React, Vue, and Angular are all built on top of it, and with Node.js, you can even use it on the backend. So in short, JavaScript is what brings your website to life. To understand how JavaScript works on the web, we first need to understand the DOM. When you write HTML code, it looks something like this. But JavaScript doesn't understand HTML directly. It's like HTML speaks German, while JavaScript only speaks English. So how can JavaScript interact with HTML code? The answer is the DOM. You can imagine the DOM as a tree structure that represents the entire HTML document and allows JavaScript to access, add, or manipulate elements. In reality, the DOM is represented as a JavaScript object model provided by the browser. That object contains other objects, each representing another layer of the HTML document. For example, if you want to display a div inside your HTML file, JavaScript can add it directly to the DOM. Every time you change something in the DOM, the browser re-renders that part of the page. So the DOM is what will be displayed inside of the browser. So to sum up, the DOM acts as a bridge between your JavaScript code and your HTML structure, making your website truly interactive.
To get started, let's create a basic index.html file and a basic template by using the exclamation mark. Now let's also create a script.js file, and let's link the script.js file inside of our HTML file in the head. We can link our script file by using script:module. Now we need to define the source, which is script.js, and we need to set the def attribute because we're defining this inside of the head. And if we define the script tag inside of the head, we need to use defer, which tells the parser that this file right here should be parsed after the entire HTML and CSS code has been parsed. So this one should be parsed last. So how can we get a specific HTML element inside of JavaScript? First of all, let's create a div, for example, and we have a little bit of text in there. So how can we get a reference to this div container inside of JavaScript so we can later on, for example, change the content? In order to do so, we first of all can create a variable. This variable will store the reference to our div container in this case. And we can use any name we want to use. We could say div, for example. We could also say that or npc. And in our case, let's just use npc. So you see that actually anything works. We can now say that we want to get a reference to our document dot get element by tag name. And this one is going to be the right method for our purpose because we want to use the tag name to get a reference to this div right here. So we're going to use opening and closing brackets. And now we need to define the tag name. So what is the tag name of this div? The tag name is div. So we are going to say div right here. And now we can console.log npc right here, which is the variable name that we've defined for the reference to our tag name. We're going to go to our browser. You can see this is the text. And right here we have an HTML collection that holds this div right here that has a lot of data that we don't really need right now. And if I'm going to add another div instead of our index.html or two more divs, you will see that we're going to get a bigger HTML collection. So now we have 3 divs instead of this collection. So the HTML tag name is an option, but as you can imagine, it's really hard to get a specific element right here. What if I wanted to get the second element, for example? And in order to do that, we can also use an ID, for example. So let's say we have a little bit of text right here. And now we have an ID, for example, that could be my minus text. Now we can also use this unique ID to fetch this paragraph by saying, for example, const text is going to be equal to document. And now we can use get element by ID. And right in those brackets, we need to define, in quotation marks again, the name of the ID that we've used for our paragraph right here. In our case, it's my minus text, so we're going to save that one. Now let's console.log our text, and you will see that this one works as well. So now we have a reference to our text, as you can see. There also exists the option to get a reference by class name. So now let's say this here is going to have a class of my minus second minus text. Let's copy that one. And now let's say const second text is going to be equal to document dot get element by class name, as you can see. And now we're just going to define, instead of quotation marks again, the class name. So my second text, for example. Let's save that one. Let's console.log our second text. And we are going to see in the console, we have this HTML collection again for our second text. So if we are using a class name, you already saw this one was a collection. So I can also add a lot of paragraphs right here, and our collection will just get bigger and bigger. So by using a class name, we can obviously get a lot of references because a class is not unique, whereas an ID is unique. So if you use an ID, you only get a single element. If you use a class, you can get a lot of elements. And now you can access the individual elements, for example, by using bracket notation and 0, for example, or the index of the element. So this works exactly as you would work with arrays, essentially. And now, as you can see, we're getting my second text right here. So the first one of those elements that has the class my minus second minus text. Now, let me delete all of this and let me show you that you can also use the query selector to achieve the same result by saying, for example, const text is going to be equal to document.querySelector. And as you can see, we have two methods for the query selector. We have query selector and query selector all. So if you only want to get one single element, so the first element that is found within the document that fulfills the requirements, then you're going to use query selector like so. Otherwise, you're going to use query selector all. And I'll show you the difference. If you're going to use query selector, you can access an ID, you can access a class, you can access a tag, and so on. If you want to access an ID, you're going to say hashtag. So we can, for example, say hashtag my minus text. So my minus text. And now let's console.log our text right here. And as you can see, we're getting this text right here in the console. Now we could also say we want to get dot my minus second minus text. So now we're getting a class by using the dot operator. And as you can see, we're getting my minus second minus class, but only one element this time because we used query selector and we did not use query selector all. So let me show you. If we use query selector all, we're getting all of those classes as a node list. So now we could, for example, access an individual text by using the index, for example, like so. So this one here should be the second item that has the index of 1. Now we can also use a tag, for example. So we can just say, let's get a p tag, for example. And again, we're getting this result. And now let me show you that this also outputs a lot of p tags. So I'm going to remove that one. And as you can see, we're again getting a node list. And we can also use query selector, which will only give us the first paragraph. So by using the query selector, you can get a class, an ID, or a tag name, doesn't really matter. If you use the get element by tag name, you can only define a tag name. If you're going to use get element by ID, you have to define an ID. And if you use get element by class name, then you have to define a class to get the element. So all of those methods work. There's not really one method that is the best one. It's in the end more about preference. So how can we change the input of a certain element? Let's, for example, imagine we have this paragraph right here. And this paragraph, for example, has the ID of text. So now we want to have some text input inside of this paragraph. In order to do so, we first need to get this paragraph. We can, for example, create a reference to our paragraph by saying const text is equal to document get element by ID. The ID name is text, so we need to define that one here. And now there are two methods to define text inside of this text element or inside of this paragraph, to be precise. We can, for example, say text dot text content is going to be equal to this is the best course, for example. Now we're going to save that one. And as you can see, now we have this text content in here. So this text inside of this paragraph. The other method would be dot inner HTML. And as you can see, we get the same result. And if I'm going to change that text right here by adding at DSDSA or whatever, we're also getting this effect. So you can see this works as well. So what is the difference between text content and inner HTML? If we're going to use inner HTML, we could also use italic, for example, or other HTML tags right here, and they will be interpreted. So I'm going to show you by using italic right here. And as you can see, now this text right here is italic. So this HTML text will be interpreted. If we're going to use text content though, I'll show you the difference. And as you can see, now we get this I tag right here. So this I tag will not be executed as HTML code. And what is the difference? Text content is a little bit safer and it prevents cross-site scripting, whereas inner HTML obviously allows you to write HTML code inside of your text. But usually I definitely recommend you to use text content. As I already said, this is a lot safer. How can you get and set HTML attributes in JavaScript? Let's imagine we're going to have this link right here, and this one should redirect the user to Google, for example. So let's get the Google link right here, and let's copy and paste that one in here. So this anchor tag should redirect the user to Google. And as you can see, if we're going to click on this link, we're getting redirected to Google. So is there a way to get this attribute, for example? Let's give this element an ID of maybe Google. And now let's get a reference to that element instead of JavaScript by using const. And let's say this here's the link, for example. Now we're going to use document, get element by ID. And we're going to get our Google ID. And now let's, for example, just console.log link.get attribute. And we have to define the name of the attribute. In our case, the attribute name is href. So we want to get the href attribute of our link, which is this anchor link right here. Let's execute that one. And as you can see, we are getting the attribute right here inside of the console. Is there also a way to set a new attribute? And obviously there is. So you can also say link.setAttribute. What kind of attribute do we want to set? Maybe in this case, we want to set the target attribute of our link. So this is the name of the attribute. And right next to the name, we also need to set the value for the attribute. And for our target, we could, for example, say that we want to use underline blank to open the page in a new tab. So we're going to save that one. Now we added for the link, the attribute target is equal to underline blank. So this is equal to doing target being equal to underline blank. So this is the exact same. Now we'll save that one. We are going to click this link. And as you can see, this link opens in a new tab. So we successfully added this attribute. So use the variable name that is a reference to your element, followed by get attribute to get an attribute, or followed by set attribute to set an attribute. Let me show you how you can use JavaScript to dynamically create HTML elements. Imagine we wanted to create an HTML element inside of this body right here. So we can go inside of JavaScript and we can say that we want to create a div. So let's say const div is equal to document.createElement. So you use document.createElement to create a new element. Now inside the brackets, you need to define the tag name. What kind of element do we want to create? Let's say we want to create a div, for example. Now our div would essentially look like this, but it doesn't really have a place and it doesn't really have content yet. So we need to add content first. So let's add some content by saying div.text content is going to be equal to I am a div. We're going to save that one. So now we have this div, and this div also has text content, but this div will not be rendered yet on the HTML page because we're not telling it where it should be rendered. So we can, for example, get a reference to our body inside of our script file. So let's say const body is going to be equal to document get element by tag name, for example. And now let's just get the body. So now we have a reference to this body. And now we want to add our div element that we've created right here to this body element. So to this body. So we're essentially saying add this div to this body. And we can do so by saying body.append like so. And now we want to append an element. What kind of element do we want to append? We want to append our div element. So let's save that one. As you can see, we are not seeing anything because we need to say we want to get the first element from our body element because we said get elements by tag name. We get multiple elements. So this is an array and we need to get the first element right here. And as you can see, now we're getting this div. So to sum up, we are first of all getting the body. This here is going to be an array. We are going to access the first element inside of the array because there only exists a single body. Then we're going to use .append to append an element. We created this div right here, and then we append this div to our body element. And I can also show you in the console what is going on right here. If we go to elements, you can see we have this body right here. We selected this body using JavaScript, and then we said that we want to add this div right here to this body. So we want to append this div to this body, and that is what's going on right here. Now there's also the option to remove an element. So let's, for example, use set timeout. And let's say after a certain amount of time, so let's say, for example, after 5 seconds, we want to use body of 0.remove. We want to remove an element. What kind of element do we want to remove? We want to remove this div right here. So we're going to specify this div right here as well. We're going to reload the page. As you can see, 1, 2, 3, 4, and 5. And now, as you can see, it is gone. So how can we use JavaScript to define styles for HTML elements? Let's imagine we are having this div right here. And let's say this div has an ID of container, for example. Now we want to get this container instead of JavaScript by saying const container is equal to document.get element by ID. And this one has the ID of container. So we're getting the element that has the ID of container. Now we want to style this container by using JavaScript. So we can say container. Now we can use .style, for example. And by using .style, we are saying we want to define or we want to have access to a CSS property. And right here, we have access to a lot of properties. So we can use bottom, for example. We can use left. We can also use background, for example. And in our case, let's say we want to use background. So let's say background is going to be equal to yellow, for example. Let's save that one. And as you can see, we're not seeing anything. And the reason for this is that we need a width and a height to set a background. So we can also say container.style.width is going to be equal to 100 pixels and container.style.height is going to be equal to 100 pixels. Let's save that one. And as you can see, we're getting this yellow square right here. So usually you can just use the reference variable followed by a dot style to access a CSS property, followed by the name of the CSS property. And then you can just use normal CSS code inside of those quotation marks to define a property. Now you can also use JavaScript to add a CSS class or remove a CSS class from an element. So let's, for example, say we create a style.css file, and we're also going to link the style.css file inside of our HTML code, like so. So now all of this code here is valid. And now let's, for example, create a class of blue, for example. So .blue. Now we're going to say that class has a width of 200 pixels, a height of 200 pixels, and a background of blue, for example. So now let's create another div right below. And let's say that div has the ID of blue minus container. Now we can grab this blue container right here instead of our script tag by saying const blue container is equal to document get element by ID. We're going to grab the blue container. And now let's say we wanted to add the class name to this container right here. So we want to add the class blue to this container by using code. And we can do so by saying blue container dot class list dot add. And now we can add the class, for example, blue minus container. Or in our case, actually the class is just blue. So that was my bad. So we have to add the class blue. Now we are ending the statement by using a semicolon. And now we added the class blue to this element right here by using JavaScript. And as you can see, we have this blue container. We can also go ahead and remove this class by using blue container.classlist.remove instead of .add. And we can also define the class in here. And as you can see, now we have removed the class. And something that is important when you work with buttons later on is the toggle method. So you can also say blue container.classlist.toggle, and then you can define the class. And this essentially means if you have a class of blue, you're going to remove this class. But if you don't have a class of blue yet, then you're going to add the class. And this is important if you think about a button click, for example, and if the user clicks on a button and the class does not exist yet, you want to add the class. But if the class exists, you want to remove the class. Let me introduce you to events in JavaScript. And a lot of people think events are super complicated, but essentially they are really, really easy. What is an event? The easiest way to really show you is by just creating a button. And this button will, for example, have a text that is click me, for example. And now this button will also have an ID of BTN, for example. So we'll really keep this one simple. So what would be an event in this case? An event is pretty much anything that is happening on a page. An event can be a click, for example. An event can be you scrolling. An event can you be typing in input. So an event is essentially just anything that you do on the page. So actually an event can be anything. And you can decide which kind of event you want to grab instead of JavaScript and what you want to do when this event occurs. So we could, for example, say, okay, we want to react to a button click. And if we want to do something when a button click occurs, we have to add an event listener. So something listens to this event. Once this event happens, we are listening to the event and we can say, okay, now that this event occurred, we want to do something. In order to listen to an event, to a button event, for example, we first need to get a reference to the button. So we say const btn is equal to document get element by ID. We want to get our button. So now that we have a reference to this button right here, we need to add an event listener to this button because we want to say listen to all of the events that happen or to a specific event that happens for this button. So we can say button.add event listener. Now you have to use opening and closing brackets. This is a method. Instead of this method, you first have to define the type of event that you want to listen to. And there exist a lot of predefined types of events and you just have to remember them essentially. But I'm also going to be honest, the most important event that you'll always use is going to be the click event. So we'll define the event by using opening and closing brackets. And here you can see a lot of events, but you won't really need any of those ones besides a few. So the click event, as I said, is really important. So we can define that we want to listen to a click event for this button, for example. So once the user clicks on this button, we want to do something. What do we want to do? That is the second argument. So this here's the listener. Once the user clicks on a button, we want to execute this callback function right here. And for example, we can just say we want to console.log clicked, for example. And obviously this logic right here can be a lot more complex, but let's just keep it simple to really understand what is going on. And as you can see, if we're going into the console right now, we can say click me And as you can see, this one has been clicked right now. Also, something that's really important, you're also getting an event object every time you're adding an event listener. So you can get this one, but we don't really need it in this case, so I didn't specify it right here. But I just want to make sure that you know that this is possible. And we can also just say that we want to log this event right here once we click on this button. So we can, for example, now click on a button, and as you can see, we're getting this pointer event right here. But in our case, it does not make sense, but for the next thing that we want to do, it might make sense. So maybe we also want to track the user input in an input field. So we are going to say we want to create an input field of type text. This one has an ID, for example, of username. So let's pretend this here is the username. Now we're going to get a reference by saying const username is going to be equal to document.getElement by ID of username. So now we have a reference to our username. And now we want to add an event listener to this username input field. And we want to see what kind of input the user types in there. Or we want to track that. So we say username.add event listener. In this scenario, we maybe want to listen to the input event because the user types in some input. And right here, we can actually say that we want to get the event or the event object, but I'm going to say this one here is E. And this is also a convention, so a lot of people say that this here is just E. And now we can also just say, let's add console.log, and let's just add our E, so our event. Now let's type some stuff in here, and as you can see, we're getting this input event. So now we have a lot of stuff in here. And something that you'll use very, very often is this target property right here. So e.target, for example. And as you can see, you have really a lot of properties in here. But one of the properties that is really important in there is the value property. But let me first of all show you e.target. So we'll access, instead of this object, the target property. And this target object has the value property. So now let's save that one. And now let me type something in. And as you can see, we're getting the value as an output in the console. Let me show you one more event that might be kind of important. So let's, for example, say we create a form of type post. And inside of this form, we are going to have a submit button. So button:submit. And usually when you press a button, so let's just say submit. And usually when you press a button, you will have a reload of the page. So take a look at the top right here. If I'm going to submit right here, you can see we're getting a reload and the page isn't working. So maybe this is something that you don't want to have, because this here is the default behavior of HTML elements. So we're going to grab this form by saying this one has an ID of form, for example. So let's keep it simple. And we're going to say const form is going to be equal to document.getElement by ID of form. Now we are getting our form. We are going to add an event listener by saying form.add event listener. What kind of event do we want to listen to? We want to listen to a submit event because right here the user is submitting data. So we are going to say submit is the event that we're looking for. We are again going to get our event object right here. And now if you want to prevent the default behavior of reloading, for example, you can use e.preventDefault, which is a method, and we'll end that statement by using a semicolon. So now let me show you, once I press the submit button, nothing is happening. So now we could also say right here, console.log, we clicked, and we're going to go in here. And as you can see, we clicked will appear in the console, but we will prevent the default behavior of reloading the page once we submit, essentially. And that is something that is pretty useful, especially if you want to define all of your logic yourself instead of JavaScript, for example. So now we could also say that we want to create an alert, for example, that says, hey, yo, or wayo, doesn't really matter. Now we're going to click, and as you can see, we're getting this alert that has the message wayo, for example. So those are the most important events. I actually never really used a lot more myself. So I think if you know them, you're really good to go. But just keep in mind that there exist a lot more events, and maybe in the future you might need some, and then you can always go and take a look at the documentation. Let's understand setTimeout and setInterval. And those functions are actually super easy. Let's start by using setTimeout, like so. And by using setTimeout, you're executing the method and it accepts a callback function. Inside of those brackets, you can define what you want to do when calling this method. So in our case, let's use a callback function right here. And right after the callback function, you can use a comma separated by a value right here. And this value defines in milliseconds how much time it will take to execute the method body inside of here. By saying 1000 right here, we say wait for 1000 milliseconds, so for 1 second, and after that second, execute the code that you have inside of this body right here. So we can, for example, just say console.log 1 second passed, for example. Let's save that code and let's execute that code by using run code. And as you can see, we're waiting and 1 second passed. Let me show you that this in fact works. I'm going to say this here executes after 2 seconds, and right here I'll say 2 seconds passed, and I'm also going to use 5 seconds so that we really see what is going on right here. So I'm going to execute the code once again, and as you can see, 1 second passed, 2 seconds passed, and 5 seconds passed. So set timeout is pretty simple. You just define what you want to do after a specific time right here. And after a comma, you define a time in milliseconds that you have to wait until you execute the code instead of the body. Set interval is pretty similar. The only difference is that you define an interval and you keep doing whatever you have in your method body forever. So let me show you. We're going to set interval. Again, we take a callback function right here. We can, for example, say console.log getting called every single second. So this line gets called every single second. And right now we also have to define a time, which can be 1 second, for example, in our case, because we want to call this function every single second. But obviously it's up to you what kind of time you're going to define right here. So now let's execute this code. And as you can see, getting called every single second gets called every single second, whereas the set timeout function only gets called 1 single time.
In some cases, you might want to turn an object into a string. And a use case that you will often need is if you want to send data via the internet, or if you want to save data inside of the local storage of a user, for example. And the reason is, for example, if the user, for example, accesses your website like this, then you have the option to, for example, save something inside of the local storage of the user. And the local storage is essentially a storage that sits on the website of the user. So essentially you save the data in the browser of the user. And this can be especially useful if you think about a shopping cart, for example. So imagine we save the amount of items that the user has inside of the shopping cart. Then you maybe want to add the amount of items that the user has added to his cart, for example, to the local storage. So once the user quits the website and revisits the website, he still sees all of the items that he has inside of the cart, because it's obviously not the best user experience if the user quits your page, for example, and everything is gone. And in order to do so, we need to save something inside of the local storage, for example, but we can not save an object like this in the local storage. And in order to save this one, we need to create a string, and we can create this user string, for example, by saying that we want to use JSON.stringify like this, and then we pass our object inside of those brackets. We're going to save this, and now we're going to console.log our user string to really see what's going on here. And this here should be a string right now that we can send to the local storage, for example. Now let's imagine we want to have the original form again. Then we can say user original, for example, is equal to JSON.parse, and let's enter the user string, for example. And now let's also console.log right here our user original, and we will just run this code again. And as you can see, this here is the original one. So we've parsed it and turned it into an object again. And this here is the stringified version. If you want to save the data to the local storage, for example, or send them by the internet, you can first use JSON.stringify. But if you know that you're going to receive one of those strings, you can use JSON.parse to turn them into the original form again. So if you say you want to receive this data and work with this data, then you turn this one into the original form again and can work with it. So you have the original object. And if you want to turn it or send it to the local storage, you can use JSON.stringify to stringify the object, for example. So let's say we've saved the cart of the user, for example. And inside of this cart is essentially an object. We have an amount of items. So let's say he has bought 2 items or has added 2 items to a shopping cart at this point. And let's say this here is the amount. And then let's say the items, for example, are an array, and we have some sneakers in there, for example, and some Jordans. So let's just say this represents a simple shopping cart of a user. And now we somehow want to make sure that once the user enters those items to the shopping cart, leaves the website and comes back to this website, the items are still in the shopping cart. Because it would be a probably pretty bad user experience if all of those items are gone. And we can do so by using the local storage. And let's take a look at the website. Once we inspect this website, we see that we can go to the application tab right here, and we can go to the local storage. And this here is the local storage, and we save key value pairs inside of the local storage. So this local storage is nothing that really has anything to do with a server, but rather is a storage on the PC inside of the browser of the user. So this local storage is not that big, and it belongs to the browser of the user. So every time you want to save info like your shopping cart, for example, this is the way to do it. And especially if you think about a website where you, for example, don't need the user to be logged in, and you don't want to query the database all of the time to get every single detail like the shopping cart, this would be the perfect opportunity to use the local storage. So let's say we want to save those items in local storage. And all I've done is essentially create this index.html, and I've linked our index.js file to this index.html. So we are executing this JavaScript code that we are writing right here inside of the browser. So now let's say we are going to use the local storage, and there are two methods. The first one is set item and the second one is get item. And as the names imply, one is for setting the item in the local storage and the other one is for getting the item from the local storage. So you can say set item, you first pass a key and you second pass a value. So this is the basic structure. So for our key, we could, for example, say, let's call this card items, for example. So I'm not going to name this one card because I want to show you that this is really, that you can really name this whatever you want. And then you have to pass in the value right here. So the value in our case is our card because we want to save our card to the local storage. So let's save this. Let's go inside of our browser. And as you can see now, we already have those card items inside of our saved to our local storage. But as you can see, the value is an object right now. And as I've mentioned in a previous episode, we cannot save an object to the local storage. And in order to save this card to the local storage, we have to turn it into a JSON string. So we are going to say JSON.stringify, and we will pass this object to our JSON.stringify method. So now we're going to save this again. And as you can see, now we can read this value inside of our local storage. We have an amount of 2 and our items right here. Now let's also say we want to get those items from the local storage again and maybe console.log them. So let's now say local storage.get item. And once we want to get an item, we need to use the key. So we can say the key in our case is card minus items because that was the key that we've defined for our set items function. And now let's store those items. Let's say const card items is equal to local storage.get items. So now we can use those card items. So now we want to log those items, let's say in a console, for example. So we can say console.log and let's log our card items. Let's save this one. Let's go to our website and let's switch from our application tab to our console tab right here. And now as you can see, we get this item right here. But if we wanted to read those items inside of our console, we would actually need to use card items inside of a JSON.parse method. So we would have to enter them in here because first of all, we've created a string to save this inside of the local storage. But if we want to use this one as an object again inside of our JavaScript application, we have to parse this JSON string essentially. So let's console.log our card items and the parsed version. And as you can see, this here really looks like an object. The second one, the parsed version, whereas the first one looks like a JSON string. And is all you really need to know to understand the local storage in JavaScript. Let me show you the session storage. If you want to save an item to the session storage, you can use session storage.setItem. We can say that we want to set the username. As you can see, the username is going to be our key. This one is going to be a string. And now we can also say that we want to set a value right here. And let's say our username is Yapro, for example. So we're going to save this one. We can go to the application tab. Right here, you can see that we have the local storage, for example, but we also have the session storage right here. If you open the session storage, you can see that we have the username of Yapro. But nevertheless, what is the difference between the local storage and the session storage? The local storage will consist even if we refresh the page over a long time, while the session storage will get lost once we reload the page, for example, or switch to a different tab and so on. So the session storage is only available for one single session, and one single session goes up to the point where you leave the page or leave the tab. The local storage is usually available for a lot of sessions. So even if you go to a different page, for example, quit this page right here, open the page once again, and so on, you will still have the local storage, whereas the session storage is usually gone at this point.
Let's understand cookies in JavaScript. Cookies are somewhat similar to sessions and the local storage, but they are also different, and understanding the difference is really important. So let's go to the application tab right here. And right here you can see we have, for example, the local storage, we have the session storage, and we also have the cookies right here. So we have the cookies for this URL, for example, as you can see. And now you can also clear the cookies. Now they're all gone. And as I've already mentioned, the local storage will be stored inside of the browser and will persist over many sessions. So even after reloading the session, the local storage will be there. The session, as the name implies, will persist over one single session. So every time you reload the page, for example, or go to a new tab, the session will be cleared. Cookies, on the other hand, can also persist over many sessions, but the difference is that every time you send a request to your server, for example, and get a response, you also add this cookie to the request. So this is really good to authenticate the user, for example. So you can, for example, store a user ID inside of this cookie. You can send the request. If you want to get data, for example, the cookie will be automatically sent with this request. The server will see, okay, we have the user ID. So this is a valid user right now that is logged in, and I can reply with the data, for example. And it's also important to understand that usually if you want to save a user ID, for example, as a cookie, you don't do that via JavaScript because that is something that should be handled using PHP. But you can also set data using JavaScript inside of a cookie, and that should obviously be data that is not that important, not that relevant. So we can set a cookie by saying document.cookie. Now we can set this to a string, for example. Right here, we can, for example, say that a monkey is equal to ayo. Now we can use a semicolon. Right here we also need to set an expiration date. So we can say expires is equal to, and right here we need to have a pretty long timestamp. And I actually can't really remember the syntax, and I don't recommend you to do this. So you can actually just generate a new date. So you can say const date is equal to new date. So we're going to create a date object. Now we can say date dot set date. We're going to set a date. We're going to say date dot get date. We're going to get the date of our date object that consists the current date. And now we can say, for example, that we want to add 7 to that date. So by using the syntax, we're saying add 7 days to the current date. So this date will be 7 days in the future right now. And now we can insert our variable right here into the string by using this syntax. And we can say date dot to UTC string, which will convert this string to the perfect format that we're going to need for this expires field right here. Now we also need to define a path, and that one can be equal to a slash, which means this cookie is valid for the entire website. Now let's save that one. We can go into the browser, we can refresh the page. Now as you can see, we have this cookie that has a key or a name of monkey and a value of AO. If we want to get this cookie, we can, for example, say, let's console.log this cookie by saying document.cookie. So setting the cookie and getting the cookie has the exact same syntax right here. Let's go to our console. And as you can see, we are right here at the top getting monkey is equal to AO. If you wanted to delete the cookie, we could just go ahead, copy that line, for example, paste it in here. Now we can also update the date. So let's say we're going to use a different date. We're going to say date.setDate is date.getDate plus 7. Instead of plus 7, we are going to say minus 7, for example. This does not need to be minus 7, but it needs to be any point in the past. Because if a cookie expires in the past, it will be deleted. So we're going to do that one. We're going to set the cookie once again. And now let me console.log document.cookie right again. And this here should be the deleted cookie. So I'm going to add that one as well. We're going to console.log that. We're going to reload our page. And as you can see, we're only getting the line deleted cookie, but we're not getting any information right after because the cookie is now deleted. We can also take a look at this in the application tab. If we take a look at the cookies tab, we are not having any cookies anymore because the cookie is deleted. Let me introduce you to the window, document, navigator, and location object. In order to do so, I think it makes sense to console.log our window object. Now let's go into the browser, inspect, and in the console we can see that we're getting this window object right here, which includes a lot of stuff. It includes the history, it includes the document, it includes alert, and so on. So the window document is essentially what represents your window. And this window object includes everything. So we could, for example, say, let's get window.innerHeight. And by doing so, we will get the inner height, so the height of this window right here. And as you can see, the height right now is 910 pixels. We can also get the inner width, for example. So let's save that one. And as you can see, the width is 1331 pixels. If I'm going to make this one a little bit smaller by making the console bigger, and I'm going to reload, you can see now it only has a width of 1143 pixels. So this might be kind of useful from time to time. Now you also have the document object. As you can see, let's log that one. We have this document object right here, which you also use pretty often, if you remember, by saying document.getElementById. So you can use that one, for example, to get elements from the DOM by their ID, for example, by their class name, by their tag name, and so on. So this is pretty useful about the document. You can also say that you want to add an event listener, for example, to the document. Let's listen to click events. And we're going to console.log clicked once we clicked the document. So let's see what is the document. I'm going to click in here, and as you can see, pretty much everything is the document. So the document represents your HTML website. So the window includes everything. The document includes your HTML website. Now let's use the navigator. The navigator gives you a lot of information about connection, for example, about the device, and so on. In my opinion, it's not that important, but I want to show it to you very quick. So you can, for example, say navigator.online, and now we can just console.log that one. So you see what is going on right here. And as you can see, we're getting true inside of the console. What is navigator.online for? This one checks whether you have an internet connection right now. If you have an internet connection, this will return true, otherwise it will return false. And now let me also show you the location object. So first of all, let's console.log location, for example, .href, and let's go into the browser. And as you can see, we're getting this website right here. So we're getting the current URL. So location in general is an object that includes information about the current location, as you can see, and you can, for example, access the host name, the host, the path name, the port, and so on. But most of the time you want to use href because that is the complete path to your current page. So if you wanted to change the page, for example, you could say location.href is going to be equal, and now we can say slash, which means we're going to use the default host right here. And after the host, we want to say contact.html, for example. So once we get to the index.html page, we are loading this script.js file right here. Once we load the script.js file, we're saying, okay, now navigate the user to our /contact.html page. I'm going to reload the page. And once I go into the browser, you can see that we cannot get the contact.html file because we don't have that file now. But if you take a look at the URL, you see that this in fact did work because we now navigated to our contact.html URL. And if we would have a contact.html, like so, for example, and I would say wayo, for example, or whatever, you can see that this one works. Now, if I'm going to go to our index.html file, I get redirected to our contact.html immediately because we run the script file. Let me introduce you to alert, prompt, and confirm. Let's start by using confirm, for example. So I'm going to say confirm, are you above 18, for example. I'm going to save that one. Let's load our index.html file right here. As you can see, once we get to the index.html file, we are getting this notification that asks whether I'm above 18 or not. So let's press OK right here. And as you can see, the notification disappeared. But maybe we want to get that value. So we can, for example, say const age is equal to this confirm message. And now just console.log the age value to see how this one looks. So we're going to press OK. And as you can see, we're now getting true. So you could use this one, for example, to check whether the user is 18. If he isn't 18, you can deny access to the page. And if he is 18, you can grant access to the page. So this would be a possible scenario. Now, there also exists the prompt mechanism, like so. And now you can, for example, ask, what is your name? And in this case, username might be a more descriptive variable name. So let's do that. And as you can see, we get this input right here where we can enter a name, for example. So I can say I'm Peter, for example. I saved that one, and as you can see, nothing really happened. But let's console.log our username to see whether we really got this value right here. Username, like so. And Let's say I'm an NPC, for example. And now, as you can see, we're getting this value right here. So can we use this value now? Obviously we can, but we could also use it with an alert, for example. So let's now test an alert and say, hello. And now we're going to add our username that we've just gotten by using this prompt right here. So we're getting this prompt. We can say I'm an NPC. I'm going to press OK. And now we're getting this alert right here, which says hello NPC. So the first one was a prompt and the second one was an alert. Let me introduce you to the history in JavaScript. Imagine we are having this HTML file and we have an H1 right here, for example, that says this is, or that just says home, for example. And now we also have two more pages like a contact.html and an about.html. Let's create a basic template and let's say this one here is about and this one here is our contact, like so. And now let's also create a short navigation bar. So we have an anchor right here that redirects the user to our home or index.html file. This here is home. Let's duplicate that one. This here is going to be contact and this here is going to be about. Doesn't really matter too much though. So this is contact and this is about. And now let's just copy those anchor tags right here and paste them on our about page and on our index.html page. And as you can see, now we have this navigation. We have home, contact, and about. And about somehow does not seem to have the anchors for whatever. Okay, now it works. So now maybe we want to use JavaScript to navigate on our page. So we can, for example, say on our index.html file, let's create a button that has the ID button, for example. And that one says, click me. We're going to get this button inside of JavaScript by using const btn is equal to document get element by ID btn. And now we want to do something once the user clicks on this button. How can we do something? We are going to add an event listener. We are going to listen to the click event. Once the user clicks on the button, let's for example say we just want to log our history because that is ultimately what we need to redirect the user on a button click. So let's first take a look at that. Let's go to our homepage. We have this button right here. And as you can see, now we're getting this history object right here. And you can see we have a lot of properties right here, like back, forward, go, push state, replace state, and so on. And the most important ones, in my opinion, are back, forward, and go. And as the names imply, back goes backward, forward goes forward, and go allows you to be more precise. For example, if we click this button, let's say we want to use history.back. So we're getting back to the previous page that we visited. So we're going to go to contact. From contact, let's go back to home. So now our previous page was contact. We're going to click this button. And as you can see, we are getting redirected to the contact page. Now let's use forward, for example. And forward is a little bit tricky. So let me show you. We're going to contact, home, click me, nothing happens. Why doesn't anything happen? Well, because this is our newest page, since we never went back. So we have to go back in order to be able to use this button right here to jump forward. So now let's test that. Let's go from our home page to our contact page. Now let's go backward. So now we went back to our home page and the next page would again be our contact page because that was the page where we pressed back. So now let's click this button and we're getting redirected to the contact page. Also, if we would go to the home page, go to about, then we're going back. We're now again on the home page, but we press the back button on the about page. So that one would be the page if we go forward. So let's click that button. And as you can see, we're now on the about page. And now you can also use go, for example. And go is pretty simple. You just enter a value, so a number. Do you want to go forward? Maybe want to go one page forward, then we use 1. Maybe want to go one page backward, then we use -1. Maybe want to go 2 pages backwards, then we use -2, for example. So this is really simple. Now let's test that one. Let's click on contact. Let's click on about and let's go to home, click me. And as you can see, we're landing on the contact page. Why the contact page? Because that was the page where we have been 2 clicks ago. So let me show you. We're starting at the home page. First click, contact page. Second click, about us page. Third click, home page. So if I'm going to click right here now, we're going to go 1 level back, about, 2 levels back, contact. So we should land on a contact page. And as you can see, we land on a contact page.